विपुल सर, અહીંયા ખાલી રેકોર્ડિંગ સ્ટાર્ટ કરજો, હું કહું ત્યારે. ગુડ મોર્નિંગ ગુપ્તા સર.
Good morning.
Good morning, sir.
Good morning.
Sorry, from my side there is some network issue, and therefore I was left this meeting.
Okay, okay.
Can we start, sir?
Yeah, I am ready.
Okay. Good morning to all the participants. For today's first session, we have Dr. Ramesh Gupta, sir, Associate Professor, Mechanical Department, Shiv Nadar University, Delhi NCR. Dr. Gupta got his PhD degree from IISc Bangalore. Dr. Gupta has keen interest, research interest in computational mechanics, nonlinear material model, auxetic structure, linear and nonlinear finite element analysis, multibody dynamics, multifunctional smart composite structures, and 3D printing. Sir has also about 11 years of industrial experience and more than 9 years of teaching experience. Sir has a reviewership of more than 7 international reputed journals. Sir has more than 15 international SCI journal papers, 2 book chapters, 2 technical reports, and more than 26 international and national conference papers. Sir is the author of an upcoming book called Dielectric Hyperelastic Cell. Sir has 3 patents in their credit. Sir has research projects of about 78 lakhs. Sir has guided about 3 PhD students. On behalf of entire FDP committee, Department of Mechanical Engineering and GEC Bharuch, I humbly welcome you, sir, for delivering an expert lecture in our FDP. Welcome, sir.
Thanks a lot. Is it my audio is clear?
Yes, sir.
Okay. Let me share my screen. My slides are visible, and is it moving?
Yes, sir. Perfectly all right.
Yeah. All right. So let's start the session. And thanks. First of all, I would like to thank the organizer for giving me this opportunity. And it is a very warm welcome to all of you for attending my session in the morning 10 o'clock. And the title is given to me is finite elements and boundary conditions. I'd like to see that it's a kind of applications oriented and some mathematical relevances I will try to cover up. Before that, I would like to introduce myself as Ramesh Gupta. I am Associate Professor in Mechanical Engineering Department of Shivnadar University, and also I am heading one new center called SDC, which is nothing but SNU Dassault Systems Center of Excellence. So with that small introduction about myself and the topic, what I am going to talk, many of the people may not be aware of our university. So I just thought of giving some kind of a snapshot about our university. So if you look at it is a very recent establishment in 2011, where our university is established by the philanthropist, HCL founder, and he is also currently the chancellor of our university, Mr. Shivnadar. So we have 286 acres of green campus, and we have the people, students ranging from undergraduate, graduate, and PhD, and around 2000 plus, and faculties of around 200. All faculties are came from well reputed organizations, and I'm happy to inform you that our university got very recently Institute of Eminence accreditation, and also we have 5 schools. The major one is in engineering, followed by management, sciences, and humanities. Very recently we started with extended education as well. Now you can see how green campus ours is. It's very near to Delhi and National Capital Region, NCR stands for. So it is very closer to Greater Noida, Delhi, Greater Noida. And one important thing I'd like to mention, because many of the participants are from the academic background having the faculties. So it's very important to inform, like our PhD program is very highlighted, where we are offering a scholarship of 50,000 per month, as well as the accommodation. And at the same time, for a MTech as well as for a BTech also, we are providing scholarship. With this small snapshot, let's move on to the presentation part. So what I'd like to give some kind of an overview or the context about these finite elements and its implementation, and then I'll briefly talk about some of the aspects in terms of the finite elements. What are the various types of the elements we have, and how do you characterize them, and what kind of applications we can think of, and then I will try to cover up in terms of the quadrature schemes. So basically, you have the stiffness matrix and you need to evaluate that. So in order to evaluate such a stiffness matrix elements, you can go for a definite integration, but an alternative way we can think of as a numerical scheme. That is where we can use Gauss quadrature scheme. And then I'll try to see how well these finite elements and Gauss quadrature can be integrated together. And I'll like to illustrate that with a simple example in terms of the beam problem. And then I'll talk about very specifically about various boundary conditions, how that will be physically, how the structure is going to experience under different fields of a study, and then we'll try to see what kind of future directions in terms of conclusions. So this is an overall view of the contents of my presentation, and please feel free to interrupt me any point of time if you have any doubts or clarifications or suggestions. Anything is acceptable. So let's begin with the very fundamental quantities, or the basic, what are the basic ingredients of a structural analysis if you look at. So I would like to bring it to your notice. Maybe I'll use the laser pointer so that it will be very pointed kind of a direction. So if you look at what are the basic ingredients, whenever you do the structural analysis, as you already may be familiar with some of the commercial softwares as well as some of the introductory lectures what you come across. So I'd like to put it as a summary over here, one in the form of 4 quadrants. One is the geometry, very important aspect. Any structural element, it should be consist of some geometry, whether it is bar or a beam or a plate or any kind of one. It should possess some length, some width, some depth, or it may be some kind of a radius and you have some thickness. So depending on the type of the geometry, you can have all these geometric parameters. Now, the other important aspect is material. Now, all the structural members is made up of some material. So that is where the material is another important aspect what we need to look at as an input. Truly speaking, these are all required for your structural analysis. That will be part of what you can think of as a pre-processor, what you look at as a finite element context, where you have the pre-processor, where you need to provide the input. So that input will be either in terms of not either, it is a combination of all the geometry, material, loads and boundary conditions you need to provide. And here I would like to bring it the other quadrant where you need to look at as a loads. So when it comes to the loads, it is not necessary to be a mechanical loads what we conventionally have, a point load, uniformly distributed or uniformly varying kind of a loads, but also you have the other fields. For example, you are working on thermal domain or electrical, or even you are looking for a magnetic field. So you are going to your structure is going to experience either individual field, or it may be combination of multi-physics problem where you have multiple load conditions are coming onto the structure. And the last one is the boundary condition, which are, even if you look at very simple differential equation, in order to solve that, you need to have, you will integrate and then you have integration constants and you need to solve by using a boundary condition. That is where we come across. That is where we come across as a boundary value problem. So if you look at the boundary condition, it may be a mechanical kind of one where I just showed about 3 set of like a fixed, hinged or roller kind of one, but it's eventually depending on the field what you are looking for. Based on that loads, you are based on the physics of the problem, you are going to have the boundary conditions. So I'd like to take it a little further to demonstrate how these varieties of the finite elements we have and what it exactly representing in a structural elements point of view. So if you look at in nature, all the structures, whether whatever the kind of application you think of, whether it is an aircraft or some a automobile or a car or a bus or any kind of automobile, even to the biomechanics or any field, every structural element, it is consists of a 3 dimensions in a very basic level. If you talk about, that means it is having the length, it is having the width and the height. I mean, geometry is I'm given as an illustration purpose as a cube, but eventually you can have different kind of, it may be sphere, it can be this kind of one, whatever. So but basically it is a 3-dimensional entity. Now this is where we have the catch over here. That means we are going to analyze these kind of structures which are 3-dimensional in nature as either 1-dimensional element or 2-dimensional element. Now, what exactly I mean to say is called as dimensionally reducible structures. So I'm introducing a new terminology, which is the dimensionally reducible structures. When you look at a beam, let's say having the length L and the width is B and the height is H. Now, but you need to pay attention on the relativeness of each other. For example, if you look at the length is much more large as compared to your width and height. That is where we are integrating the cross section. Let's say you are taking the CG as a point in the cross section, and collection of those points together, you are forming a line. That is where your three-dimensional body or your three-dimensional structural element, which is a beam, has been modeled as a 1D. That is where it is just like a line. So you may come across strength of materials and many places where if somebody asks to draw the beam and bending moment diagram, shear force diagram, or you need to draw the stress diagram. So what exactly you will do? You will just draw a line. But where exactly the cross section happened? The cross section is embedded, or you are integrating that cross sectional features, or you are incorporating those cross sectional features to a representative point, and collection of those points are leading to your beam. Now, in a similar way, now we'll look at another class of the structural elements. For example, you have the shells or plates kind of a structures, where if you look at the thickness, which is very, very small as compared to its planar dimensions, let's say length and width. So that is where you are again, instead of modeling, instead of analyzing as a three-dimensional plate or a shell, you are representing you are analyzing a mid surface. Usually the reference surface we usually taken as a mid surface, and you can just think of which is exactly mid surface of this. Just think of as you have the book consists of various pages, and the total book is think as a plate, and the mid page you can think of as a surface, and that is where the 2D representation of your actual structure, which is 3D, where we can have the plates or a shell kind of one. So why it is so important over here, and why do we need to look at this dimensionally reducible structures? Because if you look at in finite element analysis, you have number of elements. If I am able to model any structure using the solid element, then why we are having the beam elements, plate elements, shell elements, or link elements, bar element? So we have different varieties of the elements. Then the very simple answer is the computational cost involved. Let's say if I want to model this, then the kind of a computational cost involved is, you just think of as a beam. If I made it into number of elements, which is also called as subdomains, then how much computational cost involved? Whereas if I made it as a simple line elements, just to think of, let's say I made this beam as a 10 elements. Whereas if I want to model this as a 10, let's say a brick element or a tetrahedral element, how many number of nodes I need to solve, or how many degree of freedom I need to solve, and what kind of a computational cost involved is tremendous. Now that is where we are having varieties of the elements, whether even if you look at especially plates and shells, still people are working on to get a much better representation, especially for a composite material, functionally graded materials, or sandwich kind of a structures, multifunctional composite structures. People are even keep on developing the elements in order to fit the theory which will able to represent your actual 3D structure. Some may be using the very fundamental displacement. Some may be going beyond, let's say somebody looking for a simple linear analysis. Somebody may be looking forward for a geometrically nonlinear or material nonlinear or combined nonlinear, where your physics of the problem or the theory what you are looking forward is different from one to another. So that is where if you look at the finite element literature, you're still, even if you open any kind of a repository of Science Direct or, Springer or any Wiley, you still get a latest publications in terms of the plates and shell theories. So with that small need, or what you call, there is a fundamentally different kinds of elements what we are getting from the geometry. Now I'll be looking at another important aspect is the material. Now we have the very basic basic type of the materials, let's say metals kind of one, where you have isotropic materials, where the material properties are same in all directions, where you just need to provide only Young's modulus and Poisson's ratio as a independent parameters so that you can able to solve the problem. But on the other extreme end, where you have anisotropic materials, where you have 21 constants is required in order to analyze such kind of a material, especially if you look at composite materials which will exhibit anisotropic properties, which are having, there is no symmetry, the properties are different in all directions. So that is where you have a class of anisotropic material. Truly speaking, in nature, all the materials are anisotropic, but to the best possible extent, we'll try to see that how well we can modelize isotropic or an intermediate one, which call it as orthotropic material, where we can find some kind of a symmetric planes, three mutually perpendicular planes of symmetry exist. That is where you have the mechanical, your properties or the material is defined by 9 independent constants. So that is where you have one extreme end, isotropic material, very basic, another extreme end, anisotropic material, and in between you can have orthotropic materials. So this is where you, based on the type of the material what you are modeling, you can have either of them or even a subset of another set of the materials what you can look for. Now I would like to look at a very basic fundamental quantity, which is another one is the loads. So when you look at mechanical loads, I'll start with very basic, which is represented by the force newtons, and there is a uniformly distributed load which is spread over the line or along the length dimensions, Newton per meter, and there is one more variety of the load, which is the pressure per unit area or force per unit area what we have. So you can have Newton point load, Newton per meter uniformly distributed load, pressure Newton per meter square, and then you can have self weight kind of a, where it is the Newton per meter cube kind of one. So these are all kind of mechanical loads. In an equivalent way, I'll show you analogous quantities where we can have an equivalent quantities in terms of other fields as well. Now, when it comes to boundary conditions, you have the fixed end where the degrees of freedom, if you are, or the rotations and displacements are fixed, where you have the vertical displacement and rotation is arrested, and you have only vertical displacement is arrested, or the normal to the surface where it is being supported is arrested. When it comes to boundary condition in literature, you will come across the two varieties of the representation, where we can come across as Dirichlet boundary conditions, or which is also called as essential boundary conditions. Now, that means you are specifying the displacements. When I am using the displacement, it is equally applicable for rotations also. When I am referring to force, it is also equally refers to moments as well. So another set of the boundary condition, which we call it as natural boundary conditions or Newman boundary conditions, especially mathematics. Whenever you look at papers or books from the mathematics background, they will be using this kind of terminology where Dirichlet boundary conditions or Newman boundary condition. When you look at from the engineering context, where the people uses like a displacement boundary conditions or force boundary conditions in a engineering oriented. So either of the way, I just thought of introducing all of the varieties where people come across, and that is where we can have two varieties of the boundary conditions. Even if you minimize the functional, let's say you minimize the potential energy functional, one set of if you first minimization will leads to a set of governing differential equations, and others is the boundary condition. Among those boundary condition, one is the essential, another is natural boundary condition. So people uses in a different context. So I'm just illustrating in all possible manner so that you feel like I have already come across this kind of one. Then before I would like to move on, I'd like to introduce three fundamental quantities. If you refer to especially Jane Reddy textbook or his papers, you will find these three terminologies very commonly. What exactly all these? Just to look at, one is the kinematics, second one is constitutive law, and the third is equilibrium equations. So these are the three fundamental quantity equations which relating four fundamental quantities. So if you look at what exactly these four quantities and how these are related to each other. So if you look at, just take an example of, for example, you have a cantilever beam subjected to point load, and you want to find out what is the displacement for corresponding to that load. So for a given force, you need to find out the displacement, or in a reverse way, where you have displacement control formulation, or you are applying the displacement and you want to find out what are the reactions or the forces. So this is the problem in nature. Whereas you have the two virtual quantities, that means imaginary quantities. One is the strain, another is stress. Now these are the virtual quantities, whereas your force and displacements are real in nature. That means I am applying 10 newtons of force. I am getting 3 mm displacement. So you can measure it, you can feel it. Whereas the strain and stress are the intermediate quantities which are relating the forces and displacement. So that is where you have the first fundamental equations in terms of the constitutive law, or the stress strain relationship, which is relating the strains and stresses. There is another set of the quantities or equations which we call it as kinematics, where it is relating the displacement and strain. For example, we will look at very simple case, and it will be more illustrative how these quantities are connected to each other, how these three set of equations will lead to a solution. For example, when it comes to equilibrium equations, which relating the stresses and forces. So what exactly it is going to do is, once you apply the force through this set of three equations which are connecting one to another, forces are connected to stresses, stresses are connected through constitutive law to strain, strains are connected to displacements through the kinematics. So I'd like to illustrate that with a very simple example. Just look at here. You have the cantilever beam, and it is subjected to a point load P. Now I want to find out, corresponding to this load, what is the displacement I can able to get. So that is what the question in our hand. Now it is made up of certain material having the Young's modulus E, Poisson's ratio nu, and the area, cross-sectional area is A, and the length is L. So again, I would like to emphasize the four quadrants. So where you have the geometry, length, and cross-sectional area, the material, Young's modulus, Poisson's ratio, the loads, the force P, and the boundary condition which is fixed at another end. So what we studied, or what we look at in the previous slide, I can bring it over to here. And now I'll like to introduce these fundamental equations. For example, the kinematics, let's say gamma, what I am representing, because I am working in the nonlinear regime, so that this is the usual representation what I use. But very traditionally, let's say epsilon x, which is the change in length by original length. Then stress by strain is Young's modulus. That is nothing but your constitutive law in one dimensionality. And the equilibrium equation is nothing but the stress is equal to force per unit area. Now, the question in our hand is, what is the relation between P and the delta? Now you can start from any equations to anywhere. Finally, you will end up the relation which is relating delta is equal to PL by AE. So this is the very standard formula what you can get it from the combining these three set of equations, you can able to get this one. So now the point comes, is it really that convenient, or is it possible for all the cases? The answer is no, because we have for example, in case of a 3D, you have 15 set of equations. For example, you have 6 kinematics, 6 constitutive law, and 3 equilibrium equations. That means in total you have 15 equations and 15 unknowns. Mathematically it is fine, but where the problem lies, you have the integral differential equations which need to be solved very rigorously. That is where the problem lies. So there comes the numerical technique in terms of, for example, finite difference method, finite element method, or some other kind of a method where you can able to integrate these set of equations so that for a given load, what is the displacement, or for a given displacement, what is the load kind of one. So fundamentally, these set of quantities you are looking forward, and try to see that how these quantities are related. How do you able to solve this? The analytical method, very simple case I shown, but it is not possible, or it may be very difficult in case of especially nonlinear kind of a situations, or combined nonlinear or multi-physics problems where coupling is taking place. So it will be very difficult to solve analytically such equations where we need to resort to numerical techniques, and that is where the finite element method is one of the versatile and and one of the best kind of procedure what we can think of. So with this small background about why and where we can apply the finite element method, I would like to illustrate about the analogous quantities. So maybe first you please pay attention on the table which is on the right hand side, which I already described many quantities over here. When it comes to the structural analysis, usually the unknowns are displacements. Let's say I am going for a displacement based formulation. Our unknowns are displacements. Then you have the gradients. It is a kind of change in length by original length, which we call it as the strains. That is where we represent the units, unitless quantities, because it is meter by meter, and the usual representation as epsilon. So you try to look at what is the physical quantity, what is the unit, and what is the usual symbol. It is not unique, and it is not this is the only way, but this is also possible representation what we can generally find. The next quantity is the flux, or the force per unit area, which we call it as the stress, which is denoted by sigma Newton per meter square. Then you have these, please don't worry about the terminology, which is actually, in order to relate one analysis with another, it is a little deviated kind of one. But if once you familiarize, once you got a feel of what exactly these quantities, later you will say that these finite element softwares, truly speaking, making money oriented, or I can say, I would like to talk about more in a very detailed way how your single program, what you made for structural analysis, which is equally good, or which is equally able to solve your thermal analysis or a flow field problem or some other kind of one. Yeah, you believe or not, is basically internally it is able to solve set of differential equation. Now, what are those equations? Let's say one Laplace equation or a Poisson's equation, and you are trying to solve. but the quantities, what it is going as an input, or the what is the unknown quantity, what is the input quantity, will be varying from one field of analysis to another one. So I'm going to talk about now. Look at here. The first is the displacement. Then you have the strains. Then you have the stresses. Then you have the input, which is in the form of force. Either it may be point force, line force, area based, or the volume like a self weight. And this is where we have the applied force. Then you have the restraints. Restraints means constraints. For example, what you more familiarized, where you can specify the displacements or rotations, and then you are going to find out what are the reaction forces. And then it is made up of certain material where you need to provide these material properties, and that has to follow some material law. For a linear elastic, I am talking about here Hooke's law, where stress is directly proportional to strain. It may not be valid for plastic and other regimes, but a very linear elastic zone, it is applicable. Now, I would like to illustrate, or I would like to have analogous quantities where you have the, let's say I have the code for structural analysis. Can I make use of this for even thermal analysis? The straightforward answer is yes. So that is where I'd like to bring it to your notice. It's not just limiting to again thermal. Even if you go to another field, let's say electrical or some other kind of one, these will be remain same. So what exactly here the unknown? Let's say temperatures, and the temperature gradients are just like a strains. And you have a stress there, you have heat flux, which is again per unit area measures, and you have the source, let us say either heat source, which is a point based, line based, surface or a volumetric kind of one. And then you have the specified temperatures where you are specifying over the domain. Then you have the reaction flows, heat flow you can measure. And you can have the material property, just like you have elastic modulus, you have thermal conductivity, and it is following the Fourier's law. So even if whether you observed or not for some time or not, whenever you are working with any finite element analysis, people always say that you have to be consistent with the units. You have to be, you should know what input you are giving. That means what the basic governing equations it is solving. Let's say in your terms it may be displacement, the derivative terms may be strains, then the stress you are calculating, but internally it is trying to look at let's say nodal temperatures or the temperature gradients or heat flux. So this is where the analogous quantities will help you to figure out one set of program. If you make out, that can be utilized in many ways. Then I'll like to introduce one particular case, because we have a very good understanding about now analogous quantities. Maybe I'll illustrate with some heat conduction problem where the temperature is a kind of a case. Now the problem in statement, usually we can have, let's say I want to find out what is the temperature distribution in this bar, or what is the temperature distribution in this wall. Now we can model the physical problem. Let's say this is my wall, some wall, and I want to find out what is the temperature distribution in this when I have given some heat source, and I have I want to see how much it is based on the thermal conductivity, how much it is the distribution is happening from one end to another. This is the physical problem in hand. Now the very engineers very smartly what they will do, they will first take the assumptions, make it more convenient and relevant. Not only convenient, but it is more relevant, so that you will make assumptions saying that it is one dimensional. Why it is one dimensional? Because you are looking forward only the variation of the temperature in one direction, whereas the cross sectionally there is no variation. That is what the meaning. Then the steady state, there is no variation with respect to time, whether you measure today, tomorrow, anytime, it is the kind of one. It is the, or at least at that particular instance of time, what you are looking is in the steady state, and it is not varying with respect to time. And then there is a thermal conductivity which is constant in all directions. Just like you have isotropic material where the Young's modulus is same in all directions. Similarly, your thermal conductivity is constant. Now, based on these assumptions, we are reducing your physical problem to a tractable, or where we can able to minimize your efforts, and at the same time, physics of the problem is not losing. We just need to find out what is the temperature distribution in the bar. Now, that is where you will apply the physical principles. So, for example, conservation of energy is applied over here, and we are trying to see how exactly this output, that is the temperature distribution, we can find out. Then comes the mathematical model. Now you have physics in hand. Now you come to the mathematical model that will represent your actual the physics of the problem. Let's say conservation of energy or some other governing differential equations which represent physical principle that need to be represented in the mathematical fashion. So that is where now you take approximations in terms of control volume and other kind of things. I may not get into more details because this is the course which I offer as part of the 6 months course. So most of the slides are extracted from there. So it is a very detailed way some of the slides are, but wherever it is possible, I'll try to curtail, and wherever it is required, I'll try to continue the same. So where, if you look at by applying that principle on the control volume, let's say I have taken very small elemental volume, which is having the dimensions of delta X, delta Y, and delta Z. So on that, let's say there is a flow coming in, there is a heat generation, whether it is zero or non-zero, let's look at, but this is where you have an input, you have the heat generation is equal to what is coming out as a heat flow out, what is coming out. Now, it's basically like, you have the force balance. Very simple to say that it is a force balance. The sum of the forces in X direction is equal to 0. Same way, you have the analogous quantities in terms of the heat flow per unit area. Then the cross-sectional area, if you multiply, that is the heat flow along that the surface, what it is acting on, let's say dy and dz. Now there is a heat generation. This is per unit volume. Now you multiply with the control volume, then what you can get is the heat generation. That is equal to what is the heat flow out, what is coming out. Because there is something added, there is some phenomena because of thermal conductivity or some other phenomena, what it is passing through this, there is a change in the heat flow. That change, how much it is, that is a secondary quantity, but there is a change. And now that change per unit area is this quantity, and multiplied by the cross section will give you, if you simple arithmetic, if you make out, then the resulting equation is this form. And now we will introduce again, this is one form of the governing equations. You can think of this as the equilibrium equation. Now I talk about 3 set of equations: equilibrium equations, constitutive law, and kinematics. Now if I bring it, the second one, which is the constitutive law, which relating the stress, the heat flow to strain, which is the gradient of the temperature, where the thermal conductivity, what you can get is K. So now by combining these 2 equations, where I can able to get the governing differential equation, which is nothing but second order differential equation, the thermal conductivity, I bring it out so that it is a kind of a constant, but it is not necessary. You can bring it inside so that it will be function of X. Now, if you look at the governing equations, it is a second order differential equation. Any second order differential equation, which is, if you integrate twice, you will get the solution. Well, that is very basic philosophy what we follow. Now, in order to solve, whenever you integrate one time, you will get integration constant. When you integrate twice, 2 integration constant. In order to solve those two integration constants, you need two boundary conditions. So when this is where you need to pay attention, one important aspect, which is deviating the governing differential equations, the analytical solution to finite element, where this equation is applicable for entire domain, which ranges from 0 to L. For the entire domain, it is applicable. But when it comes to finite element, this domain will become subdomain, which we call it as element. That is where the beauty of this finite element goes on. Now, when it comes to the boundary condition, for example, at x is equal to 0 or at x is equal to L, which is the extreme ends of the case what we consider, where we specified some temperature or where we specified the flow field, and then we are able to solve using these two boundary condition. I am able to solve this differential equation. This is where we call it as a boundary value problem. We are specifying the boundary conditions in order to solve this differential equation, and there are ways where we can apply either analytical method, as we discussed, like a traditional integration method, or you can use the finite element method. You can able to solve that. So now we will see what are the differences, where exactly the finite element and the traditional calculus based method will goes on. So when it comes to the starting point, the differential equation and set of boundary conditions, same holds good for a traditional method as well as for a finite element method. There is no difference. Now comes the problem in hand, where you will apply the integrations here, whereas you will convert these in differential equations to a set of algebraic equations. That is where the major crux of the problem lies over here. That means you are doing the integrations and you are solving the problem. But instead, in case of finite element method, we are converting to, first of all, the governing differential equations to weak form. And from the weak form, we are able to get algebraic equations. You don't have, you don't need to do any sort of the integration, and you can just solve the set of algebraic equations. For example, you have x plus y is equal to x minus y is equal to 4. So such kind of a set of algebraic equations you need to solve instead of solving the governing differential equations in this form. Now, in this particular case, what you can get by analytical solution is the temperature as a function of x. That means a single function, whatever the solution function you are getting, which is applicable for the entire region. Please make a note, and it is very important. Whereas when it comes to the finite element, you are getting the temperature distributions at, first of all, at nodes or the degree of freedoms, and then you are interpolating from the nodal degree of freedom or nodal temperatures to within the elements. So that is where the nature of the unknowns changed from continuous function to discrete points or discrete set of the degree of freedoms. So that is where the difference lies from continuum to a discrete set of points, and those points only you are finding the solution. And then you, at any other point other than the node, you can interpolate. Let's say you want to find out what is the temperature distribution in this subdomain or within this element, that will be interpolated from whatever the temperature over here as well as the temperature over here, and then you can approximate either linear, quadratic, what kind of approximation you want. The shape functions you can use and try to figure out what is the distribution among these and what is the distribution among these. So this is where the fundamental difference between the finite element and the traditional method of mathematical analysis what you do. So where the very commonly if you read any textbooks or the literature, they will try to put it in this form, very standard from K T is equal to F. The K stands for the stiffness, T stands for the unknown temperatures, or here the temperatures, or it may be nodal displacements in case of a structural analysis, and the externally applied force kind of one, which is on the right hand side. But in this equation, these are the algebraic equations. These are not differential equations, and we need to find out what we have is the unknowns T, which is nothing but K inverse into F. So this is where the basic form of the equations which we will solve for any type of the element, whether you look at one-dimensional, two-dimensional, or three-dimensional elements, or any kind of analysis you look at from the field, whether it is structural, thermal, or any other kind of one. This is the basic governing equations that we will solve to get the nodal or discrete locations, the unknown quantities that we will find from this fundamental equation. So those people who are interested in, this reference, I got it from the one of the course, a hands-on introduction to engineering simulation from EDX. This is offered by Cornell University. If anybody is interested, I have given the reference, and its code also I have given. You can feel free to take up this. And before I move on, if anybody having any doubt or anything, I'll pause for a minute. You can ask me, or I can continue, and we can discuss following that. Organizers, is it fine if I can continue, or how exactly the sessions usually?
Yes, sir, you can continue.
All right. Let me take water and I'll start. All right, so let's move on. Varieties of these finite elements in varieties of form, maybe based on the shape, based on the theory what you will use, based on the application what you will have. So let's start with based on the shape, or this is not exactly the shape, truly speaking. It is basically the dimensionality. This is the terminology that has been used by the ANSYS software. By the way, I am not recommending ANSYS software, but I just taken the reference from there, so I just taken its name. And also I come across, in this particular faculty development program, you are already familiarized with ANSYS. I just thought of, making use of the help manual what they provided. It is really good. I really appreciate the kind of ANSYS help manual is available. So let's look at that. So you have the first quantity. There are four types we can think of. Four shapes we can think of. What exactly these shapes? If you look at, one is the point. So this is the point, and you can think of the point or the line or an area or the volume. So there are, depending on the geometric dimensions, you can have these four varieties of the elements. For example, if you like very zeroth dimensions or a point, though I shown a little bit bigger to make sure you can able to see, either it may be defined by the node or as such a mass element. Let's say you are doing the vibration problem and a lump mass you want to analyze, then you can take the mass element, which is just a point. Nothing associated with the volume and other kind of. Inherently, it is possessing some kind of a volume and other kind of thing. It is made up of some density, but as a representation, you can think of as a point or the node. Then you have the line elements. For example, you want to represent a truss or you want to represent a beam, then you can have the collection of the line elements. So that is where, many traditionally, if you look at various varieties of the elements, you can see, especially for beams, you can see in ANSYS, let's say beam 188 is an element type where it is meant for two noded 3D element. So that is where you can have the varieties of the elements you can see in case of the beams, and in case of line, using the line elements. In a similar way, we can even model the axisymmetric shells also using the line elements, where you can have revolution about one particular axis. There you get a axisymmetry where geometrically and materially, and the loads are it is symmetric, axisymmetric, I mean to say. And then you have the area based, where you have the length and width kind of one, where you can have the quadrilateral element or a triangular elements in order to model the, for example, you want to model a plate, modeling as a plane stress condition, plane strain condition, or axisymmetric condition. You can use these kind of elements. And even, you can use the plate elements as a shell elements further in order to study the behavior of the shells and the plates. So this is where you have 2D kind of one. So I'd like to mention on the right hand side in the figure, where the 0 dimension, 1 dimensional, 2 dimensional, and finally we have 3 dimensional one, where you have set of elements which is a tetrahedral or a brick in shape, and usually used to model 3D solid, where you have geometric input is in terms of X, Y, and Z. So that is where you have the volume elements. There is another variety we can look at from the functional aspects, where it will be modeled. For example, you can think of a bar element, where you, or in a finite element context, some people may also use as a link element. Then you have a beam elements, plate, and solid. So when you look at the functional aspects, I mean to say, for example, if it is subjected to a compression and tension kind of one. For example, in this bridge or a truss kind of one, where you have the members either compression or tension. So that is where we will apply this kind of bar elements or a link elements, and you can able to analyze such kind of a structure. Now, apart from the axial forces, you have the bending forces, where you have the beam kind of a structure. That is where differentiator from bar to beam, where you have, apart from the axial forces, you also, it is subjected to transverse loading, which is resulting in bending action. So that is where you have beam elements. And depending on the cross section, you may have varieties of cross sections. You can think of either open or a closed kind of a cross sections, and depending on your what kind of boundary conditions you have varieties of the beams, you can model it using the beam elements. Whether you model as a complete 3-dimensional body, let's say this is my beam, and you want to model as a using the 3D elements, these 3D solid, I mean to say these, or you can model as a 1-dimensional. Let's say I have modeling as a 1-dimensional, and but the features, the cross-sectional features are taken care at these points. So that is where you can have beam theories or beam model, the beam elements. Then you have the plate or a shell kind of one. For example, you have stiffened panels, where you have skin stiffener, which is of flat in nature, and you want to it is subjected to some kind of a loading or the pressure. And then you need to find out what is the nature, what is the displacements, what is the rotations kind of one. This is where you have a plate model. And there is another kind of one, which is a shell, where the basically, if you have apart from the bending, you have the membrane effect, where it is, we generally called it as the shells with the initial curvatures. For example, if you look at a fuselage of an aircraft, that is the central part of an aircraft, where you have the initial curvatures. Maybe here it is one dimensional, one direction. It may also have the shells having the curvatures in the other direction also. So this is the radius of curvature what you can get in one direction, the radius of curvature in the other direction. Let's say this is R1, this is R2. So you have the curvature in both directions, and you need to figure out what is the kind of structural behavior by using the plate or a shell element. Now, if your analysis is such a way that you are not able to bring it to any dimensional reduction, where you are unable to bring it to as a truss or a beam or a plate or a shell, then there is no option. Then you have to go with the solid elements. And the solid element is the one which is kind of better element as compared to all this, because there are certain assumptions that to ad hoc kinematic assumptions is involved in all these formulations, whether it is a beam or a plate or a shell kind of one. So solid element, you have the only 3 degrees of freedom, that is the displacement degree of freedoms, and you can model any kind of structure. Even you can model the bar, we can model the beam, you can model plate or a shell, or even the column, which is any kind of one we can model using solid elements. Now, so if you carefully observe where this is in actual practice, let's say this is in 3D, some 3-dimensional, let's say think of as a cylinder, and now I can take the reference surface into the form of 2D and I can model as a shell element. Now, if I take one element out of it and you can look at each node, you can find the degree of freedom. So if I write the hierarchy, one is the element, then nodes, then degree of freedom. So depending on the type of the element, you have the depending on the what number of nodes it is connected and what degree of freedom you are looking forward. Again, it may not be necessarily mechanical, like a displacements and rotations. It may be, let's say, voltage in case of electrical degree of freedom, or magnetism in case of magnetic field you are looking forward. So depending on the field of application what you are looking, your degree of freedom will depends. So this is one way of looking this kind of approach. There is also, let's say, the case very interestingly, if you look at, let's say I will model the same as a 3-dimensional element, either these, or you can either degenerated form in the form of 2D, or I can model the same as a 3-dimensional one. So you can look at, if I bring out one element, you can see clearly it is a 3D element in shape and it is a 2D element in shape. So that is what you can able to see. And the degree of freedom you need to understand here is the displacements and rotations. Whereas in case of a 3D, it is only displacement degree of freedom. Now the question comes, why there is an additional degree of freedom is coming in rotation? Because we are looking at the mid surface. Then how about the surface which is above or below? That will be dictated, or how the mid surface is rotating, or how your normal is rotating. Based on that, you are able to analyze from the 2D surface itself, you can able to analyze the entire 3-dimensional body. Truly speaking, your 2D element, what you have on the extreme end here, is able to model or analyze a 3-dimensional structure. That is what I want to emphasize, that is what I want to showcase, that even though it is a surface, a 2D, but eventually in your theory or in your formulation, you are trying to look at how exactly the above and below the material, which is how it is behaving, that will be taken care. So that is where I'd like to introduce the philosophically, let's look at beam theories and plate or shell theories. So I think many of the people are well familiar with Euler-Bernoulli beam theory, where we are telling the cross section or the plane section remain plane even after bending. What exactly it means is, let's say you have the board, you have the beam, and you have the cross section, which is, this is a cross section or a plane section. And when it is bending, in case of a pure bending only, there is a difference between bending and pure bending, where there is no shear force. Let's say if I apply equal movements on both ends, then I can able to get this kind of a pure bending situation, where there is no shear force and bending moment is constant. And this is undeformed. This is undeformed, and now you have deformed configuration. And now if you look at the normal or the cross section or the normal, it remains perpendicular to the your mid surface. Let's say if I look at as a neutral axis, then if you look at on the right hand side, I have given this figure. So this is after the deformation, this has happened. And now you look at one important feature is it is straight line, number one. And also it is maintaining exactly 90 degrees with respect to mid surface or neutral layer. That is where you have the Euler-Bernoulli beam theory. And the equivalent of that we can think of as a Kirchhoff theory, where you have the another dimensions. You can think of, you have another dimensions like a plate. Okay, here instead of looking at just cross section, in case of a plate or a shell, it is the normal. The normal remains 90 degrees in case of a Kirchhoff theory, whereas in case of a Resner-Mendlin theory, that is not exactly 90 degrees, it is more or less than 90 degrees. The same thing analogous to the plate theory or a shell theory, you have Timoshenko beam theory, where the normal may not be, this is the normal, and this is your deformed profile of the neutral axis, and this is less than or equal to less than or greater than 90 degrees, but not equal to 90 degrees, where the shear deformations are taking place. That is where you have another theory, which is Timoshenko beam theory. So this is where I would like to bring it to your notice. There are two fundamentally different, these are very basic kind of one. There are so many theories with respect to beams, with respect to plates. For example, higher order shear deformation theory, layer wise theory, zigzag theory. There are so many plate theories, shell theories are there, but very focused or very on a basic level. If you look at, one is without shear, with the shear theories. One is Euler-Bernoulli beam theory, another is Timoshenko beam theory. If you look at in finite elements also, some of the elements are which is applicable for based on the Euler-Bernoulli beam theory. Some of them are based on the Timoshenko beam theory. So in a analogous to that, it is Kirchhoff and Resner-Mendlin theory. Now when it comes to the degree of freedom, as I mentioned, if you look at in case of a beam, we are using just one line. We are representing as a line. Whereas in case of a plate, we are representing as a 2D surface. Now, the degree of freedom at each node, varies from 1 to 6 degree of freedom. What do you mean by this? Since some of them already done, hands-on session with finite element, so they may be already knowing when I am modeling the beam, then you will say if it is within the plane, then you have x displacement u, y displacement v, and a rotation about z axis, which is out of the board, which is theta z. So these are the 3 degrees of freedoms I can think of. Now, if the same one-dimensional element which is available in the space, then you have the x displacement, y displacement, Z displacement and rotations about each direction. So it is 6 degrees of freedom what you can have. In a similar way, even in case of a plate or a shell elements, depending on the what you are looking forward, and then you can have only displacement like a W displacement to a rotations and axial displacements also. So that is where you have the displacements and rotations 6 degrees of freedom up to that. But usually, drilling, usually people will call it as 5 degrees of freedom mechanically, and plus 1 rotational degree of freedom, let's say theta Z, which is drilling degree of freedom, which may not be considered, or which may be represented theta Z as a function of theta X and theta Y. So you may generally come across the shell or a plate elements with the 5 degrees of freedom, but in a complete sense, it is 6 degrees of freedom. And also, please remember, I am talking about only the mechanical degree of freedom. But if you are looking for, let's say you are analyzing the piezoelectric material, for example, then you have electrical degree of freedom. Let's say voltage, V, voltage as a degree of freedom. Or you have the temperature. For example, you are doing the thermal analysis, then temperature as an additional degree of freedom you can think of. So the physics of the problem will come into the finite element through the degrees of freedom. The physics of the governing equations will come through theory. Now the shape what you are looking for will depends on whether it is a one-dimensional or a two-dimensional kind of elements. Now, I just thought of giving some very basic details about the different forms of these elements and try to see in the later stage how this can be applied from the point of view of the Gauss quadrature and other kind of thing. Okay, so it's 11:15. So I'd like to, I'm just looking at how speed I am so that I can able to cover the required portion in time. All right. So let's look at this is the element usually designated by the letter E, and you have the nodes, node 1, node 2. That means it is a two-noded one-dimensional element. Now, what kind of a degree of freedom it is having? At node 1 is the displacement U1. And here also another displacement which is represented by U2. So it's a 2 degree of freedom per element and 1 degree of freedom per node. So this is where is very essential in order to get what is the size of your element level stiffness matrix. If you want to find out what is the element stiffness matrix, it is the total degree of freedoms per element. That is what the size of your stiffness matrix. For example, in this particular case, the size of the stiffness matrix turns out to be 2 by 2 because we have 2 degrees of freedom per this element. Now, this is called a linear element. That means you are interpolating linearly. Once you know the unknown quantity at node I, at node J, you can interpolate anywhere in between. And you can have the linear interpolation, that is where you have very basic linear element. Let's say instead of 2 nodes, if I have 3 nodes for this element, let's say this is my first element having 2 nodes only. Now I'll introduce one more element which I am designating with another symbol kind of one to designate whether it is outside nodes and one is intermediate node, and this node will give the more accuracy in terms of the how best you can your displacement quantities or even the geometry, how you can able to interpolate, especially curved boundaries you want to interpolate, or the curved boundary, let's say your geometry is like this. If I want to use the linear elements, then I get a discretization error of this one. That means you are unable to capture this amount. Whereas if we use the quadratic element, then we can able to bring it more closer and more closer, where it is, let's say if I have only one element with the two nodes, and if I use mid-side node, then it will try to have quadratic approximation, which will be more closer, where you can able to interpolate the geometry very well, so that you can have the errors, the discretization errors will minimizes to greater extent. Further, if you want more refined solution, then you can go for cubic element. But what is the problem in increasing the polynomial order? When you are increasing the number of mid-side nodes like this, that means you are increasing the polynomial approximation. If you have only 2 points, then n is equal to 2. Then the polynomial order which is able to interpolate between these is n minus 1. That is nothing but linear. That means using the two nodes, you can interpolate only linear function. Let's say if I have more number of points, okay, let's say n is equal to, in this case is 3, n minus 1 is equal to 2. That means a quadratic representation I can make out between these using these 3 points. That means I am increasing the polynomial order, whereas now if I increase the polynomial order, what is the kind of advantage and what is the disadvantage? As the number of nodes are increasing, your computational cost is increasing. At the same time, advantage, it is you are fitting very closely your displacement field or the geometry, where you can able to minimize the errors. Then we look at the another set of the degree of freedom, where you can have the displacement degree of freedom and rotational degree of freedom. Though you have the in actual practice, as I mentioned, beam is a three-dimensional body, but you are able to represent as a single line like this. Now, this line element will have let's say two nodes, node 1, node 2, and at these two nodes you have the 2 degrees of freedom, that is W1 and W2. One is the displacement in the transverse direction and the rotation which is out of the screen. So this is where you have 2 degrees of freedom per node, what you can have in case of a beam elements. In the same way, even you can think of the elements which are 2-dimensional. That means a 2D beam element, what you can have is where you have the, don't worry about the nomenclature, what exactly here it is showing. This is basically taken from SS Rao textbook. It is just to illustrate, I want to show that these are all kind of a representation where you can have the degrees of freedom, whether it is global degree of freedom, local degree of freedom. So whenever you come across any textbooks, don't get feel like I am not aware of this. It is just a matter of how well you represent these quantities. So whenever, let's say this is a beam or some kind of a structure, now I divide it into, let's say, some elements. Now if you look at some quantities which let's say you have 1, 2 and 3 degrees of freedom at each node. Let's say this is 1, 2 and 3, and similarly you have 1, 2 and 3, let's say. So this each individual, if you look at individual, then I am drawing over here. This is a combined, this is at a structure level, whereas individual element, let's say I am taking this E1 and let's say this is E2, usually represented by like this. E1 element is represented by the circle, whereas the nodes are represented without circle, 1, 2 and 3. Now if you look at here, now I will take one element, let's say this is E1, and you have the degree of freedoms, let's say 1, 2 and 3. Similarly 1, 2 and 3. Now there is a quantities I would like to mention here, that one, for example, which we call it as, this is local degree of freedom. DOF stands for degree of freedom. This is global DOF, global degree of freedom. So what exactly it means is, it is a collection. For example, if you look at one element and you have the degree of freedom, let's say 1, 2, 3, then 4, sorry, then you have 4, 5 and 6. So this is the degree of freedom, this is the element, and these are the two nodes what I have. So now these are the local degree of freedom. Now collection of those will give you the assembly process which will lead to a global degree of freedom. Now if I want to look at how to designate this local coordinates, for example, in this figure on the left hand side he used, let's say, small q. Whereas the global degree of freedom, which is represented by capital Q. But it is more or less the same. Only the difference is that it is at local level, and once you put it all together, then it will become a global degree of freedom. That's the only difference point of view. I just want to introduce one more term, which is the global and local. Similarly, if you look at, when you want to model a plate or a shell kind of one, you can think of as a, 3-noded triangular elements or 4-noded rectangular elements. Now I have taken from two different sources. That is why the terminology and the figures are little different. But eventually it is representing, it's a 2D element like this, and at each node I have 3 degrees of freedom. What are those? One is theta x, theta y, and W. So these are the 3 degrees of freedom at each node will represent how exactly this is bending. Let's say what is the bending about x-axis, what is the bending about y-axis, how much it is displacing in the z direction. So that is the physics of the problem in nature. And now the same kind of one even I can model using the triangular elements. Now it may be 3-noded, it may be with mid-side nodes, without mid-side nodes, with edge nodes, without mid-edge nodes. So you can have varieties of that. I am going to introduce later, but this is where you can make use of the triangular elements and rectangular elements to model the plate and shell kind of one. And if you look at one variety where people look at as a shell element as a combination of plate element, what we just look at as a 3 degrees of freedom, plus a plane stress assumption where you have the 2 degrees of freedom per node. As a combination of these, you have 5 degrees of freedom, which will able to represent what you call as a shell element. So you can have the 3 displacements, which is represented as U1, U2 and U3, as well as the rotations. Let's say beta 1, beta 2 are the 2 rotations combining together, which will form the 5 degrees of freedom, and that will be able to represent your shell kind of. So you are taking the membrane effect from here and bending behavior from here, and combining together it will forming the shell element. This is one philosophical way of looking, and another is a degenerated shell element where you are equivalent single layer. You are like if you look at in this figure, there is a mid side mid surface you can think of the same. Now how do you bring it down? How do you integrate that to get a mid surface? Is the various theories you can follow and get a degenerated shell elements. Many commercial finite element softwares and many literature you can find these kind of elements. Now I would like to talk about the variety of the elements. For example, you have, as I mentioned, earlier we look at only at the corners. Okay, this is the basic element. Sorry, I'm unable to write a very straight edges. But if you look at, we have the 2D element, which is having the 4 nodes at the corner, right? But if you also look at, there is a mid-side node in case of this. Here also you have mid-side nodes. The only difference between this and other varieties is that how do you approximate the field with what polynomial function? If you are looking bilinear function, then you can use this. If you are looking biquadratic shape functions, then you use this one. Or if you are looking for bicubic interpolation, then you can use the third variety what you can have. So third one, which is this one, which is having the inside the element, inside the element, as well as on the your edges of the element. So this is where you have the difference. If you doesn't have the mid-side nodes, this doesn't have mid-side nodes, doesn't have inside nodes. Whereas here you have the combination, and also if you look at it is a vector product in both directions. That means if you take a count 1, 2, 3, 4. Again in this direction also 1, 2, 3, 4. It is equally spaced, 4 in one direction, 4 in another direction. Whereas in some cases we can see there is a disparity in that depending on what variety of the element you are choosing. Now, if you look at the one class of the elements, what you can think is serendipity elements. In this kind of one, there is no node inside the element. This is what that means. You don't have the nodes inside. Then such element is called as serendipity. But you can have on the edges. For example, node number 6, node number 5, node number 4 are available on the edges where you can have the serendipity family of this. So this is a lower order element which is called as the 3-noded. If you want higher order, then you can go for 6-noded kind of one. Another important feature with respect to elements is isoparametric elements, superparametric and subparametric. What it means is if you look at the element, any finite element which is meant for the representation of, one is the geometry, like how do you represent the geometry, and another aspect is how it is representing the displacement or rotations. So one quantity is the geometry and another quantity is displacement. If your shape functions, whatever the shape functions you are using the same number of nodes, okay, here if you look at 8 number of nodes, triangles, you count it 1, 2, 3, 4, 5, 6, 7, 8. 8 number of nodes are used to represent the geometry. At the same time, even the displacement also represented by same number of nodes, then you can have isoparametric. Iso means same. Parametric. Here parameter is geometry or the displacement. So same number of nodes if you use to represent geometry as well as displacement, then you can have isoparametric. If it is more number of nodes are using to represent geometry, then you have superparametric. If it is other way around, when you are using more number of nodes to represent displacement, for example, circled one, if you look at here, there is a mid-side nodes also you have, whereas triangles are not there. Triangles are only 4, whereas the display circle nodes are represented are 8. That means you have more number of nodes to represent the displacement field as compared to geometry. Now, is it really necessary to look at such kind of different types of elements? Now, the case of, for example, if it is curved geometry, now I will be more useful if I use superparametric. A curved geometry, I need to be better if I can use superparametric. If they have a geometrically nonlinear situation I want to use. Let's say I have a bar but or a beam, sorry, not a bar, but a beam. Let's say if it is subjected to some loading where the deformations or rotations are large, now there it will be more appropriate to use subparametric. So this depending on the problem in nature, whether it is the based on the geometry, based on the your deformation patterns, you will have different varieties of these elements. Traditionally, if you look at any commercial finite element software, they will go with simply isoparametric elements, so that your complexities in terms of the shape functions, then derivatives, finding everything will be very simple. So once you make all these available in the library, you will just call up and they make use of that. So that is the easy way of looking isoparametric elements. But exactly if you are looking at the problem in nature, that depends on the geometry and the displacement field. Now, when it comes to 3D elements, you have tetrahedron kind of one where you have 1, 2, 3, 4 nodes, or you have the mid-side nodes where you can have higher order elements, or you can have the brick kind of one where it is a traditional element, 8 nodes, or if you have mid-side node, you can have higher order elements, what you can have in terms of 3D elements. Now I would like to bring it to your notice about the local coordinate system and global coordinate system. So if you look at, let's say I have a bar or some kind of a beam, and I'm modeling with a 3D element, and this is where having some kind of let's say length, height, and the width, what you can have, this is what you have, and I'm using 8 nodes to represent this. This is in the global Cartesian coordinate system or a global coordinate system. And yes, ma'am.
Student time waste આપણે સ્ટુડન્ટને સરખો ન્યાય નથી આપી શકતા. તમને તપાસ ચેક એટલે કે તો તમારે એલબી ક્રેડિટ તો ખરાબ જ.
Ramesh sir, kindly unmute yourself, sir. Okay.
All right. Earlier, I am audible, or just now only it is muted?
Yes, sir, you are audible now.
Oh, fine. So now I am going to talk about the feature of what you call the natural coordinates or the parent coordinate system and the global coordinate system. So why we need such kind of another coordinate system is that, let's say you, for example, some of them may be much familiar with the C++. You have a class, you have an object. Object is a representation or an instance of your class. That means once you define the class, once you know what are the functions defining on how exactly your class should work, then you can have the instance of it where you can have the objects. So that is in a similar way, you define your stiffness matrix in natural coordinate, and then you keep on mapping this one to any other element. So if you look at very simple, illustration, let me, sorry, trying to look at the option where my pen, I'm trying to look at the pen. Sorry. Okay. Yeah, I'm able to trace out. Okay, so let's look at the case. For example, you have a Very simple case, 2D case I am taking. Just think of it as you have a room, and in this room you have 6 tiles, and all are, let's say, same size and same quality, same kind of one, but only thing is they are placed in a different geometric location. Let's say this is my global coordinate, some x, some y, and let's say this is my 0, 0 coordinates, and these tiles are placed in a different geometric location. But the features, it is made up of same material, same kind of one. So what I will do is I'll take one element out of it, or one tile out of it, and I will find out what is the stiffness of this element. Let's say stiffness of that element I will find out, and then I will map from here to here by changing its geometric location. That means I don't need to calculate every time what is the stiffness. Rather, I will create a database for one variety of the element, and then I will keep on calling that. It will reduces your computational effort. You are just calling a function with a stiffness for one variety of element, and then you are giving the input such a way that it will represent different locations what is the stiffness of it. So that is where this is called as natural coordinate system, okay? And whereas this is your global coordinate system. This is also called as parent coordinate system. So natural coordinate system or parent coordinate system is here, and you are mapping to your global coordinate system. Usually the size of this will ranges if it is a one-dimensional. If it is one-dimensional, please look at here. If it is one-dimensional, the size of the element will be -1 to 1. If it is a two-dimensional, then the size of the element will be -1 to +1 in both directions. That means you have 2 cross 2. That means size of the 2 units along the length, 2 units along the width. In this case, you have 2 units along the some coordinate direction, let's say xi or s, whatever the kind of, usually the symbols you can see are s, t. This is the one, or Greek letters, let's say, xi, eta, gamma. These kind of letters will be utilized to represent the natural coordinate system, whereas your global coordinate system usually represented by your x, y, z kind of thing. So that is where you can differentiate the dimensionality. One is units -1 to 1, -1 to 1 in both direction. If you have a 3 dimension, what I have given the figure, which ranges from -1 to 1, -1 to 1. Now you may ask, like, you have the size here 2 by 2. 2 cross 2 dimensions, whereas in actual practice it may not be, no? Then how it will be mapping will takes place from here to here. That is where the Jacobian will help you to map one unit area cross-section, unit area to any other area what it is having. The Jacobian will help you to map from natural coordinate to your global coordinate by providing exact what is exactly your sizes. Based on that, it will able to capture. And this is you can look at with the different degrees of freedom what kind of elements you can have. As I mentioned, we can have 6 degrees, up to 6 degrees of freedom you can have. This is just want to give one or other kind of information one. And finally, I will be looking at 3D elements where each node will have 3 degrees of freedom. That is only displacement u, v, and w. This is the shape of that element, and these are the degree of freedom, and it is having all the 3 dimensionalities x, y, z. Either you can use this one for all variety. All this 3D element can be used as a bar, beam, shell, plate, or anything you can use it. But only thing is you will have only 3 degrees of freedom. That's the only displacement degree of freedom what it is. All right. Now I would like to introduce one more concept, which is called as Gauss quadrature. Basically, this is the one where we will apply is, for example, you have the stiffness, which usually represented by this form. Let's say some dx. The stiffness of the, let's say, line element, or a stiffness of the bar element you want to find out. Let's say this is the stiffness of the element is given by the strain displacement matrix B matrix constitute C matrix, your again B matrix, which is kinematics matrix. Together, if I integrate over the domain, then I can get the stiffness matrix, which is K. But instead of doing this, a definite integration with the limits, whatever the kind of specified, instead of doing that, I will use the numerical quadrature scheme, and one of the popular one among the quadrature schemes is the Gauss quadrature. Based on the rigorous people have worked over the years, starting from trapezoidal rule, Simpson's 1/3 rule, various Newton codes formula, Newton code quadrature, various other quadrature use. But Gauss quadratures is having upper edge in terms of when you compare the results with the actual values, the results are much more closer. That is where you have Gauss quadrature. So how exactly this quadrature will work? Let's have a look at. So as I mentioned, you have the stiffness in this form, some limits B transpose CB into dx. Now, instead of working in this definite integration directly, what we will do is we will evaluate the function. This is the function. This is the function. This f, let's say I am representing as f. Now, this function will be evaluated at a certain points. What are those points? Let's say you have the domain 0 to 1. This is the domain 0 to 1. And I want to integrate over this domain. Let's say my function f is going like this. Okay, f is going like this, or my stiffness is varying like this. Now I want to find out the same 0 to 1, whatever the B transpose dB. Instead of definite integration, I will go for numerical scheme where I will evaluate the function, this stiffness B, at certain points. Let's say 1 point, only 1 point, and I will multiply with certain weights. Okay, the function evaluated at 1 point, which is designated as S1. The location is S1. Within this domain 0 to 1, I am taking 1 point and multiplying with a certain weight. Let's say that is W1. So if you do this is equal to and finding the definite integration. That is where the scheme Gauss quadrature. So you don't need to do a definite integration from 0 to 1 or -1 to 1 B transpose CB into dx, where you will just take certain points and you will multiply, you will evaluate that function at that point and multiply with weight, you can get that one. So you may consider only 1 point like this. You may also look at, let's say my domain is this and I am evaluating, let's say 2 points. And I know what is the weights, let's say W1 here, W2 here, and I can able to interpolate and I can find out f of S1 into W1 plus f of S2 into W2. So this is where you will evaluate the function or the stiffness matrix very precisely in our finite element context, and you will able to figure out, instead of doing the numerical integration, instead of a definite integration, you will do numerical integration. Now, how many points you will take, whether it is only 1 point, 1 Gauss point, or 2 Gauss point, 3, 4, 5, how many, that depends on your problem in nature. So with a very low order, that is the beauty of Gauss quadrature scheme. With lower order, let's say 1 Gauss point or 2 Gauss points even, is much better results it will give, which will be approximating your stiffness very well. Here I just taken 5 points and the corresponding 5 points location, and I am able to evaluate that integral at those points, and I can able to equate it. So I just given the table for your illustration purpose. You can just go through later. I'm sharing these slides with you. So if you have only one Gauss point, so if you look at the table should be read like this. If you have one Gauss point within that domain, the location is at 0. That means exactly at the center. Usually the domain is specified between -1 to 1. So when it is saying 0, location is 0 means at the exactly at the center. And what is the weight you have to multiply? Then you have to multiply with 2. That is the where you have to read this table. Now, if I have 2 Gauss points, let's say within this domain of -1 to 1, let's say this is -1, this is +1, and you have at -0.57735, which is 1 by root 3, -1 by root 3. Let's say this is 0, -1 by root 3, or 0.57735, and here +1 by root 3. These are the two integration points, and corresponding weights are 1 and 1. So this is where you have to read this table as what is the location, what is the corresponding weight, and what is the order in which you can integrate. So it's just to look at this table and try to get familiarized. And the same concept we can extend further for 2D also. For example, in case of 2D elements, it is integral, let's say -1 to 1, -1 to 1, B transpose C B dx dy. That means here you have area integral. That is where you have -1 to 1, -1 to 1, B transpose CB. Now, even this function also, you can evaluate it at those Gauss points. For example, in this, you have, various Gauss points given, 9 Gauss points. So you can have the lower order also, where you can have only 1 Gauss point, or a 4 Gauss points, or 3 by 3, which we call it as, there you have 9 Gauss points. So depending on the problem in nature, for example, if you are using the shear plate bending, in case of a plate bending problems, I'm just giving an example where you can classify your analysis into 2 parts. One is the bending action and another is shear action. The shear action, you can use 1 by 1 Gauss quadrature scheme. That means only 1 Gauss point. Whereas for bending, you can use the 2 by 2 Gauss quadrature scheme. That means 4 Gauss points you will use. So different order of the quadrature schemes within your program also possible, because you will reduce the computational cost, and also lower order for shear, because it will reduces the stiffness. So otherwise it will become more stiffer when you use the higher order quadrature scheme. So depending on the type of the problem you are looking forward, then you will see that what is whether you go for a lower order or higher order. If you want, you have very computational power you have, then you can have higher Gauss quadrature scheme also. So this is where you have, in terms of the 2D, the points also I mentioned where exactly the location, and you can look at for 3D also. For example, 3-dimensional elements, you need to have integrate -1 to 1, -1 to 1, -1 to 1, let's say B transpose C into B dx dy dz. So you have volumetric integral. That is where you need to have 3D integrals. So this is also again represented or evaluated the function at certain points. You don't need to do all this triple integral. Rather, you will evaluate the function like this and multiply with weights in each direction, and then you will add up, summation will give you the required value. It is just like stiffness of the element. Again, I have given this one. So this is more important. I'd like to everybody to have a patience enough to look at here. I'm sure the time is not very high, but I'll try to see that whatever we covered so far is comes together in this kind of a slide, where basically, let's say I want to model a beam element. Now, where is the starting point? The starting point is total potential energy. And everybody knows how to define the total potential energy as strain energy minus potential of the load. Now, the strain energy, which is, let's say in this particular case, I am considering only bending. That is where I have given the expression. The strain energy expression due to bending is m square dx by 2EA. So this is the bending expression. And the potential due to loads. For example, here I have uniformly distributed load, and the corresponding load and displacement is V. Load into displacement is the work done, or potential due to external loads. That is where I can find this. Apart from that, there is a concentrated forces, concentrated movements. The force multiplied by displacement or movement multiplied by the rotation will give you the potential due to load. So this is where you have the set of all this part from here to here is all about potential due to load. And this part, which is the strain energy part. So strain energy minus potential of the load is total potential energy. Now, you need to, represent as some displacement field. You have the movement, bending moment, that we know that we can represent as a second derivative whole square. Right? M by EI, M by I is equal to sigma by Y, that is equal to E by R. And you can relate the quantities 1 by M is equal to EI by R. I'm trying to connect these two quantities, and I'm able to represent the 1 by R, which is nothing but a curvature, as a function of the displacement V, the vertical displacement V, as second derivative dou square V by dou x square. That is nothing but curvature. First derivative will give the, let's say, V, theta rotation is equal to dou V by dou x. Second derivative dou square V by dou x square is nothing but your curvature. Okay, let's say kappa. So now R1 by R is a curvature. I can able to represent the above equation in this form, and everything, if you look at everything, is in terms of your displacement field. Okay, one is the displacement field is either the pure translations or rotations also I am able to represent in this form. Now I'll able to go to your finite element. Okay, so how do you start again applying from the total potential energy? How do you go to your finite element? The first step again is finding the shape functions. So these are some of the times you already available to you, or you may, if you want to derive yourself, then I have given all the steps right from the beginning. If you have a polynomial order of third order, let's say A0 plus A1 of xi plus A2 of xi square plus A3 of xi cube, you can have this kind of polynomial if you consider. Then you can derive these coefficients A0, A1, A2, A3 by using appropriate boundary conditions, and then you can represent this as a shape functions. Because of the limitation of the time, I am not describing everything, but a final form what it will look like. So this is the what you have initially displacement field V, which is A0 plus A1 into something xi and so on, so can be represented as the nodal displacements as a function of nodal displacement V1 theta 1, V2 theta 2. So that, let's say this is my element, and one is V1, this is V2, this is theta 1, this is theta 2. Okay, so using the using the four nodal values, four nodal degree of freedom values, I am able to represent your displacement field. Now, the coefficients of the polynomial which is multiplying with this unknown coefficients v1, v2, v3 up to so on is nothing but your shape functions. That is nothing but, let's say, n1, n2, n3, n4. So that is where I just represented over here. V is the displacement field is represented as a function of shape functions and times your nodal quantities. So this is where you can, next step is, once you have the total potential energy, you represent your displacement field as a function of shape functions. Now you can choose any of the shape functions. What I derived is one set of shape functions only, but you can choose any of the shape function based on what you have in problem in hand. So now you represent your total potential energy phi as a function of your shape functions. Now we will, wherever v is there, wherever v or its derivatives, you represent as a function of shape functions. Now that will be, represented in this form. You need to, a little bit be patient and try to absorb at your end once you go back and try to see each and every step very carefully. I have given all the steps. You can just see that when you take the minimization of this total potential energy phi with respect to displacement fields is leads to that final form I am showing is nothing but your K into stiffness matrix into displacement is equal to your force terms. So this is the final form what you can get once you make the differentiation or minimization of total potential energy with respect to your degree of freedoms will give you to this final form of the equation which is to be used in the finite element analysis. And then you can form the element stiffness matrix, and then you can I'm just skipping off all these because of the interest of the time. All right, just 1 minute I will pay attention here. So basically, for one element, let's say this is my total structure. This is in the global coordinate and the local coordinate system. This is one element. This is second element. This is this element. This is this element. Okay. Now for each element, I am able to form this set of equation. K into U is equal to F, or K into D is equal to F. So these are the two element level matrices. Now there is a process called assembly. It's not matrix addition where A plus B, matrix A plus matrix B will give a matrix C. That is not the process. That is not the case here. Assembly means it's a process where depending on the location of your degree of freedom, you will assemble the elements such a way that it will give the global level of the stiffness matrix. So that is where the new, one more aspect we need to look at is assembly process. So once you have this assembly process, then what you can get from local coordinate system, what you have here, it will come to a global level of the stiffness matrix. And you take the inverse of this and multiply with the force, you will get unknowns what you have this. Maybe I'll pay attention on this, though it looks very complicated kind of one, but it is not so. If you pay very careful observation, this is the figure where I'm going to talk about one slide only, where I will try to cover the mechanical displacements, electrical, and thermal. So all varieties of the physics related, boundary condition I will cover in one slide. Just pay attention. One is the when it is with respect to mechanical, you have the displacement field. When it comes to electrical, it is the voltage or scalar electrical potential. When it comes to thermal, I'll be using temperature as a degree of freedom. These are all degree of freedoms. Please note, these are all degree of freedom at a node. Now, again, I will go to the next items. One is the stress in case of mechanical, dielectric electric displacement in case of electrical, and heat flux in case of thermal. Please look at, I am following in the same order. First one is mechanical, then electrical, then thermal. Then you can have the specified values at the boundaries. So in terms of the traction, you can specify mechanical, electrical charge, or the heat flux, specified heat flux at the boundary. Now, what exactly these and how we will specify? For example, if you look at a three-dimensional body like this, now there is a location where I am fixing here, let's say. Just like in a cantilever, I can fix this boundary condition. Now that boundary I am representing with this symbol gamma of u, that portion is fixed mechanically. Now there is a portion where I will be specifying gamma of pi, where let's say I am specifying the voltage. Let's say 50 voltage or 0 voltage, grounding. For example, grounding I am giving, that means I am specifying the voltage here. And there is a portion where I am specifying the temperature. Let's say I am giving 100 degrees 100 degree temperature at this region. Okay, so this is where I talk about all these boundary conditions, first set, whether it is in mechanical, electrical, or thermal. Then I will specify the stresses, mechanical stress or traction I can specify in mechanical, or electrical displacement I can specify, or heat flux I can specify. And also if it is in case of a cracks or a holes or some inclusions you have, there we can specify as a stress-free boundary condition. For example, I have some center crack or some void I have, and then I can specify on that boundary it is the stress-free boundary conditions. So this is where you have stress-free boundary conditions in terms of the cracks or inclusions where you have. Where you want to specify the loads, where you want to specify the fluxes, you can specify. So this is where in any structural analysis, your boundary conditions plays a critical role, and if you can make analogous quantities of one to another, then it will become very easy. See, for example, here I am specifying what is the traction I have applied. Let's say some forces I am applying in this region. Now, in this region, I am applying some kind of this force. In this region, I am applying some kind of electrical charges. In this region, somewhere I am applying some voltage, thermal kind of one. So there, depending on the problem in nature, you will have the boundary condition in hand. So I'll be skipping all this. So these. So can I take 5 minutes, organizers, please?
Yes, sir.
Yeah. All right. So there are so many online resources available. I just compiled all of them to give some kind of overview about it. So you can find many courses right from India, abroad, and many places. Some of them are government initiatives and some of them are private kind of thing. But you can see all of these resources where you can find out online courses on finite elements and advances in finite elements. And I would like to recommend a couple of the books for your reference. C.S. Krishnamurti, one of the basic book where you can find very easy to understand. And another book is very easy to follow is Jain Reddy. And Zenkevich is having volumes 1, 2, 3. So you can you can start with one, and if you are looking forward for CFD also, then go to 2 and 3. Otherwise, if you are just a basic finite element, if you are looking, then volume 1 is enough. Otherwise, you can go to up to 3. And those people who are interested in programming, especially finite element method using MATLAB, there is a very good book by author called Young. Finite element method using MATLAB by Young and Young Known. The name of the author itself is Young Known. So you can go through that. I find very interesting, and even source code also given there. So you can able to work out your elements, developments, and other research work, whatever you want. So with this, I would like to give some kind of a conclusions from my end. So as you know, there are 3 methods of any analysis. One is the very, you can go for experimental analysis. That is the real what you can get it. But we can not test every specimen and keep on breaking it and finding the strength of it, right? So we need to have some kind of alternatives, because it is a very expensive kind of an experimental. So we need to go for some kind of analytical solution, which is a quick kind of one, but at the same time, which is very difficult. Whereas the another intermediate one, which is a numerical method, like a finite difference method, finite element method, the new methods like XFEM and meshless methods, so many other methods are available in numerical schemes. But FEM is having its own kind of identity, whether it is, if you look at industry, whether if you look at academic community, it's a very well utilized and very accepted by the all communities. And also, whenever you want to make find an optimal product, it is better to go for some kind of numerical studies first, and then you can finally validate with experimental and see how well your product is looking like. And then it is always it will reduces your product life cycle. If you look at, the cost will minimize if you go for such numerical technique schemes. But here I would like to bring it some what you have the advantages. At the same time, there is opportunities. Truly speaking, it's not a limitation, rather we can think of as an opportunities as a academic community, where we need to see that basically I like to give an illustration with this is a Airbus published report. Basically, they have Airbus A350, which is a very popular aircraft, which is running fine and which is very popular across the Airbus series. But if you look at the cost involved, the time involved, what is being suggested or what is being initial estimate, what is the final cost? It is like a 3 times, 5 times the cost and the time as involved. Now, one of the important feature where what it could be the reason, if you look at, they mentioned as a lengthy simulations, because if you can reduce the computational time that is involved by incorporating your new method of analysis, new way of schemes, if you can include such a way that your computational cost will reduces, that will reduces your overall time required for the development of a full scale aircraft kind of a one will reduces. That will in turn will reduces the cost. And the another one is material. If you look at aircrafts which is made up of composite material, most of the 50% of them is made up of composite material, and then it is having many layers, 72 layers. If we have interaction with Airbus people, and they mentioned as part of the wing structure, you have 72 layers, and each layer may be some different orientations, angles, and that is where you have different materials and combinations, and you need to take care of all of them. Traditional approaches may not yield required solutions. So accuracy also concerned, the complexity is more, you need to give some kind of a proper constitutive law. That is where we are working for using the variational asymptotic method to give the stress strain relationship or the constitutive law for such a kind of a composite materials or multifunctional composite materials, so that your accuracies will remain, accuracies will be maintained. And we are also looking at reducing the computational cost. Instead of working the 3D elements, we will use 2D elements, that is a dimensionally reduced form, so that your computational cost also reducing, your accuracy also coming closer to your 3D level. So that is where please try to look at some kind of opportunities in terms of the how to reduce the computational cost as well as how to improve the accuracy, so that your end product not just looking at how beam will bend or how plate will deform, but you just think of as a whole structure like an aircraft or a bus or an automobile. Then think of how much cost involved and how well we can able to reduce the cost using the finite element analysis. So there are various advances coming up with in terms of the finite element. I'll just to take a minute to illustrate how the XFEM, what we are working is one more domain is applying the extended finite element method. XFEM stands for extended finite element method. So if you look at here, when it comes to let's say there is a crack, let's say a plate is subjected to some kind of a edge crack here, and if you want to model that using a traditional finite element method, then it follows the boundary of the boundary of the crack, and you have to model the entire space using the mesh. Whenever there is a crack propagates, you have to change your mesh, because once earlier it was the crack is up to here, now it is extended because of your cyclic loading, and then you have to remesh whatever the region it is extended. So you have to entire remeshing need to takes place. That is a time consuming. If you take a small plate like this, it may be okay, but if you look at a real time structures, it is very difficult. So the mathematical rigorous what if you can apply, that is where you help you in by using extended finite element method. You just look at it on the right in the right hand most corner figure, where a regular mesh, you don't need a adaptive or anything, just you take a regular mesh, identify where your crack is there. If you can able to track that crack, then you can able to solve without remeshing. I'm telling, without remeshing, you can able to solve the crack propagation problem. So this is the beauty of extended finite element method. So that is where we are applying to piezoelectric materials as a part of my second PhD student worked on that, and we are extending from 2D to 3D now. And because of the 3D printing is more popular nowadays, which is a kind of a digital manufacturing, where whatever the kind of a structure you think of, it's you have to your imagination, you can create a models, you can 3D print it. For example, if you look at on the top, all the CAD models, all of these are CAD models. In the bottom, all are 3D printed. But how to assess these? How to assess whether which model will give optimal solution? So better is you go for ANSYS or any finite element software, or we are also having in-house developed finite element software, and we are able to look at where the stresses, where the displacement, what is the auxetic nature, what we are getting. All this we can able to figure out, and we can get a optimal configuration. So right from the what you design in the more design tool to analysis and then 3D printing, everything you can make out in a digital way. So that is where you can have this kind of analysis will be very useful. I'd like to thank my team, the 3 PhD students, and the 4th one is just joined, and this is all about from my side. Thank you very much. But if you have any doubts or clarification, I'll be happy. And
Participants, please ask the questions if you have. You are unmuted. Please, you can carry on with the mic only. Please.
one of the questions, shall I take up, madam? He is asking which is the best Indian author book to recommend to the students on finite element method, finite difference method, and separately also. So as I mentioned, the book which is C.S. Krishnamurti, which is a very basic book and which you can recommend for students, especially he's an Indian author. He's a professor in IIT Madras, vast experience, and he given even programs also, even the code also available in that book. You can go through, you can ask your students, there is one way where my recommendation is always better you yourself start coding it. Let it be small element or let it be small contribution, but instead of you can make use the commercial finite elements softwares, there is no doubt, but until unless you code it, until unless you get involved, you may not able to see the real beauty of the finite element analysis. So I strongly recommend to go through this finite element method using Young and Known, which is a very basic book again, though it is not an Indian author, but it is very simple to understand, easy to go ahead, and you can start from there. Or C.S. Krishnamurti, the finite element method book, which I can show you here. It's available. It's the second edition now. It's available. This is a book what I can have, and people can look forward. And one more question in the chat. Did I answer your question? Is it okay? All right. So there is a one question, if XFEM can go for the natural composite materials also. Yes. See, XFEM is more advantageous of going whenever there is a fracture or a fatigue analysis. Because a traditional finite element analysis can able to take care of composite materials very well, but where the extra coming from or where the drawbacks coming from what your traditional finite element method is overcome based on the extended finite element method. So if you look at, there is a cracks, either edge crack or a center crack or some kind of various cracks in between in a structure. You want to study what is the mutual interaction among them. So there you can look at the extended finite element method usage very well. Now the material can be even a isotropic material to composite material, again natural or a synthetic or even hybrid kind of one, or functionally graded materials, any kind of material you can. But the advantage is that you can have, when it comes to composite, you have much more complication. In case of, let's say, look at isotropic material, modeling a crack is little less complex as compared to composite materials. So it is more appropriate to use XFEM there with more rigorous kind of one. Thank you, Bindu Mol, and thanks, Surya Kiran. Sandeep is asking, is there any element available which connects lower order elements to higher order element in the problem? Okay. See, you especially when you have the adaptiveness is coming, where you need to make some lower to order. There is always some what you call even if you have mid-side nodes or the inside nodes, which may not contribute for the assembly, that will be distributed their stiffness to the edge nodes, or where the nodes are connecting to other elements, and then you can form. In the same way, you can have this kind of let's say you have one variety of the element, another variety of element, where it is having the connection. There you can have the transformation, and then you can have continuity of the stiffness matrices. All right. For XFEM, any reference book. So, there is a Ahmed, Sohail Ahmed, if I remember correctly. That book is very good. First, he will cover up from the fracture mechanics point of view, then finite element analysis, and then they will take it forward to XFEM. So it is a kind of those who are familiar with mode 1, mode 2, mode 3 kind of failures and fracture mechanics terminology, they will find very easy to follow up that book. So if I remember, XFEM by Ahmed. So even the book, which, just a minute. This is by Amir, but I know there is a Sohail. Sohail is one which you can think of. Yeah. I can give you exact author name and book title in my presentation. Any advice about implementing wavelet concept with FEM, like wavelet Galerkin method? Truly speaking, I am not an expert in this wavelets, so my answer may be partial. But if you look at Professor Gopalakrishnan from Aerospace Department of IASC, he is an expert in this wavelets. And also Professor Sandeep Kumar from IIT BHU. He is also well-known person in this wavelets. Maybe even Professor Sandeep Kumar written one book. He shared with me the title and other things. If you want, I can send across to you the details. But it is very easy to figure out. You can just type in Google, you can get it. Professor Sandeep Kumar, Mechanical Engineering, IIT BHU. He had written one book on wavelets. And Professor S. Gopalakrishnan is professor in Aerospace Department of IASC. You can look at his quite extensively, he worked on these kind of one. You can have a look at on those. MATLAB with FEA book, as I mentioned, Young and Known is very good book. Is additional node in superparametric element take part in solution process, or it will only to capture the geometry? Yeah. See, even though the geometry as well as the displacement field in some or other way will come into picture in the formation of stiffness matrix, because if you look at integral, it is either integral of dx dy or dx dy dz. So that dx dy dz is represented by, again, some shape functions. So displacement field as well as your geometry, even in what I mean to say is, if not directly, it will indirectly will come into play, both of the fields. So that is the reason, in order to avoid, what you call, what to use and what not, commercial finite element people uses the isoparametric. But it is not necessary. What I mean to say is, as you rightly pointed out, the displacement field, which is truly more predominant in the formation of the stiffness matrix and its effect, but geometry also plays a role where it is forming in the numerical, let's say integration of the domain. That integral domain is basically dx, dy, dz. So there it is being connected. So we can't detach both of them in a unique way. Rather, it is a kind of interdependency of one other. I believe there is a kind of connection on one to other. If you look at especially Jacobian formation, it is dou xi by dou x, dou eta by dou x and all, where your x and y coordinates and the natural coordinates are mapping together. I believe there is a integration of one or a dependency of one onto other. Okay. What is adaptive? That is HPR and HP adaptation. Okay. So see, H refinement is very simple, where let's say you have a beam and I am dividing this into, let's say 10 elements initially. Now I will find out what is the solution of it. Let's say that is not up to the mark, then I will go for further increasing the number of elements. Let's say instead of 10 elements, I will make it 20 elements. That is where you have H refinement. That means element edge length we are decreasing, but the same type of element, whether it is a linear element, quadratic element, whatever the kind of element you are using, same element, but number of elements you are increasing. That is where you are having H refinement. Now comes to the P refinement, the polynomial order. Let's say I have one element, one dimensional. Now I have two nodes, that is initially, and I have done the analysis. Let's say I have 10 elements, each element having two nodes only, and then I have done the analysis. Let's say I am not comfortable with that and I'm looking for, let's say, more, let's say, bending kind of one. Then you try to see that there is by introducing one more node, instead of two, I can introduce one more having 3 nodes. Then it is better to have a more flexible or make it more polynomial order, so that you can represent your displacement field. So that is the polynomial order increasing by increasing the number of nodes, usually mid-side nodes. By using those mid-side nodes, you can have the better quality of results. But I am not sure what do you mean by R refinement. Truly speaking, I am sorry, I didn't know about R refinement. And HP adaptation, where you can, increasing the number of elements, increasing the number of nodes, both together you can go for. I think that is HP refinement, if I understood correctly this thing. And R refinement, sorry, I didn't know what is the R refinement. And best book for Abacus software. So what I suggest is, when you go for Abacus kind of, or ANSYS for that matter, doesn't matter whether it is this or that. Truly speaking, I am representing Dassault Center, and we are having Abacus software, as well as the academic version of ANSYS also we are having. And I am, very recently we got into Abacus, but earlier we used to use ANSYS very extensively. These two are quite, very versatile in terms of their, help manuals. Especially if you look at, if possible, I'll share my, screen where you can look at the ANSYS help manual. So it's very informative. You can look at theory manual, user manual. Yeah. So this is, and maybe I'll be if possible, I'll pay attention on one very important aspect is with respect to verification manual, especially in ANSYS. If you look at, there is a good number of verification problems are available. Whenever you are working, you make sure that whatever your learning process, you make sure that you should able to go through all these verification manual. So mechanical APDL, in this there is a verification manual, theory manual, and there is a verification. Yeah, here if you look at, there is a verification manual, mechanical APDL. So it starts from VM, V stands for verification, M stands for manual, verification manual, 1, 2, 3, 4, all these are available. Just clicking randomly, and then you can have so many example problems are available. You can just practice one after another. I think this is the best resource, I believe, rather than you can look at maybe any other book is available, but I believe their reference manuals and YouTube videos, especially for these kind of softwares, these are commercial people, they want to emphasize or they want to commercialize their product to the greater extent, so they're quite extensive. YouTube videos are available. You can just type whatever the kind of analysis you want, it is available. And more importantly, I believe this is very good manual what they prepared in terms of verification manual. And also very good thing is what is the input listing. You can just copy and paste it in the APDL. I'm just talking about mechanical APDL. I'm not very comfortable with Workbench, so I'm just talking about this. I'm an old guy, so I'm looking at APDL. So this is what we can make use of it. And thanks Chauhan ji, thanks Sandeep, and that's all. Okay.
Uh, Thank you so much, sir, for your interactive and informative session. And we are very delightful to have you, and you have spared very valuable time with us. Thank you so much, sir. And on
Thanks.
behalf of FDP team and Government Engineering College Bharuch, I thank on their side also. Thank you so much, sir.
Thanks a lot for kind patience of all the participants. All the best.
Thank
Thank
you,
you.
sir.
Thank you.
हेलो
हाँ पराग भाई.
हाँ आशीष सर पीपीटी शेयर કરી શકો ને
हाँ करो करो.
હા
માઇકની બાજુમાં એરો કી હશે સર.
હા
હા.
A very good afternoon to all of you.
is it visible on your
Yes,
screen?
yes પરાગ ભાઈ.
Yes, yes.
Okay, what if I want to do annotations?
It is as per the provision of Microsoft PowerPoint presentation.
Okay, can you see the PPT on your screen?
Not right now.
You are not able to see? Okay.
Yes.
Okay. Presenting give control.
So no need. You have full control. You are presenter right now.
Okay.
Don't give control to anybody else.
Okay. But then why it is not coming to the screen? I have already started sharing, but
We can see that. We can see that screen.
you can see PPT.
Yes.
Okay.
Right now we are saying the Microsoft team from your side.
Okay.
Just minimize this screen, sir.
Okay. Right. Is it fine now?
Yes, sir.
Okay. You can see, huh? Fine.
Yes.
Okay. Yeah. Please go ahead.
Yes, madam. you
Good
can start.
afternoon, Parag. Yeah, good afternoon, Parag sir, and good afternoon to all participants attending. Dr. Parag Rajpara is presently working as an assistant professor in the Department of Mechanical Engineering at Marwari University, Rajkot, India. He received his PhD in August 2019 from Sardar Vallabhbhai in National Institute of Technology, Surat, India. He has completed his MTech in turbo machines from Surat in 2011. He has passed his BE in Aeronautical Engineering in Propulsion Division from the Aeronautical Society of India, New Delhi. He has published papers in international journals and national and international conferences of reputed. His research interest includes combustion, heat transfer, and CFD. I, on behalf of Government Engineering College and FDP team, sir, I welcome you and invite you to deliver the session, sir. Please.
Okay, ma'am. Thank you so much for the introduction. And first of all, good
You're
afternoon
welcome,
to
sir.
everyone. I welcome you all in this session, which is on computational fluid dynamics. I hope that I am clearly audible to everyone.
Yes, sir.
Fine. Okay. So welcome you all in this session, which is on computational fluid dynamics, or what we call it as CFD, right? And this session is mainly organized to discuss some of the basic principles, the governing fundamental governing principles which governs the implementation of CFD in practical applications. So we will emphasize on the basic principles, and also we will yeah. Is there any query? Okay.
No, sir. You continue. I think someone's mic is on. You can continue, sir.
Okay, fine. So we will emphasize on the basics of CFD, and we will also look into the applications of CFD by taking an example, right? So basically in this session we will try to learn, we will try to discuss, we will try to understand the fundamental principles that govern the implementation of CFD in practical applications, right? So, see, before you start talking about computational fluid dynamics, or what you say CFD, right? The first question that should come in our mind, that what is CFD? Then the second question is why we are doing CFD, or why we need to do the CFD. And the third question is when should we do CFD, right? So we will try to find the answers of these questions one by one as we will proceed into the session, right? So first thing is, what is CFD? So you might have some basic knowledge about what is CFD. You might be using different CFD codes in your research work, or in your academics, right? So you might have some basic understanding about what is CFD. So we know that the full form is computational fluid dynamics, but the its scope is not limited to the fluid dynamics problems. Although the name is computational fluid dynamics, but its scope is not limited to the fluid dynamical problems. When we say CFD, that means we essentially mean that it's a computational transport phenomena. So it does not involve only fluid dynamical problems. It may be any kind of the problems, it may be any kind of the process which involves transport phenomena. So it may be a heat transfer problem, it may be a mass transfer problem, it may be fluid structure interaction problems, right? Any process which involves the transport phenomena. Then second question is when to do the CFD. So we will try to find the answer of this question also. We will see that what are the important and challenging applications we have these days, right, where we need to we need to implement the CFD. What are the challenging and interesting applications we have where we need to implement the CFD? Fine. We will also try to find the answer, that is CFD inevitable? Are there any other approaches available to solve the fluid dynamical problems, or to solve the problems related to the transport phenomena? So that is the third question, that why CFD? What are the alternative approaches? What are the other approaches to solve the transport phenomena? Fine. So here is the outline of the presentation, right? We will talk about. We will start from the basics. We will try to understand what is fluid dynamics. What are the approaches to solve the fluid dynamical problems, right? Then we will come to some of the interesting applications of CFD, right? Then we will discuss about the strategy of CFD in solving the fluid dynamic problems. Basically, see, CFD is all about uh, it is an approach, we can say, where the continuous problem domain is replaced with a discrete domain. So basically what we do is, in CFD we get approximate solution, we get the solution of any field variable at discrete points. So continuity of the problem domain gets gets sacrificed ultimately, right? But there are benefits also. We will discuss about the positive as well as negative points of all the approaches, right? We will discuss in detail about what is the methodology that we are following in CFD analysis, what is the strategy of CFD. So ultimately what do we do is, the first step and the most important step in CFD analysis is dividing your flow domain into smaller subdomains. So this process we call it as a discretization process. And then whatever the nodes or elements or what we say subdomains or control volumes, it depends upon which kind of discretization method you are using. So we solve the governing equations. It may be partial differential equations or ordinary differential equations, and we convert them into the algebraic equations. Fine. So we will see the different discretization methods, right? We will also talk about the plus and minus points of different discretization methods, which method will be suitable for your problem, for your case. Fine. And how to decide that this method is more appropriate than the other method, right? Then we will explore the different features of a commercial CFD software, ANSYS Fluent. It is a very popular and useful tool, right? Which is used to solve the transport phenomena problems, right? So we will take an example. With a specific example, we will explore this tool and we will see the different options, different features, right? um, uh, um, by taking the specific example. And in the last, I will look in. I mean, we will look into. We will see that what are the opportunities that CFD offers in different areas. Fine. So now let's understand that first of all, what is fluid dynamics? And then we will try to understand that if you want to solve any fluid dynamical problems, then what are the procedures or what are the approaches that we have available? What are the conventional approaches that we are having, right, to solve any fluid dynamical problems? So see, we all know that fluid dynamics is a sub-discipline of fluid mechanics, which ultimately describes the behavior of fluid when it is in motion. So it describes the flow of a fluid. It has the further sub-disciplines like aerospace, then hydrodynamics. Aerospace is a discipline where we are interested to study the behavior of air when it is in motion. Similarly, hydrodynamics is a we can say sub branch of fluid dynamics, where we are interested to study the motion of liquid when it is in motion. It has many applications. It has a wide range of applications, which includes not only these are the traditional applications: aerospace, automobile, hydrodynamics. These are the traditional applications. Other applications, or we can say non-traditional applications, not so traditional. So like that, meteorology, oceanography, then of course combustion energy generation, and there are many other applications. These are some of the few applications that we have highlighted here. Fine. Now, the most important thing is the solution to the fluid dynamics problems. Right? The solution of this fluid dynamic problems is mainly based upon the fundamental governing equations. Fine. Now, these equations are a set of mathematical statements which describes the physics of the problem, and your entire fluid dynamics is based on this mathematical statements. So from where do we derive, from where do we get these mathematical statements, from where do we get these governing equations, or which is the factor, which is the means which is the factor which governs this fundamental governing equations of fluid dynamics. So these equations are mainly governed by the fundamental principles of conservation. So to understand the principles of conservation, we will try to understand the principle of conservation by taking an example. See, conservation means it may be a conservation of any field variable. It may be a conservation of any fluid property. Let's say if you talk about fluid dynamical problems, it may be a conservation of mass, it may be a conservation of momentum or energy or species or any other variable. But before we talk about the conservation of mass, momentum or energy, right, let us try to understand the fundamental principle of conservation by taking an example of not mass transfer or momentum transfer or not energy transfer. Let us take an example of money transfer. For example, we will try to understand the fundamental principle of conservation by taking an example of money transfer, and then later on we will apply this concept to the transport of mass or momentum or energy like that, right? So what essentially does the conservation talk about? What is conservation, or what is the principle of conservation? So let's take this example and try to understand the fundamental principle of conservation, right? Suppose you have a bank account. We are taking an example of money transfer. Supposedly you have a bank account. Fine. Now we are talking about the ancient times. We are not talking about the today's time where we have ATM and digital transfer facility and everything. Let's think about the ancient time. Suppose you have a bank account and you want to transfer some money to the bank account, right? So let's say you go to the bank and you transfer some money to your bank account. So you are depositing. So it is in what we can say that is given to the bank account. So you are depositing. So it is ultimately your bank account is enriching, right? So it is in, let's say. So you are depositing, you are transferring some money to your bank account. Now let's say you think that you want to withdraw some money from your bank account on some day, right? And again you go to the bank on some day and you withdraw some money from your bank account. So you are taking it out from the bank account. So let's say it is going out of the bank account. So let us say this is out. Fine. So what will be the change in the balance in your account? Will it be in minus out? What will be the change in the balance in your account? Will it be in minus out? No. Why? Because whatever the money that you are holding in your account, right? The bank is paying some interest on that. So some source is there, and this source comes through the interest that the bank is paying to you on the amount that you are holding in your account. So this is the money that comes in the form of interest. So this is the generation of the amount. You can say this is the generation of the amount in your bank account. Then what will be the change in the balance? What will be the net balance in your account? So if you want to calculate that, then what you have to do is the total money that you have transferred to your bank account, that is in, minus the money that you have withdrawn from the bank account, so minus out, plus the money that has been deposited or which has come through the interest paid by the bank. So that is your interest. or you can say generation of the money, right? So this is nothing but it is equal to the change in money or change in balance in your account. So this is ultimately the balancing of what is going in and what is coming out, right? And that is nothing but that is the net change in the money that is remaining in your bank account. So we can say this is a statement of the conservation of balance in your account. Fine. So see, whether you believe it or not, this principle governs the conservation of any physical variable. We are talking about the fluid dynamic problem. So this principle of conservation, right, this statement of conservation of your balance in the bank account, this principle is applicable to any other physical variable. It may be your mass, momentum, heat, mass, whatever it is. Normally, what do we do is this change in the variable, right? We represent in terms of rate. So we can say that the rate of input minus rate of output plus the rate of generation is equal to the rate of change of your balance in your bank account. So if you see this block, right? If you see this block here, this is a specified region through which your field, property, or you can say your variable is it's transporting. It may be a transport of mass or momentum or energy, whatever. Or your quantity is what we can say it is flowing. So this specified region is known as a control volume, right? So this fundamental principles of conservation, it can be applied to any transport quantity which may be a mass or momentum or energy, and it can be represented in terms of these mathematical statements. Ultimately, these equations or these mathematical statements are they are representing the physics of the problem, and your all fluid dynamics is based on this, right? So now we have understood that what is fluid dynamics and what is the fundamental principle of conservation. Now the question is, if you want to solve any fluid dynamic problem, or let's say transport phenomena problem, right, then what are the approaches available to solve the fluid dynamical problems? See, of course, this session is on CFD, so we should not we should know what is CFD and whether the CFD is inevitable. Is CFD necessary in all the problems, or it is necessary in all the cases? If it is not, then what are the other approaches? See, we should not be biased towards the CFD, because we are having this session on CFD. So we have to find the answer that when we need to apply the CFD, when we need to use CFD, and why we need to use CFD. So we have to understand the other alternative approaches. We have to compare the other approaches that we have, and from that we can find out some conclusion that why CFD is important. If it is important, that where it is applied, in what kind of problems we can solve through CFD. Is it applicable to every flow problem, every fluid dynamics problem, right? So we have to find these answers, and for that we need to understand the different approaches available for us. Fine. So see, by this time we understood that CFD is nothing but it is a numerical simulation of some governing equations for solving the transport phenomena problems. But if you want to solve the transport phenomena problem, then you could have the other approaches like analytical approach and experimental approach. So the question is when we should prefer the other approaches and when we should prefer the CFD. So let's try to look into that and let us talk about first experimental investigation or experimental approach. See, we should keep in mind that experimental approach is it is very accurate method, and there is no substitute for experimentation, right? Because see, in experiments, whatever experiments tell you the reality, right? So whatever you will see, you will believe it. In case of numerical solutions, what do is we do a sort of idealizations when we are doing the numerical modeling. But in experiments, whatever we see is what the reality is. Of course, there are certain restrictions, there are certain limitations in experimental modeling also. Supposedly, if you want to do the experimental modeling in a full scale, then it is very much expensive and often it is impossible. Let's say you are designing an aircraft. So before you come up with the final dimensions of the aircraft, right, you have to make a lot of trial experiments with a real size aircraft or prototype. Then it becomes very expensive. And in addition to that, see, just like any tool which has some errors, experiments are also having some important errors which are associated with the measurements. So these measurement errors are also one of the issue that is associated with the experimentation. Supposedly, many times full-scale experimentation may not be possible because of several limitations. So one can go with scale modeling. It may be reduce scale, or sometimes it may be you have to use enlarged scale depending upon the problem that you are solving. But again, scale modeling is it is simple, but it is very much difficult to extrapolate the results from the models, because they will not be able to demonstrate what will happen with the prototype. Sometimes it may be because of incomplete similarities. Similarities like, for example, geometrical similarities or kinematic similarities or dynamic similarities. All these similarities may not be properly maintained. And always, whether you are doing full-scale experimentation or you are doing experimentation with means you are going with scale modeling, measurement errors are always the issue associated with the experimental investigation. Fine. So there are some positive points, there are some restrictions, or we cannot say we will not say negative points, but we will say some restrictions, some limitations are there associated with the experimental approach. Right. So this is all about the experimental investigation. Next is theoretical calculations. See, when you are solving the same problem with theoretical approach, then you will have two sorts of approaches. One is analytical approach, the another one is numerical approach. If suppose the problem that you are solving, if the analytical solution exists for that problem, then it is like nothing. Analytical solution is very simple. It gives you exact point-to-point solution. But these analytical solutions are possible for very simple flow problems. However, most of the practical cases for most of the practical problems, right? You don't have simple flow problems. You have very complex flow problems, and therefore, for most of the practical cases, the analytical solution does not exist, and it exists only for the few cases. So here comes the role of the third approach, which we know as a philosophy of computational fluid dynamics. CFD can be applied to almost all the practical problems, all the practical fluid dynamical problems. But here you have to remember one thing, that CFD cannot stand alone by itself, right? It needs the help of analytical as well as experimental solutions, because see, you need to validate your results, you need to benchmark your solutions. Suppose if you are solving any complex fluid flow problems, and if you have written some code or if you have developed some code, how will you verify your results? How you will validate your results, or how you will validate your code? So you can validate your code against some problems which are standardized in their solutions, either by analytical means, or there are some benchmark experiments with which you can compare your results and you can validate your code. So we cannot discuss CFD without considering the other approaches like analytical approach and experimental approach or experimental solutions, right? So if you are going with numerical solutions, we can say that the numerical solutions exist for almost all kind of the problems, for every problems. But whenever you gain something, you lose something also. Whenever we say that the numerical solutions, that means we do not get exact solution, we get solution at discrete points and not at all points in the domain, because that is the heart and soul of CFD. That is what we do in CFD. We get solution at discrete points, right? We do not get the solution at all the points in your problem domain. So ultimately, the continuous nature of the solution gets sacrificed. But definitely, the advantage is that you can solve any complex problem and you will get the solution for complex problems. So if you compare the modeling versus experimentation, right, then what are the advantages of modeling? See, the modeling is, of course, it is cheaper. It is not free. Numerical simulations or CFD analysis, it is not completely free, but of course it is cheaper if you are comparing with experimentation, right? Why it is cheaper? Because supposedly you have a code and you are doing some simulations. You can use that code for several different cases, and you can where expenses do not matter. You can use the same code with different parameters, with different conditions, right? So it gives you this freedom. But of course, the computation is not completely free. If suppose you want to solve some complex problems, then you have to use parallel computing, and you need to, it means you will incur a lot of computational time when you need to solve any complex problem. Fine. Then the numerical simulations or the modeling, when you are modeling, you get more clear and complete information, because with experiments you cannot get all the details of all the variables which you are looking for in your problem. But in CFD modeling, it is possible to get all the details, complete information and clear information through the modeling. But in experiments, sometimes it is very difficult, or it may not be possible. Right? For example, let's say if you want to do the measurement of let's say pressure or temperature or any other property, of course you can do that within a complete flow field by simulations, right? But you can also do it by experiment, but that will result into lot of expenses, lot of complexity will increase. Fine. Then the third point is, one can handle any degree of complexity as long as it is fine. So in simulations, whether you want to believe your simulations or not, that depends upon the level of input that you are giving. Level of input means the material properties, right? Like thermophysical properties when you are solving the fluid flow problems. If you give proper inputs, it will be good. And for proper data, you must have some reliable source. Fine. Apart from that, you have to represent the physics of the problem by applying the proper boundary conditions. If you want accurate results, if you want more realistic solutions, right? You need to take care about this parameters, like you have to take care about the boundary conditions, you have to take care about the property data, you have to take care about the governing equations, models which are appropriate for your problem. So you must have some basic knowledge of means you must have the knowledge of fundamentals of fluid mechanics, heat transfer, thermodynamics, right? And you must have some knowledge about the CFD codes, right? So you have to keep in mind that whenever you are doing CFD modeling, right, you are dealing with the mathematical descriptions. It is all about the mathematical models, mathematical statements, right? So this mathematical description, it may be correspond to the reality, it may not be correspond to the reality, right? So you have to be very precise about this parameters, like for example the material property, then boundary conditions, and the model that is required to solve the problems, right? So we can say these are the advantages, but there are limitations also, because modeling is dealing with mathematical description, so it may not be correspond to what the reality is, and mathematical description can be inadequate. Fine. So we have to consider this means we have to keep this in our mind. Fine. So ultimately, if you sum up what we have understood by this time, that CFD is it is a science of the predicting fluid flow, heat transfer, mass transfer, chemical reactions, and other related phenomena by solving numerically a set of governing mathematical equations. Right? These governing equations are mathematical statements which are based on the principle of conservation, right? Which ultimately describes the physics of the problem. Then we have also seen that why CFD is important, because most of the real problems are complex in nature. Most of the engineering problems are very complex problems, the governing equations that we are having are coupled and nonlinear partial differential equations. Sometimes the equations become so longer that if you try to solve these equations analytically, then it may be possible that you may miss the physics behind that if you are going with analytical solution. So it is not possible to solve these equations analytically in most of the engineering problems. But it is possible to obtain the approximate solutions of these governing equations, right, through a computer based modeling, and this is what the subject matter of computational fluid dynamics is. So of course CFD is we can say that it is an equal partner with pure theory and pure experiments wherever it comes to the analysis and solution of the fluid dynamic problems. What do we do in CFD is that we create a virtual prototype and we do the numerical experiments in order to find out the solutions, right, before we design the actual prototype, right. It is CFD helps to test the virtual prototype, and you can analyze the different situations. You can change number of variables, you can study the results, right, and you can find out your optimum design. Fine. So this is what the importance of CFD is. Now when it comes to the benefits of CFD, so far from our discussion we understood that whenever you want to solve the complex problems related to the fluid dynamics, right, without CFD it is quite impossible, we can say. CFD complements both experimental and theoretical fluid dynamics, right? So it is we can say it provides alternative cost effective means of simulating your real flows. How the CFD helps you to solve the complex problem? If you talk about the insight of CFD, then it provides you better visualization and enhanced understanding of the fluid flow that help you to find the optimum configuration for your system or optimum design for your system that you are going to develop. What is the foresight? See, testing many variations until you arrive at optimum result before physical prototyping and testing. So ultimately you can test any system, any virtual prototype, and you can do the variation in terms of parameters, conditions, whatever kind of variations, whatever situations you have, any number of situations, any number of variations you can do until you arrive at your optimum solution. So that reduces your overall costing, that your expenses, right, that you need to do for if you directly go with experimentation. So experimental trials will be reduced. Practically, CFD helps you to find out your optimum design without any added expenses. You can do unlimited level of simulations, and you can get unlimited level of details of your results at virtually no added expenses. Fine. So these are we can say that some of the important points which highlights the benefits of CFD. Now, right, so it has been highlighted here also. There are a few points which ultimately speaks about why CFD and what are the major benefits of CFD. So ultimately the simulation results in prediction of the flow fields and engineering parameters, they are very useful in design and optimization of any process or any equipments or any system, right? There will be substantial reduction of the lead times and cost of new design. Fine. Then you will have the ability to study the systems where the control experiments are very difficult, or sometimes it may be impossible to perform in case of very large systems, just like we have taken an example of aircraft. We can have the ability to study systems under hazardous conditions at and beyond their normal performance limit. So you can have safety studies and accident scenarios. So suppose you talk about application of CFD in automobiles. You are interested to study the flow over a outer body. You are interested to study about the interior, like for example, if you want to design the air conditioning and ventilation systems for better comfort of the passengers, right? So this kind of real problems can be addressed, and CFD has a potential to play an important role in this kind of real problems. Fine. So yes, through these pictures, right, it highlights these 4 points, or we can say the 4 major benefits. First of all, it reduces the system cost. It helps to understand the problems, helps to analyze the problems, helps to find out the optimum design. It also helps to improve the performance of your system. Fine. And we can say that it reduces the design time and the overall cost that you need for experimentation or to develop your product or system, whatever it is. Now, we are going to look into some of the applications of CFD, some of the interesting applications, right, of CFD in next few slides. So let us see the first application, that is the application of CFD in aerospace. It is, we can say, one of the most common and traditional application, right? So let us consider this. Let us say you have an aircraft. When you say aircraft, then aircraft has interior and exterior both. If you consider the interior, then it includes the design of your air conditioning and ventilation systems like that. When you have an exterior, then you basically consider flow over an airfoil section, which you are intending to model, for example, right? So supposedly the other components, like for example, you have a combustion chamber, right? So you want to know the transport phenomena within the combustion chamber, how the reactions are taking place, what is the performance, right? What are the emissions and what is the efficiency and all these things. So we want to understand the reaction chemistry, we want to understand the transport phenomena. So one can have CFD for this kind of applications. One can have CFD for a spacecraft application also, right? Then the another traditional approach is automotive application of CFD in automobile. So again, here the basic philosophy is same. You want to see the fluid flow behavior inside the car. The whole idea is to design the car so that passenger feel comfortable. Other important consideration, like how the fluid flow takes place in the outer body, right? And what will be the resistance, drag resistance across the car, means how the flow takes place outside the across the car body, and how to determine the drag force on the car. Also you have a combustion chamber design is also very, very important, right? So CFD has potential to do this kind of analysis in automobile applications also. So when we say automobile or aerospace applications, these are very traditional applications of CFD. But when there are many applications which are not so traditional, right? And but they are important, and they are used in modern days where we are using CFD. So one of the application is biomedical, right? So you can see that this is a human heart, which is modeled as a pump in CFD, right? Then you can see this also the flow through arteries, where This is very interesting case where the fluid flow analysis is very, very important, right? So next, CFD is it has a lot of applications in chemical industries also, right? Whenever there is a mixing of two fluid streams, or whenever there is a separation or injection of the fluid streams, right? This type of complex problems we can capture by CFD. CFD has a very big role in solving this kind of problems, right? Now, see, chemical application is a sort of traditional application, right? But you have applications of CFD in designing the electronic devices also, right? So this we know that with the advent of electronic devices, the sizes of the electronic devices are getting more and more reduced nowadays, right? So supposedly you have some you have same power rating. Then what you want to do? You have to dissipate more and more amount of heat. If you want to have more and more heat dissipation, then you have to design efficient cooling system. No matter whether it's your laptop or desktop or any other electronic device, you require efficient cooling strategies. So if you are cooling your electronic device by different means, for example, if you are using a fan cooling or any other technology, then you have to assess that what is the fluid flow and heat transfer around the flow passage in your electronic device, right? So this is we can say one of the very important application of CFD in uh, uh, electronics engineering. Then there are, see, lot of applications of CFD in energy related areas. Like for example, you have a wind turbine, then flow over a wind turbine, then heat transfer and mass transfer in IC engines, or let's say, for example, this is a picture of the Francis turbine runner. This is a draft tube of the hydroelectric power plant, right? So to understand the fluid flow, heat transfer, mass transfer in many of these applications, right? It is very, 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 very critical. So CFD plays a very big role towards understanding this phenomena. Fine. Then, see, when we talk about fluids, right? Many time what happens that we forget that the fluid interacts with the boundary of your domain, and this gives rise to what we say fluid structure interaction. Fine. So what is fluid structure interaction, or we say FSI? Whenever you want to solve any FSI related problem, right, it is important to model CFD with a structural model, because CFD is a fluid dynamic model. So you have to couple your structural model with a fluid dynamic problem, a fluid dynamic model. So it's a two-way coupling, we can say. It is more complicated problem, right? So generally FSI speaks about structure, and whenever the fluid will interact with the structure, with the boundary, right, it will have some sort of vibrations, and when it will respond, when your structure will respond to the fluid, then there will be modification in the velocity field within the fluid. So when the fluid will interact with the structure, there will be a deformation in the structure. When the structure will give the respond, when it will respond, then there will be change in the velocity field within the flow. So there is a great means we can say challenge to consider this two-way coupling, or we can say dynamic coupling, right? When you are modeling this kind of problems related to fluid structure interaction. Fine. Then see for larger scale problems, CFD has applications in marine engineering also. Right. For example, you consider a flow past a ship or boat, or it may be submarine, right? This large components of the marine mainly relies on CFD nowadays, and lot of CFD analysis is going, is being going. It is running, right? Apart from that, if you consider the application of CFD in small scales, there are interesting applications of CFD in what we say microfluidics, or we can say the fluid flow at small scale in small micro channels, right? So mainly this microfluidics deals with the studies of fluid flow at a small scale. Usually what happens at small scale in micro channels, you do not have the advantage of turbulence because of very low Reynolds number, right? So if you want to mix the two streams of different fluids, right, then you have to do the efficient design of your system. So you have to do a clever designing of your geometry, right? There are many other ways also to improve the mixing, right? But in microfluidics, one of the important study that you have is, for example, if you can see this animation, one of the important studies concerning the droplet dynamics. So you can see this is a T type of junction, and because of the shearing, the droplets are produced. They are getting deformed, right? They are elongated. They are also compressed. So ultimately, they are deforming. And many times, suppose in some micro reactors, you put some reactants with these droplets to allow the reactions, right? To put in case of micro reactors. So the application of CFD, the CFD analysis of this kind of systems becomes very important. It becomes very crucial, right? So see, we have seen many applications of CFD in different areas. There are many other areas, like for example CFD application of CFD in turbo machines, then in material processing, in sports, and many other applications. Many other examples are there, right? So now the most important thing is the strategy of CFD, or how it works actually. We have understood what is CFD, what are the other approaches to the fluid dynamic problems, right? What are the benefits of CFD, and what are the interesting applications. Now the thing is, what is the strategy of CFD, or how it works actually? We say that it is a numerical modeling, right? So how does it work? What kind of strategy it follows? What are the processes that we have to do, right? So broadly we can say that CFD applies numerical method to develop the approximate solutions of the fundamental governing equations of fluid dynamics, right? So ultimately what happens in CFD is the continuous domain is replaced by the discrete domain by using a grid, right? Let's say, for example, we talk about a simple one-dimensional continuous domain. So let's say you have this one-dimensional domain where it is a continuous domain. Let's say this is your x equal to 0 and this is the length of this domain is, let's say, 1. So here it is x equal to 1. Now let's say that you have this quantity called pressure P, right? So if you want to describe this quantity, if you want to write or if you want to express this pressure in a continuous one-dimensional domain, then we can say that P is a function of x. Fine. So this quantity can be defined at every point in the domain whenever you have a continuous domain. Each flow variable can be defined at every point in the domain. But in case of discrete domain, supposedly this domain, if I divide this domain into small subdomains, and if I create these points, I can call it as a grid or you can call it as a node also. It depends upon the type of method that you are using. So if you create this grid points or if you create these elements or let's say control volume, whatever you say, right? Then in this case, in this discrete domain, this pressure will be defined at discrete points. It will not be defined at all the points of the domain. So your continuous nature of the domain will be sacrificed ultimately. It will get lost. So the accuracy of results, accuracy of your solution depends upon that how many grid points you have created. Fine. So in that case, your pressure will be defined as Pi will be equal to Pxi, where I is the number of grid points. It may be n number of grid points, right? So one can say that in CFD analysis, we can directly solve for the relevant flow variables at the grid points. And the values at other locations can be determined by interpolating the values at grid points. So your governing partial differential equations and the boundary conditions are defined in terms of continuous variables like pressure, velocity, etc. And one can approximate this in the discrete domain in terms of discrete variables like Pi, Vi, etc. Then your discrete system is a it is a large set of coupled algebraic equations in the discrete variables, right? And then if you want to set up the discrete system and if you want to solve the complex problems, then you need a very large number of repetitive calculations, which we call it as iterations, and that we can do it on digital computer. That is what the heart and soul of CFD. So by this time, what we understood is that CFD is a type of analysis which provides insights into solving the complex problems, and in fact not only the fluid flow problems but any kind of the transport phenomena, right? So you don't need to conduct real world experiments. You can have ability to test the effect of fluid flow on your designs, right? So CFD helps you to simulate the various problems pertaining to, if you take an example, let's say the problems related to vehicle aerodynamics, or it may be thermal heat transfer, turbulent flow, any problems. Now, what are the important steps? What is the methodology in CFD, or what are the important steps that you need to follow to get the solution using your CFD code, right? So here you can see in any CFD analysis, you need to follow these 3 steps. You can see these 3 steps that have been highlighted here. The first one is a pre-processing step. Second one is solution step, and the third one is the post-processing step. Let's talk about all the 3 steps one by one. What is pre-processing stage? See, this pre-processing will help you to define your parameters for the simulation. What you have to do in pre-processing stage is you have to identify first of all your domain of interest. Then you have to ultimately you have to create your geometry first. Then you have to divide your domain into several subdomains, which we call it as meshing. So you have to do the meshing. Apart from that, you have to define the properties of material. You have to apply the boundary conditions. You have to define the boundary types and boundary conditions in this pre-processing stage. See, this is the first step of CFD analysis, and this step is very, very crucial. This is very, very important step, because all the 3 steps of CFD analysis are interdependent. And that's why if you do if you do this pre-processing stage properly, right, then your CFD simulations, your results of your simulations will depend on that, whether you are doing this stage step properly or not. So earlier also I have told that you must have some reliable source to get exact data for your material, to get exact boundary conditions which should meet the physics of your problem, right? Then next step is the solution step, right? So in every simulation process, you have to go through these 3 steps. Fine. So in solution step, what you are going to do is you are going to apply the models which are required for the solution of your problem. You have to do the problem specification, and then you will do the numerical computation. Fine. And once your computation is over, once your simulations are converged, right, once the solution is done, then the final step is post-processing. Post-processing is a step where the results obtained from your simulation will be analyzed. You will use all the available methods, like for example, if you want to see the vector plots or contour plots or streamline patterns or data curves, etc. Whatever you want to see, you can do that in post-processing software, or you can do that in this final step. So ultimately, in this step, you will do the processes like you can do the calculation of the derived quantities. You can analyze various parameters. You can visualize the flow field, right? You can have the systematic data analysis, and you can also have the verification and validation of your CFD model, right? See, there are many commercial softwares or models are available for post-processing in CFD. Just to name a few, like for example, you have ANSYS CFD Post, you have ParaView, you have TechPlot 360, and there are many other tools available for post-processing, for analyzing your results obtained from CFD simulation, right? So here you see that the same thing has been explained here, so I'll just skip it, right? The details of pre-processing step, right? Then the details of the solution step has been explained here. So what do we do essentially in solution, right? We essentially what we do in CFD. In CFD, we are just replacing your governing differential equations with a set of algebraic equations, and this process we call it as discretization process. right? So now we will talk about what are the means. We will first try to understand what is discretization, what discretization essentially means. Then we will see what are the discretization methods. Fine. So in CFD, we have different methods for discretization process, for numerical discretization. So before we talk about discretization methods, we should understand the general philosophy of discretization, right? So in simple way, we can say that discretization is a process where we can transfer the continuous function into a discrete form of the function. Ultimately, it means that a continuous domain will be divided into the smaller subdomains, right? And for each subdomain, we will get approximate solution, and this is what we can say the basic concept of discretization. So if you sum up what is discretization is, then you can say that the first step in the discretization is to divide the domain into number of discrete subdomains. This subdomains, for example, let's say, let me take this example. Supposedly you have this domain 1D problem. If you divide this domain into number of subdomains, right? If you create this discrete points, right, then this discrete subdomains, you can call it as element also. You can call it as, let's say, this is your element 1, this is your element 2, this is your element 3, this is your element 4. All these elements are connected by these points. These points, you can call it as a grid point, or you can call them nodes also. It depends upon what discretization method you are using. But our main objective in CFD is to convert your partial differential equations into a system of algebraic equations, right? So we can see here the different methods available for numerical discretization. Like we have a finite difference method, then we have finite element method, and then we have finite volume method. Fine. See, I know that on very first day in first session, you have gone through the introduction to the finite element method. So you have the understanding of this methods. So we are not going to go deep into this method. We will just discuss these methods. We will discuss the discretization policy, and we will understand the basics only, and then we will try to compare these methods, right? That which method can be suitable to a specific problem, or which can be method, or which method will be more appropriate to solve your problem. So we will just do the discussion in order to understand the policy of these methods. Not we are not going to go into much detail. Fine. So see, the first method that we have is finite element method, right? We can discuss these methods, of course, in deeper and deeper, but we will not go deep into that. But that is not the objective of this session also, right? So what is FEM, finite element method? In FEM, the problem domain is mainly decomposed into the discrete number of subdomains. See, that is the step that we do in all the methods, in all the three methods, right? We decompose the domain, we divide the domain into discrete number of subdomains, and each subdomain is called as element. Whether it may be a, supposedly, for example, you have 2D or maybe a 3D domain. So you divide this domain into number of subdomains, right? So this type of elements you will generate, right? So this is what the discretization, or this is what the decomposition of the domain into number of subdomains, and each element, or sorry, each subdomain is called as an element. If you have a 2D or 3D domain, then you could have elements like this. If you have, let's say, 1D domain, right? Then when you discretize this domain into number of subdomains, then you could have elements like this. So each element is represented by, you can see they are connected by number of points or nodes. These points you can call it as a node, or you can call it as a grid point also. In this FEM method, finite element method, the accuracy of your solution, that depends upon the number of finite elements. If you have more number of elements, accuracy of your results will be greater, it will be more. But at the same time, your computational expense will increase, because see, you have to solve your field variable at more number of points, at more number of nodes. So you can write your algebraic equation at any element, right, corresponding to your governing differential equations, corresponding to the problem that you are solving. Fine, that is what essentially the FEM is, right? The another method that you have for numerical discretization is finite difference method. That is what we call it as FDM. Right. So our objective is to learn the important feature of these methods, right? So we will see that philosophically how these methods are differ from each other. That is what the only objective is. We have talked about FEM. Now what is the philosophy of FDM, and philosophically how they are different from each other? We can identify some of the plus and minus points of these methods. So what do we do in FDM? What is the philosophy of FDM? Right? So basically, in finite difference method, we manipulate the governing differential equations directly, and we represent the suitable algebraic equations by using what we call it as Taylor series expansion. Let's have this two-dimensional problem, right? Supposedly you have a two-dimensional problem, and if you discretize this domain using FDM, these are the grid points, or these are the nodes, right? Let's say this is a grid point. The name you are solving any field variable. It may be a temperature, pressure, or velocity, whatever it is, right? So let's say this is your point ij. So here you have this point which we call it as I plus 1 j. On the backward side you have this point that is I minus 1 j. It's a two-dimensional case, so the point on this upward side you have, that is I j plus 1. On the lower side you have I j minus 1. And let us say the size of the element, or size of this the discretization, this grid size is, let's say, delta x, for example, right? So how to transform your governing differential equations into a set of algebraic equations? Let us try to understand by taking a very simple example. We will illustrate the fundamental idea or fundamental concept of FDM, right, using a very simple equation. Let us have this 1D equation. So you can take an example of any problem. You can take an example of steady state heat conduction problem. Any one-dimensional equation you take, and try to explore the philosophy of FDM. Supposedly you have this one dimensional equation du by dx plus u raised to m equal to 0. So we will try to find out means we will try to derive a discrete representation of this equation. We will consider it is a linear equation. So let's say m equal to 1, so it becomes a linear equation. And let's say we have this one dimensional domain, right? And we have identified these points, let's say x1, x2, x3, x4, like that. And let us say the size is delta x, fine. So we have divided this domain. And one thing you have to understand that this is not an element like what we have seen in FEM method. What we are doing essentially is, it is similar to the FEM, that whatever we have did in FEM, it is similar to that, but there are conceptual differences, right? It is not element here. There is no logical element here. Fine. So there is no concept of element ultimately as such in FDM. You have discrete points. You have these grid points. Fine. So let's say that we have these grid points, and for example, in this one-dimensional domain, I want to express, or I'm interested to express the function. I want to solve this governing equation, right, at any grid point. So I have this governing equation du by dx at ith point plus ui is equal to 0. Now this I represents the value at grid point xi, right? So suppose in order to get the expression for du by dx in terms of u at the grid points, if you want discrete equation, right, then for example, let's say I want to find out the equation at this point. Let's say this is my ui point, this is my ui minus 1. It's a 1D problem, so I minus 1, and let's say this is ui plus 1. So this size is delta x, this size is also delta x, right? Now if I want to express this function or this variable u at I plus 1, ui plus 1, or you can say let's say for example, for simplicity I assume this is x, this is x plus h. Forget about delta x, I say this is h, and this is also h, and I say this is x minus h. For simplicity I am just writing. Later on we will talk in terms of u, but let's say we talk in terms of x. So I want to express the function at x plus h. So let's say the function at x plus h. So f x plus h is equal to function at x plus that is h into f dash x plus h square by 2 factorial f double x. This is the Taylor series expansion. Similarly, if you want to express the function at x minus h point, then you can write fx minus h is equal to fx plus h f dash x plus here it will be minus h into f dash x plus h square by 2 factorial f double dash x. And then you can write the discrete equation in terms of f dash x. So that will be like this: f dash x will be equal to f x plus h minus fx divided by h plus h square by not h square by 2 but h by 2, sorry, h by 2 factorial into f double dash x, right? So this is your discrete equation in terms of f dash x, right, which is equal to fx plus h minus fx upon h plus h by 2 f double dash x. Now if you truncate your Taylor series expansion up to this simple terms, then see this solution that you will get, that will be inaccurate solution. The inaccuracy will be maybe because of neglecting the higher order terms. So if you are neglecting the higher order terms, then whatever the error that is produced, that error is called as a truncation error. Fine. So similarly, see, since we have defined this, we have write this expression for x plus h point, right? And whatever the discrete form of equation we are getting, we can say this is a forward differencing method. Similarly, if you are writing for x minus h, then it becomes a backward differencing method, right? So ultimately, you can convert your differential equation into an algebraic equation in this form, right? And this method of deriving this discrete equation using the Taylor series expansion is called as a finite difference method. This is one of the very simple method, and it can be applied to a simple flow problems, right? We will see later on that what are the limitations or what are the benefits of different methods like FDM and FEM. We will compare them in between, right? So see, till now we have looked into these two methods of discretization. The third one is the finite volume method, that is FVM. But before you go into FVM, right, you should compare the different aspects of FDM and FEM. We can discuss the positive and negative of these two methods, and then we will look for the alternative method, that is what we call it as FVM, finite volume method, right? We will see that how FEM evolves as a natural consequence in terms of overcoming the limitations of FDM and FEM. FVM, this finite volume method, is it is established as a method which borrows or which takes the good points of two methods, these two methods FDM and FEM, and we will see that how it becomes inherently suitable for solving the fluid flow problems, fluid flow as well as heat transfer problems, right? So if you talk about FDM, finite difference method, right, one of the feature of FDM is its simplicity, but there are some issues also, right? For example, if you are dealing with complex geometry, then it becomes very difficult, or it is not convenient to use FDM in complex geometries because of its discretization policy, because it is based on Taylor series expansion, right? So if you use the Taylor series expansion, right, and if you remove the higher order terms from the Taylor series expansion, then what happens? Sometimes, suppose your grid size is larger, then the truncation error will also be very large. So that will result into the discrepancy on your results. So this is what you can say the limitation of your FDM. But if you consider FEM, suppose finite element method, it is relatively more complicated than FDM, because you need to go through more rigorous mathematical formulations to get your derivatives, Of course, your finite element method can handle the complex geometries, right? But it requires more computational power, and particularly for fluid dynamical problems, finite element method is not so appropriate, right? The reason is, it is because the fluid flow and heat transfer problems, right? The governing equations, the governing guiding principles are based on the principle of conservation, right? And in case of FEM, doesn't have that sense of conservation or conservativeness, right? And therefore, we can say that it can be applied to the structural mechanics problems, but for fluid flow and heat transfer problems, right? FEM has certain limitations. So with this in mind, the advantages and disadvantages of these two methods, right? You can talk about FVM, that is finite volume method, right? So what do we do in finite volume method basically? Uh, in fact, in any discretization process, what we do is we divide the domain into discrete number of subdomains. Fine, that is what the process that we do in all the methods. But in case of FVM, this subdomains are called as control volume. Then once you decompose your domain and once you create the control volumes, then in next step you integrate your governing differential equations over each control volume, and then you solve the integral form of your equations, right? This each and every control volume is represented by grid points or boundary nodes. You have a computational node and boundary nodes, and the value of your field variables at all the cell center are solved directly, while the values at the boundary nodes or other locations are obtained by suitable interpolations, right? So if you want to sum up, then we can say that your finite volume method is generally expected to provide better what we can say conservation properties. But again, see, the opinion is different on different points. So which method is more suitable to the specific problem or to your problem? The best answer is, or the best way is to decide that which method is suitable. The best way is to carry out the literature survey in the specific problem area, right? So that is what the answer to the question that which method is more suitable, because there are different opinions on different points. Of course, each and every method has certain advantages, certain limitations also. Fine. So this is what the different discretization methods. Then we have already talked about the post processing, that is the third step in the CFD analysis, right? Now, once you have the knowledge of the discretization methods or basics of CFD, you can say you can choose any CFD code to solve your problem, right? But before you go on to the numerical simulation, you must have clear understanding about the physics of the problem. See, we always make certain assumptions in numerical calculations, right? In order to reduce the complexity. And at the same time, see, whenever you do some assumptions, at the same time we have to take care about the important features of the problem, right? Because whatever the assumption that you are taking to reduce the complexity, you have to do these assumptions, you have to make these assumptions to a manageable level, because you have to preserve the important features of the problem, and that's why you need reliable sources. You need a very good CFD code which can produce the realistic results with good accuracy, right? So by this time we understood that CFD is a method which uses the numerical models to solve the fluid flow and heat transfer problems. But in CFD, either you can in CFD, either you can write your own code to solve a specific problem. For example, you can have your own program in MATLAB to solve, let's say, an example of incompressible pipe flow. If you want to solve that, you can write your own program in the MATLAB. Or the other way is you can use any commercial CFD softwares which are available. For example, some of the very useful and popular softwares, like you can use ANSYS Fluent or Star CD or CFX, OpenFOAM, COMSOL, and there are many other commercial softwares available, right? Which you can use to solve your fluid flow and heat transfer problems, and you can apply the appropriate numerical techniques. Fine. In this session, we are going to explore one of the very popular and useful commercial CFD package, which is known as ANSYS Fluent, right? This Fluent is a finite volume based software, right? And we can solve any fluid flow heat transfer related problems using ANSYS Fluent. So what I will do is I will talk about the important features of this tool with a specific example. We will take an example of reactive flow inside a combustion chamber. This is the problem on which I was working during my PhD. So we will see that how to do the simulation, how to perform the different steps of CFD using ANSYS Fluent software, and see in any CFD analysis. Now we know that these are the important steps that we have to follow, right? Which includes pre-analysis, means problem identification, then geometry and mesh generation, then physical setup, then numerical solution, and verification and validation. Fine. So pre-analysis means you have to, whenever you want to solve any real world problem, you must understand or you must observe first the real situation. You need to obtain the data pertaining to your problem, right? And you must have some previous experimental or numerical results with which you can compare your simulations. Then the next step is the geometry creation. You can use any modeling software. You can have ANSYS Workbench also, or there are many other CAD softwares available. You can create a geometry in one modeling software, and then you can import it into the other software for solution purpose, right? Then you have to do the meshing. Meshing is very important part of the simulation, and your simulation results mainly depends upon the quality of mesh that you have created. Then physical setup. In this particular step, you have to give the inputs for physical for physics which is involved. You have to also apply the boundary conditions, material properties, and the solution accuracy. You have to take care about these steps. Fine. So what is ANSYS Workbench? See, ANSYS Workbench is a graphical user interface which allows you to use all the tools or the software from a single platform. You can access all the models like pre-processing, solver, post-processing. All these functions you can access through a single tool, through a single platform. Now you see this picture. When you open the ANSYS Workbench, right, the first screen that will be visible to you is this screen, right? You can perform different types of analysis. You can see here this toolbox is there. There are different modules like analysis system, component system, custom systems, design exploration, ACT, right? So you can see there are different types of analysis you can perform through a single platform, through a single tool. You can have analysis of static structural problems or transient thermal problems or fluid flow problems. Any kind of analysis you can do from this software. Once you select the required analysis system, for example, if you want to solve any static structural problem, you just drag it here on this whiteboard or on this interface, right? And then you can perform the sequence of operations which requires in any CFD analysis. Like you can perform, it means you can define the engineering data, material properties and all these things. You can create your geometry, or even if you have created the geometry in some different modeling tool, then you can import the geometry here. Then the next process is like, for example, you define your means you develop your mesh, you create the physical setup, means you define your models and boundary conditions and everything, and then you can do the solutions, means you can run your simulation, and then you can do the analysis of your results from single single platform, right? So all the tools are given here which are required for your simulation. You can access all of them through this single interface. Now we will try to know the important features of this software by taking an example of CFD analysis of gas turbine combustor, right? So this was the means I was working on this problem during my PhD, and I have done the numerical parametric investigation on this gas turbine combustor geometry. This is a schematic diagram which highlights the dimensions of this geometry. My interest was to find out the optimum configuration of this geometry, which can give me better performance characteristics in terms of combustion and emissions, right? So what I did is, in CFD analysis, I have studied the flow and combustion phenomena of this combustor model for different situations, for different conditions, and for different variables also, and then validated this CFD results with experiments. So I'm going to show you how we can perform simulation to solve a specific problem using this particular software, ANSYS Fluent, right? I'll show that how the solution of this type of problem, this type of complex problem, can be obtained. What are the features available in ANSYS Fluent? How to select different physical models for any particular problem, right? What are the solution methods available? How to execute the program, and then how to examine and analyze the results in ANSYS Fluent. So we will see step-by-step procedure. Here you see the first step in any CFD analysis is to create the model of your flow domain. So you have a feature, you have a design modeler, ANSYS design modeler, wherein you can create the geometry of your flow domain. Even you can use any other CAD or CAE software, right? And you can import the geometry from other design software in a particular format. There are different formats available. Like, for example, you can import in IGES format or step format, etc. And then you can do the rest of the steps you can complete in this software. Fine. So that is the first step of any CFD analysis. Now you see, if you will do the CFD analysis using ANSYS, right, then you will see that once your task is complete, if suppose you are creating the geometry, once the geometry is completed, right, here you will see that this tick mark will appear. That shows that this step is now complete. You can go on to the next step. And the next step in CFD analysis is to generate meshing. You have different mesh generation methods. Of course, we are not going to talk about the different mesh generation methods here, but just if you will explore the ANSYS workbench, right, you will see that you have different types of the mesh elements you can create. You have different mesh generation methods, and you can create the mesh. Even you can create the mesh in any other software also, and you can import them. You import your geometry in ANSYS. But this step is very crucial. It is very important because the quality of your mesh will ultimately decide your accuracy of the results. It will also influence the speed of your simulation. If you are creating a very fine mesh, obviously the number of elements are much higher, so it will take a lot of time to reach at the convergence. But ultimately, if you are having a very fine mesh, then obviously the accuracy of your solution will be better. Fine. So this is the second step, right? After modeling, you have to generate the mesh. Now, once you generate the mesh, you see that again the tick mark is appeared here. That means your mesh is generated. Now you go for the solution process. You go for the physical setup. The next step is physical setup. Fine. So what you do is, when you go for the solution process, now we are going to solve this problem using ANSYS Fluent. So what do we do is, you open the ANSYS Fluent. When you will launch your Fluent, you will see this is the first screen that will appear on your desktop. So what you have to do here, you have to mainly specify the type of solver that you want to apply. What kind of geometry you have. Supposedly, if you have a 2D geometry, you have to select 2D. If you have a 3D geometry, you have to select 3D. Also, you have an option that what type of accuracy you want. If you want more accuracy, you can go with double precision, or in normal cases, we do not go with double precision because it will incur a lot of computational time. Then you have processing options available, like you have serial and parallel options. If you select serial option, then computer will simulation will run through. It will select only one core of your computer processor. If suppose you want to use more number of cores, right, you can go with parallel computing. If suppose your problem is very complex and your mesh elements are very large, or if you want to do parallel computing, if you want to connect other computer nodes also, right, then you can go with the parallel processing. Fine. So ultimately you can decide, you can select how many cores you want to use in your simulation. Now when you press this OK button, and when you go into the Fluent, right, you can see this is the screen that will appear here. Here you can see all the tabs that you have to deal with. There are different tabs here, like meshing, solution setup, solution controls, and results analysis. Whenever you will press a particular tab, right, the details of the selected tab will appear here. This is a graphical display wherein you can see your geometry. Here you will see your numerical results during the calculations. The first tab in simulation step, the first tab is the general tab. This tab will allow you to describe your problem's physics, and it will also help you to control the simulation. For example, you can see when you will open the general tab, you can see there are different options given here. You can define the type of the case, whether it is a steady problem or transient problem, you can select. Whether it is a pressure based solver or whether it is density based. Suppose if you are solving incompressible flow, you will go with pressure based solver. If you have a compressible flow where density variation is involved, then you can go with density based solver, right? So this is what the general tab option. Then you have models. The next tab is models. Here you will define the governing equations that you want to solve in your problem, right? If you have a multiphase, then you have to select the multiphase, and then you have to choose the appropriate model for multiphase flow problems. If suppose in this case we have a combustion phenomena. So energy dialog box will be open, and we will enable the energy equation, because energy will be included in our simulation, right, whenever we are solving the combustion related problems. Then next you have a viscous model. So when you enable your viscous model dialog box, and suppose your flow is a laminar flow, then only continuity and Navier-Stokes equations will be solved, or it will be activated. So viscous laminar model is applied whenever you have a simple and whenever you have a simple case. But whenever you have a turbulent flow, for example, in combustion chamber, we have a highly reactive turbulent flow. So you have to activate the turbulent models. There are different turbulent models available in the fluid. You can see here, whenever you will click on the viscous turbulence models, you will see there are different models available. Different models have different modeling strategies, right? Which turbulent model is suitable for your case? That again requires a literature survey. You have to do the literature survey, and you have to decide that which turbulence model is more appropriate for your particular case, right? Then see, it is a combustion problem. So in combustion, we know that there will be chemical reactions. So there will be the interaction between turbulence and chemistry. So we have to model the turbulence chemistry interaction. Basically, in this combustion chamber, we have a non-premix combustion. So here we have used a chemical equilibrium model. We have used a probability density function method to account for the turbulence chemistry interaction. This model is chemical equilibrium model is very suitable for combustion related problems, right? And the main important feature is that it does not require any detailed chemical kinetic rate data, right? It also calculates the formation of intermediate species. So it is more appropriate than any other models available in the fluent. So next option that is given here is you have to choose the materials from the fluent database, right? So you can edit the material properties and you can select the material which is appropriate in your case, right? In present case, we have a gaseous mixture of methane and air, right? It's a gaseous combustion. The fuel that we have is methane. So it's a gaseous mixture of methane and air which is reacting. So we have selected this PDF mixture. Then under the solid tab, right? By default, you will see that aluminum is selected, but you can select other material, right? For example, the combustion chamber is fabricated with SS304. So we will select the appropriate material from the fluent database. Then next one is cell zone condition. Now what is the meaning of this? See, you will select the material from the material zone which is given here, right? For example, we have different components or different zones, like we have nozzle, we have fuel injector, we have a dome, we have cylindrical barrel, swirler. So these are the different zones. So we have to select the type of the material. For example, in nozzle we have a fluid, right? So we will select fluid. So appropriate material you have to select from this particular tab. Then important thing, the next important point is the boundary conditions, right? See, you have already assigned your boundary types for each type of the zone in your modeling stage, in your pre-processing stage. Now here you have to give the input for each boundary. Supposedly I select air inlet of the combustion chamber. So here I am defining which variable. I am defining mass flow at the air inlet. You can define velocity inlet also, or maybe any other parameter. So you have to use the type and edit option to assign the boundary conditions. For example, in this case, all the inlet surfaces are defined as mass flow inlet, and the outlet of the combustion chamber is defined as pressure outlet. So if you are defining mass flow inlet, then you will give the specific value of the mass flow rate at the inlet surfaces. Then the next step is, or the next option is mesh interfaces. Now, what is mesh interface? This option is not useful in every case. This option is useful when you have two phases overlapped or connected, right? So if you create the mesh interface, that will make it permeable for the flow. It will allow the fluid to flow from that particular space. If you will not create the interface in this condition, then what will happen? The fluent will consider it as a wall, so fluid will not flow beyond that. So that is the option that we have available in Fluent, but this option is not suitable for all the cases. It is useful for the case when you have two phases, either they are overlapped or connected with each other. Then reference values. See, this reference values are not so important, right? In all the cases, they are important in some cases, like when you want to calculate the drag coefficient or skin friction coefficient, right? But ultimately, the general solution of your problem will not be affected by these reference values. It is not so much important. Now, the most important is the solution methods that we have. You will select the solution methods that you want to use, right? There are many solution methods available. Each solution method has its own advantage and limitations. Fine. You can choose any discretization method from here. Fine. For different variables like pressure, momentum. If energy is activated, then energy, and since it is a combustion problem, so mixture fraction will also come into the picture. Generally, the first order or second order affluent schemes are used for discretization, but second order is considered to be more accurate, but it is also more complicated. First order scheme is considered as simple, and it helps you to converge faster than the second order scheme. But obviously, second order scheme gives you more accurate results. Then you have this pressure velocity coupling method, right? We have different algorithms like simple, simplex, like that. So simple is semi-implicit method for pressure linked equations, right? Simple algorithm is very popularly used in CFD in order to solve your Navier-Stokes equations. It basically uses the relationship between your pressure and velocity corrections to enforce the mass conservation and to obtain the pressure field. Next, you have solution controls. Now, here, this tab will ask you to set the common solution parameters, which we call it as under relaxation factors. This URF ensures that solution from one step to the next step does not change too much. Otherwise, it may become unstable. So in some complex problems, like for example, whenever you are solving the combustion problems, or whenever you have a combustion simulations, you have to change this under relaxation factors, right? So in combustion simulations, normally it is preferred that you reduce the under relaxation factors to 1/3 of their default value. But again, it varies case to case. For different cases, this opinion will be different. Fine. Then you can set the solution monitors. You can monitor your simulation here, right? You can set the residuals. You can even add additional monitors also for additional properties, like if you want to plot the drag coefficient or lift coefficient or momentum coefficient, if you are solving any flow over an aerofoil, if you are solving that kind of problem. You can set the convergence criteria. For example, in this case, we have set the convergence criteria to 10 to the power -4 for all the governing equation, except for energy and radiation, we have set it to 10 to the power -6. So you can set your convergence criteria. before you begin with your simulation. You have that control, you have that option. Then the final step is the solution initialization. Now you will initialize your solution, right? Before you run your simulation, you have to initialize the solution. Here you can see there are two methods available. One is called as a hybrid initialization, another one is standard initialization. What standard initialization essentially means is that all the cells will have same value at initial. That is what the standard initialization. And hybrid initialization makes non-uniform initial guess, which is sometimes helpful, especially for complex geometries. Hybrids initialization sometimes results convergence in less iterations. So there are certain advantages and limitations, right? For specific problem, you can use specific methods. Then, since our problem is transient problem, see, combustion is an unsteady phenomena. It's a three-dimensional unsteady reactive turbulent phenomena, right? So we have performed the transient simulation. So when you go into the calculation activities, right, here you can save your data file and case file at every time step. Even you can create the solution animations for various parameters in Fluent, right? You can use the solution animation dialog box to create the animation sequence. Fine. Here you can start your simulation by giving the number of iterations. If you have a steady state problem, you can directly give the number of iterations. If you have a transient problem, then you have to set the values of the time step size, number of time steps, reporting intervals, maximum iterations per time step, right? So these are the features available, these are the options available. Depending upon the type of problem that you are solving, these features will appear in this table. And then you start your calculations. Fine. Once you done with your calculations, now the next step is post-processing, where we will examine and analyze the results using CFD post-processing tool. You can either use CFD post, or you can use Fluent also, or any other solver available for post-processing. You can display your results in terms of contours, in terms of vector plots, in terms of path lines, right, of any variable as per the physics of your problem. You can even display your results in terms of XY plot format, right? You can have a variation of pressure or velocity or temperature along the axial distance or along the radial distance. You can create XY plots. Then you can load your external data file into the Fluent, and you can compare your results with the other sources, right? Then you can generate the reports also. That will allow you to set up the report for your this particular option will allow you to set up the reports for your CFD simulation. Reports can be compiled for fluxes, can be for forces or projected areas, surface and volume integrals, and there are many other options. You can even plot histograms for sample files created in the sample trajectory dialog box. Here you can see some of the results from my simulation. You can see the results are plotted in terms of streamline pattern. You can create the streamline plots. You can see this is the streamline plots on longitudinal plane of the combustor, which describes the flow pattern. So you can visualize the flow pattern, right, for different variables or different situations. Even you can create this type of means you can identify some locations in your flow domain, and you can visualize the flow patterns. You can, with the help of velocity vectors at different locations, right? Even you can create this type of XY plots also. Here this XY plots I have created at different axial planes. Radial variation of velocity, different components of velocity. You can see this is a radial distance These are the different components of velocity, like axial, radial, tangential components. This, you can have this kind of variations. You can compare your results in terms of velocity profiles or temperature profiles or any variable, for any variable at any different means at any locations in your domain. So you can generate this type of results in order to understand the flow physics, in order to get insight into the flow problem. Now you see, this is a comparison of the CFD results with the experiments, and you can imagine that how your CFD results are helps you to understand the real physics of your problem. Here you can see I have demonstrated the results in terms of temperature contours on my vertical plane, and I have also got the experimental results in terms of flame visualization through a transparent geometry of the combustion chamber, right? So this is just for the purpose of validating or verifying your results, whether the predictions that you obtain from the CFD simulations, whether they are matching with your experimental results or not, right? And you can understand that how the CFD can be helpful to you in optimizing optimizing your geometry, your system, right? And that can save your experimental expenses, right? You can see the temperature distribution at the outlet of the combustion chamber that we obtained from the CFD simulations. This temperature distribution shows that at the center of the combustion chamber outlet, you have a maximum temperature. As you go away from the center, near the wall, the temperature reduces gradually. Now, the same physics we also observed from the experiments. We can see the flame visualization at the outlet of the combustion chamber, and you can clearly see that the thermocouple, which is placed at the center, the outlet, it is experiencing maximum temperature, and the temperature at other thermocouples are relatively low. So what CFD is predicting, right? We see in reality through the experiments. Fine. So this is what the importance of CFD is. This is what the significance of CFD is. I'll just take 1 minute because of time. I know that. So this is just the last slide that I have to show you, right? So you can see what are the opportunities that CFD offers you in different areas, right? We have a lot of opportunities if you talk about industrial scenario. In industry, you have a lot of opportunities in CFD application, right? Rather than in case of code development, because if you are going for the research side, right, then development of various CFD codes, right, that will be helpful to you. But if you are talking about the application of CFD softwares, right, for solving the industrial problems, right, then in industry the opportunities in CFD application are relatively more than those in development, testing, and documentation, right? There are different areas, right? Depending upon your interest, depending upon the skill that you have, you can explore yourself either in code development, either you can involve in the application of CFD software for solving the industrial problems, either you can do the testing and validation of the CFD codes, or you can involve yourself in writing the technical documents, like for example the user guides that are available for the commercial CFD codes, right? So I think this is all I wanted to convey. Thank you so much. If you have any questions, then you can ask your questions.
Thank you so much, sir. Actually, we are very much short of time, so we will just request you that you give. We are having your email address. The participants will post the questions if they have. And because the session was very informative, I was not willing you to stop, but because of time constraint, it is very necessary that we have to cut short the session here only.
Sure. problem.
Even in the chat box, we are able to see that many of the participants have enjoyed. They have described your lecture. It was very good. So it was really very informative, and it was like we didn't want to go away from there. But thank you so much, sir. On behalf of FDP team and the Government Engineering College, Bharuch, I am very much thankful to you. Thank you so much, sir.
Thank you very much to the entire team, and thanks for giving this opportunity. Thank you very much. Thank you.
Yeah, thank you so much.
Thank you. Thank you.
A very good afternoon to all the participants. Sorry, we could not have a good break today because already we have in our room the next speaker with us. So please bear with us, and we will start the session. The next section for the next session, we are having Mr. Paresh Bhatt. He is the direct from the Advice and Assist. Mr. Paresh is a science graduate. He is a trainer by passion and has an innate ability to take the participants on knowledge tour with fun and learning experience. He has too much of experience in various stages. For example, he is taking the corporate training. He is taking college training also, in which he takes campus to corporate for students of engineering, management, and pharmacy, and he is also involved in social development. He has number of very valuable clients. So today I'll invite Mr. Paresh Bhatt to please deliver his session. Welcome, sir. Sir, your mic, your voice is not audible.
Dhanyawad Deepa ji. Thank you. Thank you very much.
Thank you,
And
sir.
good evening to all my gurus, teachers. And I'm very happy to be with you. I request in starting for the first 5 minutes, if it is possible, you please switch on the cameras. And when I will start my PowerPoint presentation, we will close the camera. So if it is possible, I request that you please switch on the camera. Thank you very much. First cam has been already started. So nice of you. Thank you very much. And I am very happy to be with you. मैं मेरे देश के सभी गुरुजनों को प्रणाम करते हुए आज की मेरी ये बात आपके सामने रखने के लिए जा रहा हूं। मैं आपके साथ रिक्वेस्ट करूंगा कि यदि हो सकता है तो आप ईयर प्लग लगा के बैठेंगे तो आपका सराउंडिंग नॉइस आपको डिस्टर्ब नहीं करेगा, and you will be in position to listen my voice modulation, voice clarity as well as voice frequency. Thing is that since last 3 days I am with you, as and when I am getting the chance to listen, to understand what is the this workshop is about. I used to get entry and I just try to understand what is the exact meaning of this, or what is the purpose of this सेमिनार। मुझे लगता है जब तक मेरी समझ में अभी तक शायद मैक्सिमम टेक्निकल बातें हुई है, लेकिन अब आने वाले 2 घंटा हम टेक्निकल नॉलेज से कुछ बाहर हटके हमारे अंदर रहा जो गुरु है इसके साथ हम बात करने की कोशिश करेंगे। I am going to establish a bridge between my words and your ears. और वहां ब्रिज जो बनेगा वो गुरु तत्व बीच में रहेगा। तो इज इट ओके? क्या मैं आपका थंब इंप्रेशन ऐसे देख सकता हूं? शैल वी स्टार्ट? इज इट ओके? यस, आई एम गेटिंग 1 or 2. वेरी गुड, थैंक यू वेरी मच। सो फ्रेंड्स, समय की मर्यादा है, 2020 खेलना है, और मुझे लगता है कि हमारे देश की राष्ट्रभाषा में यदि मैं बात करूंगा तो बहुत लोगों को ज्यादातर दिक्कत नहीं आएगी, बट आई विल ट्राई टू मिक्स अप द हिंदी एंड इंग्लिश। सो दिस लैंग्वेज विल बी इंग्लिश, दैट इज हिंदी एंड इंग्लिश कॉम्बिनेशन, बिकॉज मेरा इंग्लिश इतना अच्छा है जितना सोनिया गांधी का हिंदी, और इसीलिए मुझे शायद इंग्लिश बोलने में तकिया कलाम आ भी सकता है। देखो, आपके ऊपर चेहरे पे स्माइल आया हो, मेरी सबसे आज के दिन की पहली कमाई है। मैं देख रहा हूं लोगों के चेहरे पे स्माइल आ रहा है। तो कुछ हटके करना है, कुछ अलग सी बात करनी है, और यदि बीच में आपको ऐसा लगा आपको भी मेरे साथ ज्वाइंट होके कुछ कॉन्वर्सेशन करना है, आपका स्वागत है। So let us get into the training session. गुरुजनों, आचार्य चाणक्य ने बताया है, क्या बताया है? शिक्षक कभी सामान्य नहीं होता। शिक्षक कभी सामान्य नहीं होता। जब मैं यहाँ शिक्षक शब्द बोलता हूं या फिर टीचर शब्द बोलता हूं तो सभी लोग आ जाता है, जो प्रोफेसर है, जो शिक्षक है, केजी नर्सरी में पढ़ाते हैं वहां से लेके पीएचडी के गाइड तक, क्योंकि शिक्षक तत्व तो वही रहता है। हाँ, अपने स्टूडेंट बदलते हैं, हमारा काम करने का तरीका बदलता है, लेकिन वो जो स्टूडेंट और टीचर के बीच का जो रिलेशन होता है, गुरु और शिष्य के बीच में जो रिलेशन रहता है, वो रिलेशन तो वही रहता है, इसमें कोई फर्क नहीं होता है। तो यहाँ पे आचार्य चाणक्य ने बताया है कि शिक्षक कभी सामान्य नहीं होता। बस इस थीम के ऊपर आज इस बात को चलते हुए मैं आपके साथ कुछ बातें करूंगा। मैं मेरा पावर पॉइंट प्रेजेंटेशन अभी शेयर कर रहा हूं। यदि आपकी पॉसिबिलिटी है, शक्यता है, तो आप कैमरा चालू रखना, वरना यू कैन स्विच ऑफ योर कैमरा। आई एम गोइंग टू शेयर माय पावर पॉइंट प्रेजेंटेशन। Is it visible? मेरा पावर पॉइंट प्रेजेंटेशन आपको दिखाई दे रहा है? Can anybody tell me, because now I cannot see.
Yes sir,
Yes, it is.
Thank you very much. अभी मेरे सामने सिर्फ मेरा कंप्यूटर है, आप कोई दिखाई नहीं दे रहे हैं, लेकिन मेरी खुद की जो अंदर की आंखें है, इससे मैं विजुलाइज कर लेता हूँ कि मेरे साथ बहुत से गुरु ज्वाइन हुए हैं और मैं बोलने की कोशिश कर रहा था। मेरा नाम परेश है, जैसे मैडम ने बताया, मेरी कंपनी का नाम द एडवाइस एंड असिस्ट है। I started my journey on 26 January 1994. So almost all put together, it is 27 years in my this training field. 27 साल की मेरी यात्रा है, और ये स्टेज की गरिमा को रखते हुए ये 27 साल में मैंने बहुत सी कंपनीज, यूनिवर्सिटी, शैक्षणिक संस्थान के साथ काम करने का मुझे सौभाग्य प्राप्त हुआ है। I am also working with the Gujarat government, and I am also working with lots of private PSUs and private companies.
Paresh bhai.
जी sir.
Sir, it is requested that kindly deliver in English. Some of the participants are not able to understand in Hindi.
हाँ सर, आपकी बात सही है, लेकिन 2 बात मैं यहाँ पे बोलने की कोशिश करूंगा कि सबसे पहली बात कि मैं जो भी बोलूंगा वो मिक्स में हिंदी और इंग्लिश, जो भी हिंदी बोलूंगा उसका इंग्लिश ट्रांसलेशन करता रहूंगा, नंबर 1। और दूसरी बात, मैं ये भी अपेक्षा करता हूं कि यदि मेरे देश की राष्ट्रभाषा को समझने के लिए उसकी थोड़ी सी तैयारी होगी तो वो लोग मुझे समझ पाएंगे, अच्छी तरीके से समझ पाएंगे। but definitely I will try to communicate in English.
Okay.
But there is some fragrance. Yesterday I had a word with Mr. Modi that if there is something which I want to communicate in proper language, उसके लिए शायद मुझे हिंदी words use करना पड़ेगा. So I will try definitely, and I'm sure कि मैं आपकी अपेक्षा के ऊपर जो आपकी अपेक्षा है इसको मैं फुलफिल कर पाऊंगा. धन्यवाद सर. Friends, I'm very thankful to organizing committee of FEM GEC Bharuch, at the same time Director of Technical Education, Gujarat Government, Gandhinagar, and AICTE Training and Learning Academy. I'm very thankful because of them I'm here. Today I'm going to discuss how to be an effective teacher. जैसे राष्ट्रपिता महात्मा गांधी has given the 11 vows, 11 महाव्रतों. These 11 vows are going to be make us an effective teacher. एक असरकारक effective teacher बनने के लिए we'll have to understand which are the 11 vows to be an effective teacher. But before I enter in the 11 vows of the teacher, let me elaborate which are the with me. This with me word has been come from the IIM Ahmedabad. With me stands for what in it for me. What in it for me matlab what is my benefit. Anybody who is trying to obey these 11 vows to be an effective teacher, what the benefits that gentleman or guru is getting. And that guru is getting first and most, that is they makes the most positive impact on the human life. Friends, I personally believe that any teacher who is making the impact on the life is the worth to live the life as a teacher. Make positive impact. Number two, they ignite the spark. There is lots of potentialities there in today's youth, but because of lack of direction and lack of proper guidance, today's youth are not, we can say definitely, they are misguided missiles. Today's youth is a misguided missile. They have the lots of potentiality, but we have to give the spark and we have to ignite that they can go in the right direction. Number 3, जैसे कि like there is 11 vows, here is 11 benefits to be an effective teacher. ये 11 महाव्रतों के साथ आपको 11 बेनिफिट भी यहाँ पर मैंने दिखाया है. सबसे पहला बेनिफिट, you can make the positive impact on the life. Second, you can ignite the spark. Third one, you will be surrounded with the love and respect. This is the only profession where we get the lifetime love and lifetime respect. If a person has really worked as an effective teacher throughout the life, he will get unconditional love from the students, unconditional respect from the student, and that is also for the lifelong. You can have the life all the day long, which is very important because you know very well that nowadays it is very rare to live by heart in a day. We can create a teacher can create his own work environment and inspires others. Friends, it is very easy to motivate something because motivation is the word which is related with the words. शब्दों के साथ खिलवाड़ करके you can motivate other, but if you want to inspire other, you have to live the life in that way. Then and then others will be inspired with your work, with your way of working, with your way of presentation. Inspiration and motivation both are the different things. And here I have mentioned you can inspire others. It will feed your inner creativity. Yes, I personally believe everybody has some creativity already installed by the Almighty. We can feed it. At the same time, every day is an exciting day. Every day there is something new. because we are living in between the student, we are living in between the young generation. They have all the new ideas, all the new energies. It will long lasting memories. Friends, I personally believe, I know lots of retired teachers and professors. Those students, those teachers and professors have worked very nicely, very genuinely in their lives. They have the long lasting memory. अरे परेश भाई क्या बताओ, उस जमाने में उस दिनों में हमने ये किया था. My students are there in US. My students is working with this company. My student is calling me in these days. और गुरु पूर्णिमा के दिन, on the day of Guru Purnima, they are on the top of the world. They have the lots of good memories in the life. This can only with the gurus. Friends, I am also a son of a teacher. My father was a teacher. I have seen lots of happy retirement senior citizen who have worked as a teacher, very genuine. And I personally believe that there is a third law of motion. Newton ka gati ka tisra niyam. Whatever you will throw through the society, through the universe, you will get back. If we have thrown good work, definitely you are going to get retirement life. A teacher's life is very, very important life. And last one is very, very important. इस शब्द के ऊपर last में जो the word with the benefit which I have mentioned on 11th number, we can enjoy the second line of parenting. Teacher, professor is a second line of parenting. They can do the parenting. Friends, these are the 11 benefits. If we apply this, 11 vows to be an effective teacher in this world. Friends, why? Why this 11 vows, or why this regulation, self-regulation is required in our life as a teacher? Friends, you know, COVID-19 has made irreversible, not reversible, this is my mistake, it is irreversible changes in the behavior of all the industries. अपने मूलभूत स्वरूप में नहीं आने वाले परिवर्तन आ चुके हैं. And education in the industry is also one of them. Before COVID-19, mobile was prohibited in the college. I have seen lots of colleges and lots of universities where there is a board that mobile is prohibited, and if you will be caught with the mobile, you will have to fine 500 rupees, 1000 rupees, depends on the campus of the college, university. Now the entire college is there in the mobile application or in the mobile. Previously, teacher were used to speak in front of the crowd. पहले teacher एक समूह के सामने अपने वक्तव्य रजू करते थे. Now they have to work in front of the camera. Previously अपने आंख का कैमरा 180 डिग्री पे चलता था. अभी स्टैटिक कैमरा के सामने बोलने के समय आ गया. It has changed. Previously there were only students were your audience. When we were delivering the lecture in the classroom, students were listening us. Now it has threefold. Now it is threefold. Now students plus parents plus competitors. At the same time, our communication is playing a very vital role because now the recording is there. So we have to be very effective in our classroom teaching. Friends, and for that matter, let us get entry in our today's thought. आज के विचार में मैं आपको प्रवेश करवा रहा हूं. There are lots of pairs in the world which are very famous. In context to India, we will discuss few relevant examples. Lots of famous personality. If we will talk about the one person, we will definitely by default we will get the remembrance of the second one. Like Sachin, तो दूसरा नाम जिगर आ जाता है. कल्याण जी तो आनंद जी आ जाता है. लक्ष्मीकांत तो प्यारेलाल आ जाता है. बेदी और प्रसन्ना तो बेदी जी, इफ यू रिमेम्बर रिकॉल बेदी तो हम प्रसन्ना जी को याद कर पाते हैं. At the same time, it is also there in the nature. It is also there in the nature. यदि रात आती है तो दिन आता है. If we talk about the night, there is day. If we talk about the light, there is darkness. So nature is, there is also yugma. It is called, in Sanskrit it is called yugma. It is always in pair, and they are opposite in the nature. At the same time, place. That's a lots of place. Kulu and Manali, Div and Daman, lots of places are there, which has been used one name, and we can get the recall of the second one. Something in the object also, like cup and saucer. So sui or daga, ये कुछ ऐसी है पैर से, which are made for each other. At the same time, some relations are also there. They are made for each other. And it is one of them is Guru Shishya relationship. Guru Shishya relationship is very much pure. At the same time, it is selfless. You can see on our screen, there is a Guru Ramdas. If Guru Ramdas would have been not taught Shivaji, शायद हमारे पास आज कुछ इतिहास अलग होता. Second was that is Ramakant Achrekar and God of the cricket Sachin Tendulkar. We have also PV Sidhu. Right now she is really doing well at Olympic, and Pulila Gopichand and Allah Rakha as well as Ustad Zakir Hussain. These are the few pairs where there is Guru and Shishya Parampara. And in Indian mythology, in Indian culture, this relationship has a vital role to play for the holistic development of any youth. किसी इंसान का सर्वांगी विकास के लिए गुरु और शिष्य का संबंध होना बहुत आवश्यक है. And as per me, the most beautiful relation or most pair in this world is the Param Guru Ramakrishna Paramdev and very world famous, very well known Indian saint Swami Vivekananda. Friends, Guru ने ऐसा क्या दिया है? What Guru has given to their Shishya? So even today, we consider that this is the best relationship in the world. And for that matter, friends, the teacher cannot be ordinary. चाणक्य कहते हैं शिक्षक कभी सामान्य नहीं हो सकता, लेकिन I Paresh Bhatt personally believe something differently. An ordinary cannot be teacher. चाणक्य कहते हैं कि शिक्षक कभी सामान्य नहीं हो सकता, लेकिन मैं कहता हूं सामान्य कभी डॉक्टर हो सकता है, सामान्य चार्टर्ड अकाउंटेंट हो सकता है, सामान्य IAS IPS हो सकता है, सामान्य कभी शिक्षक नहीं हो सकता. जिसकी यहाँ पे कुछ केमिकल लोचा है, जिसके अंदर कुछ अलग सी आग है, he can be only teacher. He can be only teacher. And for that matter, student relation teacher relation is the best in the world. Friends, student and teacher relation is one of the best relation in this world. There are few reasons. Number one, teachers are the psychological parents. I personally believe, आज भी, even today, when you are teaching something, there is some reflection of your Guru. When you are on the stage, when you are delivering a lecture, when you are correlating something with the real world and theoretical world, there is some fragrance of your Guru, through whom you have learned something. वो कॉलेज के हो सकते हैं, he can be from the college, he can be from your PhD guide, or he can be from your primary education. But teachers are the psychological parents. Second, student is learning from our walk and talk. It is not like that कि teacher वही बताएंगे और बच्चे वही सीखेंगे जो teacher बताते हैं. ऐसा नहीं है. Students are learning from the walk and talk. The way we are entering in the class, the way we are delivering, the way we are elaborating or we are giving the relevant examples. Student is learning from our body language. You know that 7% effect is from the words, 38% is from the our voice communication, and 55% effect of our communication is from our non-verbal communication, and that is body language. So student is always learning from our talk and walk. And finally, very important, they are the customer of our education industry. We are getting the money from their pocket, or we are here because of them. They are our customer. So friends, this relationship is very important. Coming to little further, one step ahead. Teacher is bridging the gap between 36 to 100. Teacher is bridging the gap. Any student who is passing with the 99 percentage, इसका मतलब हम ये भी कर सकते हैं ना कि उसके पास 99% ज्ञान है लेकिन 1% अज्ञान है. He is having the 99% knowledge, लेकिन उसके पास 1% का अज्ञान है. The industry is expecting 100% from the any candidate, any corporate professionals. If any student who is passing out from the 99%, 9.9 CGPA, and is going to any Mercedes company, any company like Mercedes, and if we say I have passed out with the 99%, I can make 100 cars. Out of 100, 99 will be okay. When maybe some problem. Will this company, corporate company, will select him? No. The society, the company, the corporate world is expecting 100%. And no student is going to get the 100% except any exception. So teacher is bridging the gap between 36. 36 is a passing marks. And teacher is bridging the gap between 36 to 100 with the maturity, with the non-verbal communication, by creating or advising them minor fine-tuning in their vocabulary, in their maturity, in their behavior, in their understanding. And believe me, friends, I personally believe with the experience of 27 years, we are paid for our maturity. We are hired for our maturity. We are not hired for our any good, highly intelligent fluency and all. Maturity is equal to success. Gyan, pratibha, these all are the secondary matter. First and foremost, that is the maturity. And now let us go with the one more slide. Why teacher is teaching? टीचर टीचिंग क्यों करते हैं? अभी आपके चेहरे पे थोड़ा सा स्माइल आना चाहिए. Why teacher is teaching? There are 5 reasons. या फिर 5 प्रकार के टीचर्स होते हैं. There are 5 kind of teachers. और वो 5 प्रकार के जो टीचर होते हैं, इसमें से किसी न किसी जगह पे हर एक प्रोफेसर, हर एक टीचर वहां पे आता है. First, that is to prove the existence or to prove the salary. मैं प्रोफेसर हूं, मैं टीचर हूं. I am a teacher, and if I want to be a teacher, if I want to be a professor, I have to teach because I want money. I have to justify my salary. That's to prove my existence. I am here. और ऐसे लोग होते हैं, मैंने बहुत से ऐसे लोग मेरी जीवन में उससे मुलाकात होने का मुझे दुर्लभ मिला है. They are there because they want to earn something. They want to get something. दूसरे जो टीचर होते हैं, impressed student, ये बहुत खतरनाक होते हैं. ये छा जाने के लिए, they want to just impress the student. Yes, he's a good. उसके नाम बड़े और दर्शन छोटे वाली बात यहाँ पे आपको दिखाई होती है. उसका ड्रेसिंग और एड्रेसिंग बहुत बढ़िया होता है. इस प्रकार के जो टीचर है ना, दे आर वेरी गुड एट द ड्रेसिंग एंड दे आर वेरी गुड एट एड्रेसिंग. छा जाते हैं जस्ट टू इम्प्रेस द स्टूडेंट और द क्राउड. थर्ड वन, मुझे जो बताया गया, वॉट एवर आई एम सपोज टू टीच, आई विल टीच. वेदर माई स्टूडेंट इज लर्निंग और नॉट, दैट इज नॉट none of my work. I have to do, I have to justify मेरा जो फर्ज था मैंने पूरा किया. I have to educate, I have to teach my students, not educate, I have to teach what I am supposed to, I'll do it. This kind of professor are always regular. This kind of professor are teaching all the words of the textbook, which is supposed to be. But they never add anything from their own pocket of the knowledge. उसके ज्ञान का जो एक पॉकेट है, इसमें से कुछ भी ऐड है. They don't give the relevant examples. They don't give the real life experience. Student is teaching from the examples. Student is learning from the real life experience. They are expecting. I would like to advise, if it is possible, please read the new book of the Sapiens novel. Yuval Noah Harari की एक book है. Sapiens is it's Hindi and Gujarati and English. All the three version is available. Definitely, we can say we have always a capability, or we have this tendency. We learn from the stories. We learn from the stories. And this is the difference between human being and other animal. Human can create the story, while other rest of the human cannot create the story. They have just signals, they have communication, but we are learning from the story. This kind of teacher never teaches through the story or relevant example or real life experience. Fourth one is to ignite the student to think and self-learning. जहां से टीचर अपना एजुकेशन, अपना टीचिंग खत्म करता है, वहां से स्टूडेंट का थॉट प्रोसेस चालू होता है. They are provoking the student to think about from where he has left rest of the part. And finally, it is going to be the self-learning. It is resulting in the self-learning. And fifth one is to make the student a good human being. पांचवा प्रकार है, they are creating a good human being, they are creating a good citizen of our nation. These are the 5 kind of teachers which, according to me, they are, and all the students, all the gurus, all the professors, they are falling in one or other in this, out of this 5. To make student a good human being. And friends, new education policy is always emphasizing on the same, that holistic development is a central, it's a madhyavarti vichar, the central idea of nowadays. The education is going to be there. There will be lots of changes, and these all will be a part of creative thinking, meditation, psychological strength. These all are going to be the part of our curriculum in time to come. So friends, there is one serious humor. There is one serious humor. This is on lighter side, but it is on, though it is on lighter side, it is not like that. इससे कुछ हमको अर्थ नहीं मिलेगा. It is on lighter side, लेकिन बहुत गंभीर बाबत है. हर एक इंसान होता है, 4 प्रकार के इंसान होते हैं. There are 4 kind of human beings. There are 4 kind of teacher. There are 4 kind of trainer. There are 4 kind of businessmen. If we were to bifurcate any human being in the 4, we can compare with the fan. कुछ लोग सीलिंग फैन जैसे होते हैं. They are something like ceiling fan. और वो सीलिंग फैन दुनिया से ऊपर उठे होते हैं. They are not bothered about the respect and rest of the thing. They are just doing their own work. They are just flowing the air, and लोगों के लिए एक शीतलता मिलती रहती है. लोगों को एक शीतलता मिलती रहती है. दूसरा एक होता है, और वो होता है टेबल फैन. जैसे मैंने कहा ना, ड्रेसिंग और एड्रेसिंग. They are big name. They are noising a lot. They are moving very fast. उसकी हाइट भी सोसाइटी में, समाज में, they are heighted people. लेकिन बेनिफिट उसको मिलता है जो उसके नजदीक में रहता है. रेस्ट ऑफ ओनली नॉइज. तीसरे एक लोग होते हैं जो टेबल फैन की तरह होते हैं, दे आर लाइक ए टेबल फैन। कभी वो वैल्यूज की बातें करेंगे, कभी वो एसोसिएशन की बातें करेंगे, कभी कुछ और बातें करेंगे। दे आर नॉट फिक्स्ड इन देयर ओन थॉट प्रोसेस, दे आर बीइंग ऑपरेटेड बाय समबडी एल्स। और कोई कोई होते हैं वो एग्जॉस्ट फैन की तरह होते हैं, वो उल्टे चलते हैं और बात निकालते रहते हैं। So this is on lighter side, but this is a very serious humor. Friends, this time of the teaching profession, I would like to congratulate all of you, including myself. This is the best time, this is the golden era of teaching profession. And we should feel very proud that we are in the same position, which is the best, because if we talk about the 19th century, 19th century was the century of the landlord. 19th century was the century of the landlord. If we talk about previous, यदि हम भूतकाल में जाएंगे, if it read the olden books, पुरानी बुक का हम पढ़ेंगे, किसको हम बड़ा इंसान कहते थे? जिसके पास ज्यादा जमीन था. So 19th century was the century of the landlord. 20th century was the century of the power of post. यानी कि 19वीं सदी जमींदार लोगों की सदी थी, 20वीं सदी अमलदार लोगों की सदी थी और 21वीं सदी समझदार लोगों की सदी है. 21st century is the century of the knowledgeable people. 21st century is the century of the knowledgeable people, and we are in the same profession. When Barack Obama, ex-president of America, came to India, he had used a word, or a sentence, that knowledge is the currency of the 21st century. So friends, we are dealing in the 21st century, matlab knowledge based industry, and we are the drivers of this industry. And for that matter, I would like to say almost we are teaching to those students who was born in the 21st century. We are teaching to those students who was born in the 21st century. And 21st century में जिसका जन्म हुआ है, they are gifted by the society. 5 gifts they have got by born. By born, they are gifted by our society. And first, that is the smartphone. See, हम 21वीं 20वीं सदी में पैदा हुआ और टीचर बना, प्रोफेसर बना हुआ एक इंसान 21वीं सदी में पैदा हुआ और पला हुआ एक युवान को पढ़ाने की कोशिश कर रहा है. And for that matter, we will have to understand which are the 5 gifts our student has got from the society. It was not there in our childhood or our youth time. हम जब युवान थे तब हमारे 5 में से एक भी चीज हमारे पास शायद नहीं थी. That is, first is a smartphone. Second is the high speed internet. 21st century youth has been blessed, has been gifted by the society. First is a smartphone. Second is a high speed internet. Third is a high configured computers. Fourth is a digital games. And fifth is a social media. Believe me, friend, आप मुझे बताइए सर, when you were aging 21 year, क्या आपके पास ये था? आपके पास ये था? नहीं था. जब हम थे, we were not gifted by the society, and this 21st century student or born child is gifted, and we have to make them understood what is the values. When everything is available on the Google Tips, I think that if और मैं आपको होमवर्क इसके ऊपर मैं नहीं बोलूंगा क्योंकि विषय से शायद मैं कुछ अलग चला जाऊंगा, लेकिन you would have been come to know that there is a school in Bangalore where this Robert is teaching, where Robert is working as a teacher in a school in Bangalore. Just think, this is a thought process, or this is a homework from my side to all the gurus, that if we replace all the teachers by robot, what will be the benefit? Benefit की बात है. What will be the benefit for the students as well as school या college या organization या फिर university, whatever it is. इसके बारे में सोचना. What will be the benefits? There will be n number of losses and uncompensable losses will be there. But what will be the benefit of this for the student, and what will be the benefit? We are dealing with the 21st century, and 21st century is the century of the knowledge, and for that matter, friends, we have to update ourselves. Now, this is the last slide before I enter in the 11 vows. There was one very good music album of Michael Jackson, The Man in the Mirror. The person who is there in the mirror is capital I, first person singular. And we have to ask few questions to ourselves. Answer will come from the within itself. I am a teacher by chance or by choice. I am a teacher by choice or by chance. Number two, what is the purpose of my job? Just to get the money on 31st or last day of the month in my bank account? And the voice of this message, that message is very, very melodious. The voice, because there is some money has been credited in our account, bank account. Is it the only purpose of my life? It is the only purpose of my job, or it is something else? Do I feel that my student loves me, respect me? The inner soul bata deta hai. Our inner soul will definitely give the answer whether I'm loved or I'm getting the respect from my student or not. नजर ने नजर से मुलाकात कर ली, रहे दोनों खामोश और बात कर ली. Definitely there is non-verbal communication is there in the eyes, and we are getting the answer of this third number question, whether I'm getting the respect and love from my student or not. Do I think that I'm a role model or hero of my student? All of you would have been work with n numbers of students in your career. In how many students you are there, you are present? How many students feels that this is the fragrance of my guru? According to me, who is the best teacher of the world? मेरे हिसाब से इस दुनिया का सर्वश्रेष्ठ गुरु कौन है? और आंखें बंद करके ये लास्ट क्वेश्चन को, if you will close your eyes and if you will think about who is the best guru of the world, आपके शायद प्राइमरी टीचर आएंगे. You can close your eyes and definitely you can see, you can try to understand who is the best teacher of the world. आपके प्राइमरी गुरु आएंगे. प्राइमरी एजुकेशन आपने जहां पे लिया है वहां से आएंगे. Friends, I would like to share one of my real life story which has happened last year. I am living in Ahmedabad. My native is a Bhavnagar district, and this Bhavnagar district is located in Gujarat state. I am coming from a very small village. Even after the completion of the 74 years of our independence, ST bus is not there in my village. There is no ST bus stand because it is interior village from the highway. If you walk for almost 2 kilometers from our native place, we can touch the highway and we can catch the bus. I studied in Bhavnagar University. I have completed my Bachelor of Science with principal subject physics. I am a physics student. Presently, I live in Ahmedabad. Almost 3 years back, I was going to my office in Ahmedabad. There is one place called Shivaranjani Crossroad. It is a very famous place. I was going to my office and my son was driving my car. I saw my professor through whom I have, through which I was in 1993, 1993 में मैंने उसके साथ पास रह के BSc कंप्लीट किया था. I stopped my car and bowed down his legs. मैं उसके चरण स्पर्श किए, मैंने नमस्कार किए. When any teacher is passing through this kind of incidents, somebody is going down, तो उसके दिमाग में हो जाता है कि ये मेरा स्टूडेंट होगा, he will be my student. मैंने बोला नमस्कार गुरुजी, मेरा नाम परेश है और 93 के बैच में मैं आपके पास फिजिक्स विषय में स्नातक हुआ हूं. So he asked me, your name, I cannot recollect. It is almost 27, 25 years. After 25 years, उन दिनों में दुबला पतला सा और एक फटी हुई जींस पहन के आने वाला बच्चा अभी शायद इतना मोटा हो गया है, तो definitely it is very natural that teacher is he will not recognize me. मैंने बोला सर मैं परेश हूं, मैं बहुत छोटे देहात से आता था और संगीत का मुझे ये शौक था. ये सब कुछ बात होने के बाद आफ्टर completion of this formal talk, he did not ask me what you do now, what you have earned, what is the size of your company. उसने मुझे जो सवाल किया शायद वो हिंदी में ही बोलना पड़ेगा, माफ करना मुझे, लेकिन उसने जो मुझे जो प्रश्न किया वो प्रश्न सुनने वाला है. उसने मुझे ये प्रश्न किया, ए भाई ये जून महीने की गर्मी है, तेरे माथे पे टोपी क्यों नहीं है? मैंने बोला सर आई एम गोइंग थ्रू माय कार, सो मेरे टोपी नहीं रखी है. उसने ये सवाल पूछा और दूसरी मोमेंट पे उसने अपने सर पे जो टोपी थी वो मेरे सर पे रख दी. उसने अपने सर पे जो टोपी थी वो मेरे सर पे रख दी. मैंने बोला सर ये मेरे पास ऑलरेडी घर पे पड़ी. अरे रखना है तेरे पास रख ले, मेरी ओर से तुझे गिफ्ट. ये मां तत्व है, ये मां तत्व है. और द प्रोफेसर हु हैज जॉइंड फ्रॉम गुजरात, they must be knowing this guru, this gentleman, and his name is Professor Dr. Ashwin Oza. Almost last February, almost 5 months back, he left this world. अश्विन ओझा सर, जब भी बात आती है हमारे जहन में आज भी अश्विन ओझा जिंदा है. क्यों? Because that gentleman has proved himself that some motherness is there. कुछ मातृत्व उसके अंदर पैदा हुआ है और वो मातृत्व की वजह से आज उसके बच्चे पूरे विश्व में जहां पर भी है वो अश्विन ओझा जी को याद कर. There is lots of professor, lots of teachers are there. और आपके अंदर रहा ये जो गुरु तत्व है, इसको मेरा भी प्रणाम है, क्योंकि यहाँ जितने भी बैठे हैं वो सभी में कोई ना कोई अंदर कुछ ऐसा पड़ा है. Something is there जो उसके अंदर ये गुरु तत्व की वजह से वो आज भी दुनिया को कुछ अच्छा बनाने की लगातार कोशिश कर रहे हैं. Let us move forward. So friends, entering in the 11 vows, first, and that is enjoy the teaching. Enjoy the teaching. सबसे पहला महाव्रत, if you want to be an effective teacher, effective professor, at the same time, if you want to gain that 11 benefits, यदि आप second life parenting करना चाहते हो, if you want to enjoy that love and care, if you want to get the respect, first and very important, enjoy the teaching. Every moment, यदि इसको, if you will consider that this is a responsibility, this is a burden, this is a, और कुछ नहीं मिलते हैं तो ये करते हैं. Friends, believe me, definitely you will definitely get some money or whatever it is there in our destiny has given us, we'll earn that. But if you want to enjoy that every moment, we have to enjoy the teaching. Friends, this is the only enjoyable, rewarding career. This is the only where every moment you are in between the youth. This is the only profession where you are getting everyday update. This is the only profession where you are getting the all new ideas, new energy. Only become a teacher if you love your student and teach. If you are coming out of from your lecture room, यदि आप lecture room से बाहर निकलते हो और पीछे पीछे if there is 2 or 3 students is coming back to you, believe me, your lecture was effective. To know how to make your lecture very live. This is a very important. To make every lecture very live. There should not be any. If any teacher or any professor is predictable, believe me, lecture will be vanish. Lecture will not be very live or effective. Teachers is there, they are coming to the classroom, they will remove their spectacles, put on the desk, and they will ask on the front or front row 2 student. We will understand. हमने शायद देखा है ना, वो मुन्ना भाई एमबीबीएस में एक प्यून है, वो भी उसके प्रिंसिपल की स्पीच बोल सकता है, उसको मालूम है अब क्या बोलने वाला है. If you want to make the lecture very live, we have to always we have to create something new ideas and to know how to create the intent. रस निष्पत्ति होना बहुत आवश्यक है दोस्तों. ये रस निष्पत्ति नहीं होती है, ये रस निष्पत्ति नहीं होती है, तब बच्चे के साथ हमारा कनेक्ट टूट जाता है. Only become the student at this teacher at the same time. Never become a teacher if you don't know. Learn with the fun technique. शुरुआत में जैसे ही मैंने बोला कि मेरा अंग्रेजी इतना अच्छा है जितना सोनिया गांधी का हिंदी, there was some smile on your face. There was some smile on the face. Every lecture, every session, every statement has to be there with the very learning attitude with fun. If we don't know how to create the fun techniques, and for that matter, we will have to understand which are the jargons of today's youth. Don't become the teacher if you are not passionate about the teaching. Since it is concerned with the Gujarati professor who can read Gujarati, I would like to suggest one book, and that is Angad No Pag by Harish Tolakia. Anybody who is from Gujarat, I request you, please read this book, Angad No Pag. There is one teacher, there is one professor, retired, and still he is very much passionate about the teaching. And that is superb. It's a super selling book. And don't become the teacher if you cannot enjoy every moment of your life. So friends, first, a simple vow, enjoy the teaching every moment. Number 2, be a change agent. If you want to be an effective teacher, दूसरा महाव्रत, be a change agent. First, there is some saying, with the great power comes with the great responsibility. With great power, it comes with the great responsibility. When you are the boss, you are the king, you are the everything of the stage. When you are delivering a lecture, there is some response. There is great responsibility on our shoulder that we have to carry. Friends, we have to believe, or we have to deal a matured lecture. A matured lecture. Friends, this is something new, and this is the creation from my side. I'm sure this rule of 246 will definitely help you to understand why a teacher has to be a change agent. Rule of 246 says, our student has to learn, or as a professor, we have to teach them out of the 2 pages of the book, 2 cover pages of the books. हमारा जो पुस्तक है, उसका जो 2 पेज है, कवर पेज है, उसकी बाहर की दुनिया पढ़ाने का समय आ गया है. और ये बढ़ाना पड़ेगा. We will have to teach them out of the 2 cover pages of the book. मतलब, as a teacher, as a professor, we can only enjoy if we give them latest knowledge of the industry, of the market, of the society. And if you will give them the latest updated knowledge, you will get the love from your student and you will get the respect from your students. Second is the 4 walls of the room. 4, 2 pages, 2 cover pages of the book. 4, that is the 4 walls of the room. Now we will have to carry out the mindset of our student out of the 4 walls of the room. We will have to show them laboratory, library, workshop, industrial tours, and practical experiment. And it will come only through by getting out of the 4 walls of the school room or college room. And now 6 hours training or 6 hour teaching is not enough. We will have to invest more than 6 hours in a day to be an effective teacher. So we have to be a change agent. If we want to be a change agent, we will have to apply rule of 246. Knowledge between the 2 cover page, knowledge beyond the 4 walls of the classroom, and working more than 6 hours in a day, and especially by developing our different way of teaching. Make a difference in student lives by make them feel they are safe, secure, and special when you are in the classroom. Friends, out of our teaching profession, हमारा जो ये शिक्षक का व्यवसाय है, इसको बात करते हुए, there are few things in the world कि जिसको बच्चे को देना चाहिए. Honestly speaking, I am the counseling profession since last 12.5 years. मुझे लगता है today's youth are required huge amount of counseling by the professor. If you want to sustain this industry or the customer of our industry, we have to make them counseling, and especially in the self-esteem part. Self-esteem part has been broken down. You will also agree with me if you are in the live touch with the today's youth. उसका खुद का self esteem का मतलब मैं करता हूं खुद के बारे में खुद की सोच. The way the gentleman is thinking about himself or herself is almost zero. It has been broken down. When you are as a teacher, as a professor, we are in the class, our students should feel that I'm safe, since it is concerned with the future and job and career. I'm safe hand, I'm in the safe hand, secure hand, and I'm something special. There is one rule of the nature जो हमारे घर में नहीं है वो हम बाहर ढूंढने जाते हैं. The things which are not either available at ourselves or at our place, we will borrow from the outside. If today's youth is not getting the money, today's youth is not getting the respect, love, they will search outside. And result, as a part of result, students are getting the misguided advice, and finally they are not on the right track on which they should be. Number 2, make positive influence in the life of the students. Friends, I personally believe values are very important rather than percentage and all. If you want to build a nation, if we want, and we are the only last hope that we can do something change in time to come. And for that matter, there was one saint, Pramukh Swami Maharaj. प्रमुख स्वामी महाराज गुजरात में बीएपीएस संस्था के स्थापक, और वो बताते थे बच्चों की हाजिरी में बड़ों का बिहेवियर बच्चों के लिए शिक्षण होता है. द बिहेवियर ऑफ एनी पेरेंट is an education for the child. Behavior of the parent, the same thing is applicable to our profession. We have to make the positive influence. उसके ऊपर हमारा प्रभाव बनेगा. कैसे? By being a change agent. यदि हम किसी श्रेष्ठ परिणाम की अपेक्षा करते हैं तो हमको काम करने का तरीका बदलना पड़ेगा. यदि वही तरीके से हम काम करते रहेंगे तो परिणाम कभी नहीं बदलेगा. परिणाम बदलना चाहते हैं, आने वाली कल बदलना चाहते हैं, हमको आज का जो प्रयत्न है वो प्रयत्न बदलना पड़ेगा. एंड लास्ट वन, दैट इज ट्राइंग टू अंडरस्टैंड द सोशल, फाइनेंशियल एंड इमोशनल स्टेट ऑफ माइंड. जैसे कि मैंने बताया दोस्तों, every human being, every individual have their own problem, own challenges in the life. Everybody has their own. किसी के पास पैसा है तो इमोशन नहीं है, किसी के पास इमोशन है तो पैसा नहीं, किसी के पास दोनों है तो और कुछ प्रॉब्लम्स है. We don't know what is the social background, cultural background, financial background and emotional background of our student. Friends, there is lots of students are there in this world. They know which is the problem of this my child, this is my student. And यहाँ पे मुझे जगदीश सिंह की याद आती है. जिस्म की बात नहीं थी उनके दिल तक जाना था. जिस्म की बात नहीं थी यारो उसके दिल तक जाना था. इतनी लंबी दूरी तय करने में वक्त तो लगता है. And for that matter we have to be a change agent. तो दूसरा महाव्रत है बी ए चेंज एजेंट. तीसरा महाव्रत के ऊपर हम बात को आगे बढ़ाते हुए, बी ए पावर हाउस ऑफ द पॉजिटिविटी. बी ए पावर हाउस ऑफ द पॉजिटिविटी. Youth is frustrated due to various reasons. Today's youth is frustrated. Reasons are many, and numbers of reasons are there. If we go and if we delayer the reasons, मुझे लगता है शायद हमारा 2 कलाक का काम यहाँ पर ही समय पूर्ण हो जाएगा. And for that matter, let us not go in the reasons, but there is a lots of various reasons. Because of that, today's youth is frustrated. Friends, since it is concerned with the psychological state of mind, first that is the worry, जिसको हम कहते हैं चिंता. This is the first state of mind. If worry increases, the second stage of mind, and that is stress. If stress is also managed very nicely, it's okay. Otherwise, this stress will get converted into frustration, and this frustration is known as a chidchidapan. And uncontrolled frustration will get converted into depression, and this depression is very dangerous. And last, that is the suicide. So these are the different state of mind. Today's most of the youth is frustrated. They are frustrated with the parents, they are frustrated with the system, and number of reason is there. And in that matter, just to manage this frustrated youth, we have to be a positive power of positivity. Every coin has two sides, and the same way we have to show them the lighter side of the any event and the society and the world. Every day is a special day, really mean it. Friends, मैं आपको बताऊं, honestly speaking, you cannot take a bath in the same river. मुझे लगता है I will have to speak in Hindi because this is thought from Osho Rajneesh. आप किसी एक नदी में 2 बार स्नान नहीं कर सकते. Because जब आप कल स्नान करने गए थे, उस वक्त जो गंगा जी थी, जो नर्मदा जी थी, जब आप दूसरे दिन वहां पे स्नान करने जाते हैं, वो नदी तो आगे बहुत चली गई, आज एक नई नित्य नदी आपके सामने है. You can take the bath on the same bank of the river. आप एक ही किनारे पे 2 बार स्नान कर सकते हो, एक ही नदी में 2 बार स्नान नहीं कर सकते. In the same way, you can live your day once only. चाहे आप सिंगल चेक से, एक ही चेक से अदानी, अंबानी और इलोन मस्क को परचेज कर सके, इतने पैसा वाले भी बन जाए, आपका बीता हुआ कल आप कभी परचेज नहीं कर पाएंगे. And for that matter, every day is a special day. Really mean it. This moment is my life. Normally what we do, what is our state of mind? Normally, we are thinking about the past, pain of the past or worry of the future. भूतकाल की पीड़ा और भविष्य की चिंता के बीच में हम पेंडुलम की तरह इधर उधर करते रहते हैं. If we have to be the real mentor of our student, we have to live in today. And this today, that is the present tense. Every day is a special day. Really mean it. Because if we are not working today, if I am not working today, तो मैं किसके साथ अन्याय कर रहा हूं? समाज के साथ या मेरे खुद के साथ? मेरे खुद के साथ. Because there is this is the only one gift from the Almighty. It is limited, and unfortunately we don't know how much it is. This is the only one gift from Almighty. यदि एक दिन चला गया तो हमारे पास दूसरा दिन की यानी कि गए हुए की यादों के अलावा कुछ नहीं बचता है. रात गई और सुबह हुआ तो एक ताजा गम हुआ. रात गई और सुबह हुआ तो एक ताजा गम हुआ. अफसोस हमें ये हुआ जिंदगी का दिन एक कम हुआ. And for that matter, friends, every day is a special day. Really mean it. Spread the positivity by smiling. And I personally believe smile is a very infective. It is very contagious. If I smile at you, we'll definitely smile. There is a fast infection as compared to even COVID. Leave all your worries outside the campus. When I am in my studio, when I am on the stage, nobody can touch my state of mind. I am a teacher, and I am teacher. When I am on the stage, I am everything. Masking all your frustration, stress and anger. क्या फर्क पड़ता है कि आज मैंने खाना खाया नहीं खाया? आपको 3 बजे से 15 मिनट से लेके 5 बजे की 15 मिनट आपको बेस्ट देना है, आपको बेस्ट लेना है. मेरी खुद की प्रॉब्लम खुद की है. My own problem, that is my own problem. Whether I have consumed the food before I started my lecture or not, you are less concerned. At the same way, if I am in frustration, I am in stress, I am angry because of my n number of reasons, what the student has to take from this? Student want your best. आपका शेयर बाजार में पैसा डूब गया, सर, that is your lookout. परेश जी, आपकी तबीयत अच्छी नहीं है, आप छोड़ देते, लेकिन आए क्यों हो? If you are there, you have to give the best. Mask all your frustration, stress, anger, if you want to spread the positivity and not allowing others, people spreading negativity. ऐसा भी होगा. If you are trying to spread the happiness, if a professor and a teacher who is trying to spread the happiness will be definitely popular in the student, तो और भी लोग आएंगे, और भी प्रोफेसर लोग, they will spread the negativity, they may spread the negativity. Let us hope कि ऐसा ना हो, लेकिन ये संसार है और definitely there will be a 3 kind of person. Once again, there is some bifurcation as per my knowledge. One is a PC, problem creator. Second is a PL, problem lover, and very small part is PS, problem solver. Problem lover or problem creator may create some negativity. They may spread distance, maintain a distance with those people. तो तीसरा महाव्रत, be a powerhouse of the positivity. And always remember, ये मैंने already बात बता दी, it's a contagious. Fourth, and that is very important, personal touch. Friends, I personally believe and I have experience even. If you ask any person by name only, just give the personal touch by speaking speaking his or her name. Baat khatam. Honestly speaking, don't try to give the answer, but just ask ourselves, how many students I address them by their name. Hey bacha, idhar aao. Yes, gentlemen. We are used to give them respect by speaking this gentleman. But if we give them the personal touch by speaking their name, it will give a personal reply. This is the fun part and absolutely required to be an effective teacher by understanding their psychology. Get to know the interest of your student and find the ways to connect with them. What is the interest of it? If you will talk about the education, if you will talk about the music, and if you will talk about the Srimad Bhagavad Gita, this is my interest. This is my interest. आप इस सब्जेक्ट पे बात करेंगे, then I will be more connected. I will be definitely connected, or fast I will connect with you. But if you will talk about the finance, if you will talk about the bureaucracy, if you will talk about the stock market, तो मुझे बोलेंगे हाँ हाँ आपका रिस्पेक्ट के लिए हाँ हाँ कर दूंगा, but there will not be any bonding, because my interest is music, my interest is reading, my interest in teaching, education, policy. If we know what is the interest area of my student, whether it's a games, whether it is a reading, whatever it is, try to get the interest. What is the interest? और यदि कोई इंटरेस्ट नहीं है, try to ignite that interest. Try to ignite. मैंने मेरी लाइफ में ऐसे बहुत से स्टूडेंट को कुछ बुक पढ़ने के लिए दिया हो, मैं कुछ दिन के लिए follow up, I do follow up. I have given you a book and have you read it? Maybe student maybe lie. Yes, I have gone through. Then I used to ask them, come back by tomorrow with the book and we will discuss on that book. Then by default he has to read this. And once he's getting the taste of this reading, once he's getting the taste of this music, believe me friends, then he will connect. He will be having the strong bonding with you. Get to know the learning style. Everyone is unique in nature. There are 5 kind of learning styles that you know as a teaching professional. You must be knowing that kinesthetic way of learning, interversal way of learning. So there is a 5 kind of learning styles is there. Everybody is. मेरी एक स्कूल है अहमदाबाद में. तो एक बार once I was there in a parent teacher meeting. A parent came to them. और एक नई टीचर हमारे पास आई थी. She was recently joined our school in Ahmedabad. So a teacher complained that why my son has got less marks in the test. Why my son has got the less marks in the latest state test. So teacher talk with the philosophy. टीचर ने फिलोसॉफी से बात किया. देखो मैम, हम तो सभी बच्चे को एक ही पढ़ाते हैं. मतलब we are used to teach all the students in the same manner. There is a few student in our class who is getting more than 90 marks. Your son is little bit weak in this subject. What we can do? End of the day, I call them in my chamber and I ask her, Madam, आज आप बोल रहे थे? Yes, sir. How can I say I am teaching with the same way? Then I told her, this is the wrong perception. आप सभी बच्चों को एक ही तरीके से पढ़ा नहीं सकते, यही प्रॉब्लम है। Because all individual has their own unique style of learning. यदि 60 बच्चे हैं, 60 बच्चे को सिर्फ एक ही तरीके से पढ़ाएंगे, नहीं पढ़ेंगे। We will have to understand. और यदि ये पर्सनल टच दे दिया, believe me friends, irrespective of your power, position and your experience, you will enjoy the state of mind. आप अपने दिमागी मजा को, वो जो state of mind, you will enjoy this. Give the personal touch to your student and address them with the name. If it is possible, try to get to know about the condition of their parents, intellectual condition, financial, social, cultural background. There is one college in Bhavnagar district, Lok Bharati Sanasra. ये बुनियादी शाला है. There was one guru called Manu Bhai Pancholi. He was used to know, or he was used to even know the mama, uncle, maternal uncle of that student, even that what his maternal uncle is doing. This is the bonding. This is the connect. In practical life, in today's era, it may not be possible. Avoid this point, but is try to contact their parent and talk to the parent. Make them feel free to share their problem, feeling, and frustration. Friends, honestly speaking, with due respect to all the parents, nowadays, instead of parenting, there is over parenting. जब से ये parenting का विचार एक शुरू हुआ है, from the day where this parenting concept has been established, instead of doing the respectable or responsible parenting, एक जवाबदार parenting की जगह पे over parenting has been taken place. And as a result of this over parenting, now parents are facing lots of problems. Honestly speaking, now the family or number of family members is reducing day by day. It is reducing, excepting barring few families. जब nucleus family बन गया है, there are only 3 members, electron, proton and neutron. And there is a over parenting, over expectations from the parents. And because of that, that's ati sarvatra varjayet. Anything which is excess, it is poison. जे पोषतु तेज मारतु एवो क्रम दिसे छे कुदरती. शायद मैंने गुजराती में टुकड़ा बोल दिया, लेकिन हमारे गुजरात के बहुत ही बड़े उमाशंकर जोशी करके एक साहित्यकार हुए थे, उसका ये वर्ड है, एनीथिंग व्हिच इज एक्सेस इट इज पॉइजन. और संस्कृत में यही बात हमको मिलती है, अति सर्वत्र वर्जयेत. Because of the over parenting, now parents are getting the problem. They have some feeling, they have negative feeling, they have problem. They want to share with the reliable person. If we can connect with them, we can give the personal touch. And if we can give the personal touch, believe me friend, we can enjoy this profession. We can enjoy this profession. ये मेरा पूरा का पूरा end of the crux of the entire presentation is only one: how we can enjoy ourselves, our profession. This is the way we can enjoy. Otherwise, what will happen, you know, friends? End of the career, अंदर से कुछ नहीं करने का दर्द होगा, और वो दर्द को बाद में हम इसको रिपेयर नहीं कर पाएंगे, बाद में इसका सॉल्यूशन कुछ दर्द के साथ जीना पड़ेगा. At the same time, share your struggle, achievements and activities. with your students. Friends, in today's era, we have to make them understood how we can manage the failure. There is n number of motivational students. I am not a motivational student, honestly speaking. You will never listen a motivational speaker as a motivational speaker. I am a soft skill trainer. I am not a motivational trainer, because motivational trainers always says there is a moon and you can go. You have to go, you can do it. But motivation is temporary and soft skill is permanent. If somebody says as a motivational trainer कि जो बेटा वहां चांद है आपको जाना चाहिए, तो मैं कहता हूं बच्चा इतना इतना और इतना कर, शायद तो चांद पे पहुंच जाएगा. Make the change in the behavior, not in the thought process. Friends, lots of frustration is there in the today's mind, today's youth, and we have to understand that, because student is comparing themselves with the best in the world. All the motivational trainers are, you can do it, blah blah blah. यहाँ के जोर जोर से बोलते, अरे जोर से बोलने से असत्य सत्य नहीं हो जाता. अरे जोर से बोलने से इंसान का बिहेवियर नहीं बदल सकता, और बदलता है तो भी if it gets changed, it is temporary. But if you change the thought process and if you change the working pattern, you can make the positive change and that will be remain for the long time. So friends, try to make them and try to understand or try to manage them. Try to manage failure. आजकल ये क्लास होना चाहिए, निष्फलता को कैसे डाइजेस्ट करना चाहिए, how we can digest our failure. Number 5, that is give your best, give your 100% or more than 100%. Friends, if I am giving you the lecture, if I am delivering the lecture at any place, I am with myself. I am with myself. When I am on the stage, एक बार मैंने, there is a lots of Gujarati singers are there, and nowadays they are very much popular. Nowadays they are very much popular. तो एक हमारे गुजरात के बहुत बड़े प्रख्यात एक गायक कलाकार है ओस्मान मीर साहब, जिसने वो संजय लीला भंसाली के गीत में मन मोर बनी थनगाट करके बहुत से हिंदी प्ले पे भी गाए हैं. वो जब स्टेज पे अपना परफॉर्मेंस दे, व्हेन ही इज परफॉर्मिंग ऑन स्टेज, पीपल आर डांसिंग, शाउटिंग, they are throwing some money on them. Once when I asked him once, don't you get disturbed? आपका सुर कभी नहीं टूटता है, आपका ताल कभी टूटना है, what is the secret? And he has replied me very nicely. He has given me a very good, perfect answer. When we are traveling in our car, हम जब अपनी कार में मुसाफरी प्रवास करते हैं, कार के सभी बारी यानी कि उसकी जो विंडो ग्लास है वो हम बंद कर देते हैं, और यदि अंदर कोई छोटी सी मक्खी भी आ जाती है, हम ट्रैवल करते हैं 100 की स्पीड से हमारी कार चलती है, तो मक्खी पीछे वाले ग्लास से कभी टकराती नहीं, क्योंकि वो अपना एक नया वातावरण पैदा कर लेती. He is creating his own atmosphere. In the same way, when I am on the stage, I am creating my own atmosphere. Same if we apply in our profession, when I am on the stage, I am giving my best by not getting the disturbed with the outside influences. We can give our best. Do your job for love of teaching, not because you feel obliged to do. At the same time, do it for the self growth, soul satisfaction. बहुत ही दर्द के साथ, with very high amount of pain. Friends, I would like to share one thing. I have asked many I have asked a question to many professors and students. मैंने बहुत से ऐसे गुरु को एक सवाल पे पूछा है कि टीचर इज ऑलवेज स्टूडेंट, राइट और रॉन्ग? टीचर इज अ लाइफ टाइम स्टूडेंट, राइट और रॉन्ग? और उसने हर बार बोला है यस जेंटलमैन, यू आर राइट, टीचर इज अ लाइफ टाइम स्टूडेंट. वेरी गुड, एक्सेप्टेबल. When I asked them where is next question, दूसरा सवाल जब मैंने पूछा, sir can you tell me what you have learned with intention, सीखने के वजह से, with the intention to learn what you are doing the activity on the regular basis, उसके पास कुछ अपना जवाब नहीं था. उसके पास कोई ठोस आंसर नहीं था. सीखने के नजरिए से आप ऐसी कौन सी प्रवृत्ति, ऐसी कौन सी एक्टिविटी करते हो, which are the activity normally you do with the intention to learn something new? And there was no any strong answer. They bluff. Do for the self growth, self satisfaction. Friends, irrespective, rightly I am repeating this statement, irrespective of our power, position and experience, we are answerable to ourselves. We have to answer, we have to reply to our inner soul that I am justifying my work, and if answer is yes, बहुत बहुत अभिनंदन. And do it to inspire other teachers. तो पांचवा महाव्रत है, और महाव्रत है give your best. Never give up, trust to your best. This is the something. Stay organized. इसमें मैंने ज्यादा बातें नहीं लिखी है, इंटेंशनली नहीं लिखी है. Stay organized, because a person who is not organized in his life will be like a kati patang. And you know very well that kati patang don't have the control on himself. Kati patang is going in that direction in which wind is directing them or wind bring them. जिस दिशा से पवन आएगा उसी दिशा में उसको जाना पड़ेगा. Stay organized, plan your day and stick to it. This is something like time management, or all gurus are not required to give some tips about the time management. But definitely, it is very important that we have to be on time. 7th Mahavrat, and that is open-minded. This is not the philosophy, this is the real, this should be the reality. We have to accept new changes. Friends, after this, online education has been taken place. I have designed a training module that is called Science of Online Teaching. We will be also passing through in day by day about the online teaching. I have asked many teachers and professors. Honestly speaking, in Gujarat, I am a consultant with the 2 universities and 18 self-finance engineering colleges. So I have come across a number of professors and teachers in last 2 years to educate them about this my new training module, and that is Science of Online Teaching. I normally ask a simple formal question. क्या लगता है ऑनलाइन टीचिंग असरकारक है? What you feel, whether it is effective or not? And friends, honestly speaking, more than 95% आंसर आता है नहीं सर, इसमें हम ह्यूमन टच नहीं दे पाते हैं. We are not in position to give the human touch. Friends, honestly speaking, बताओ मुझे, आप जब मूवी देखने जाते हो, हम जब जाते हैं, वहां कोई ऐसा करुण दृश्य होता है, any sentimental scene is there, are we getting sentiment, are we getting senti or not? Some people are also crying with that. They are floating with the flow. They are floating. They are crying. This is also something like online teaching. This is also something like online teaching. It is a real आभासी दुनिया में हमको ले जाते हैं. If we accept this, और एक बात यहाँ नहीं है, फिर भी मैं आपको बताऊं, स्ट्रेस मैनेजमेंट का एक नया फंडा. किसी भी चीज को हम स्वीकृत करते, if we accept anything on the very as it is as fast as possible, you will be stress free. The moment you accept, this is the future, this is my career, this is my bread and butter, this is my roti sabji, believe me, you will accept it. We have to accept the change very fast. 95% of the teacher and professor have replied me, sir, we cannot give the human touch, we cannot give the emotional touch. Thing is only one, we have to learn how to give the emotional touch. इसका मतलब ये हुआ, हम इमोशनल टच नहीं दे पाते, वो अलग बात है. हम अभी तक इमोशनल टच देना सीख रहे हैं या अभी तक सीखे नहीं है. We have to be open minded, we have to accept it. Friends, you are constantly observed and evaluated by the students, parents, management and other competitors. I am also in the same profession. We are continuously observed and evaluated by our students, parents, also management and our competitors. We are on that position where others want to grab that position, and for that matter give your 100%. Be open-minded while receiving the constructive criticism and plan of action. Form a plan of action. Friends, there is one sentence in Gujarati, but I will have to communicate in English. When we are eager to speak, we cannot listen. આપણે સંભળાવી દેવાના મૂડમાં હોય ત્યારે સાંભળી શકતા નથી. ये गुजराती में मैंने बोला, अब हिंदी करता हूं. जब हम सुनाने के मूड में होते हैं, दूसरों को सुनाने के मूड में होते हैं, तब हमारी श्रवण शक्ति शून्य हो जाती है. एंड इंग्लिश में when we are eager to speak something, we cannot listen. Be very open-minded while receiving the constructive criticism. Accept it. और स्टीफन कवी ने बताया है, normally we listen the any person with intention to reply, not the intention to understand. This is the statement from Stephen Covey. Normally we listen anybody with the intention to reply. Rather reply, it is justified. We listen with intention to justify our act. But try to accept the constructive criticism and try to make ourselves more shining, more sparkle, and accept the change that is the fit, fast and fresh. Darwin has told fittest will survive, but I personally believe now fittest and fastest will survive. Darwin के उत्क्रांतिवाद में the law of revolution has told now fittest will survive. ये जंगल राज की बात है. अभी ये जंगल राज से कुछ और है. And in today's era, fittest and fastest will survive. If you are fit, but if you are not in position to accept the fact and change yourself or mold yourself in today's era, you will be out of the date, outdated person. You have to accept new era, new style of working, new style of thinking. लोग कहते हैं old is gold. All old is not gold. हर एक पुरानी चीजें गोल्ड नहीं हो सकती. पेरेंटिंग करना, this is old is gold, done. लेकिन पेरेंटिंग स्टाइल इट चेंजेस फ्रॉम पर्सन टू पर्सन. When I was searching the job in 1994, 1993, there was word, sir, I am perfect in time management. Now time management is out. Task management has entered. If you look at it from the aerial view, time management is grounded in your normal condition. It is grounded condition. Time management is out. Now, friend, task management has entered. Customer satisfaction is out. Customer satisfaction to chahiye. Customer delight has entered. It has been replaced. Customer satisfaction is out. Customer delight has entered. What you can give more than the expectations. Result orientation is out. Revenue generation has entered. These are the new era to become the fast, fresh, and fit. We have to accept. Mahabharat number 8. Set your own standard. Set your own standard. मतलब मैं हूं तो इतना बेस मिनिमम तो डिलीवर होना ही चाहिए. If I am there, these are the basics. Set the standard of your own, and also student from the beginning. I personally believe कोई बच्चे होते, कोई स्टूडेंट्स होते हैं, सॉरी मेरी गलती हो गई, कोई टीचर्स होते हैं, प्रोफेसर होते हैं, कंप्लेन करते हैं. दे आर ऑलवेज इन कंप्लेनिंग मोड. ये सब कुछ बदल गए हैं, बिगड़ गए हैं. बिलीव मी फ्रेंड्स, आज हम जिसको पढ़ा रहे हैं ना, वो बिगड़ी हुई फसल नहीं है, वो बदली हुई फसल है. ये बदली हुई फसल, द जनरेशन, इट इज नॉट स्पॉइल्ड, इट इज चेंज. आप बगड़ी गेला નથી, આ બદલાઈ गेला છે. And we have to deal with this change mentality people. Set the standard of your own, and also expectation alignment जिसको हम कहते हैं. Expectation alignment. Whether it is in classroom, in your workshop, in your laboratory, wherever, it is in library. And this expectation alignment may be time management, safety management, commitment, whatever it is. Set the standard, and from the expect a lot if you can give a lot. आपको अपेक्षा करना, श्रीमद् भगवद गीता में भगवान ने कहा है, कर्मण्यवाधिकारस्तेषु मा फलेषु कदाचन. मैं कहता हूं, यदि आपने बेस्ट दिया है तो बेस्ट की अपेक्षा कर सकते हो, बट कंडीशन है, एक्सपेक्ट ए लॉट इफ यू हैव गिवन a lot. You have a best. And your dressing and body language, set the standard. Friends, as I told, 55% effect is there on the mindset of our crowd is body language. मुझे लगता है कि इस दिशा में काम करने की बहुत आवश्यकता है. And today's youth, new generation, they are very sharp. They are very sharp. They will judge you when we enter. They will judge how we enter in the class. The moment we enter in the class and start our lecture, वो समझ जाएंगे, हाँ आज मजा आएगा और आज मजा नहीं आएगा. And at the same time dressing, please set all the standards. This all should be very, very perfect and very standardized. महाभारत नंबर 9, हम करीबन हमारे कार्यक्रम की उत्तरार्ध की ओर आ गए हैं. Find your own inspiration. An effective teacher is one who is creative, but it does not that every time you have to create from your research and your start from the stretch. Yadi, if we want to be the powerhouse, we are also required some power. Learn from the others every time. At the age of 50 years, even today, we are attending this kind of. मैं आपको बहुत बहुत साधुवाद देता हूँ. I congratulate all of you that you have participated in such kind of knowledge brushing, knowledge sparkling training program, and you have got something. Definitely, we are getting something. See, friends, I personally believe everything is here in between 2 years. Everything is here. If we consider, okay, यार ऐसे 11 महाव्रत है और वो तो कोई बोल सकता है, it's okay. There is nothing for you. It is just spoil of 2 hours from your life. And if you listen me very carefully, you will get definitely something. It depends on our mindset. It is up to us whether what we are going to take away from this training session. An effective teacher is one who is creative. But it does not mean that every time you have to create from the scratch. You have to learn from the others. We should also have some our own inspiration. Find the inspiration from as many as sources you can, like books, education, Pinterest, YouTube, blogs, also from your mentor, your guru. Update yourself. Mahabharat number 10, that is hug the change. परिवर्तनता हो सके इतना, शायद आपको इसको रिपीट भी आपको ऐसा लगेगा कि बी द चेंज एजेंट, और यहाँ पे आपको वही दिखाई पड़ेगा हग द चेंज. लेकिन यदि इसको पारदर्शी रूप से देखा जाए, फिर लुक एट फ्रॉम द डिफरेंट एंगल, देयर इज सम चेंज, देयर इज सम डिफरेंस. थिंग डज नॉट ऑलवेज गो अकॉर्डिंग टू द प्लान. Every day, every time, everything is not going to be as per our plan. और यदि ये प्लान के हिसाब से ही जाता तो मुझे लगता है कि हर एक कोई इंसान टू डू लिस्ट को एंड ऑफ द डे 100% काम होता होगा. लेकिन ऑनेस्टली स्पीकिंग, देयर इज वन सर्वे. इफ यू प्रिपेयर ए टू डू लिस्ट, if you can complete 80% of your to do list, you are a very perfect time manager. You cannot manage 100% of your to-do list. Be very flexible and go with the flow when change occurs. Don't try to swim against the flow. The entire world is switching to the online education. And believe me, friends, I personally believe now there will be the 3 types of education: offline, online, and self-learning. यानी कि प्रोजेक्ट बेस्ड लर्निंग. बी वेरी फ्लेक्सिबल एंड गो विद द फ्लो व्हेन चेंज इज हैपनिंग. जब परिवर्तन होता है, उस परिवर्तन के सामने नहीं आते हुए वो परिवर्तन के साथ अपने आप को जोड़ देना चाहिए. दिस इज द वेरी मैच्योर्ड एक्ट. एन इफेक्टिव टीचर नेवर कंप्लेन्स अबाउट एनी चेंजेस हैपन विद द सिस्टम. और याद करना बहुत सहज है. यू कैन डेफिनेटली मेक द कंप्लेंट कि सर ये हमको अच्छा नहीं लगेगा. एज एन एम्प्लॉय, ओके, यू मे बी राइट, बट एज अ टीचर, once again we have to think. As a teacher, I am in position to accept the change. When I am considering myself as a guru, I have to accept the change very fast, and rest my student will others will follow me. An effective teacher never complains. और believe me, change अच्छा है. There is one advertisement in the television, दाग अच्छे है. In the same way, change is always good. Instead of criticizing the change, hug it with open arms and show that you are capable of hitting every cow's ball that comes in your way. Instead of criticizing the change, ये अभी कहाँ आ गया? I have listened lot many teachers, primary teachers especially in Gujarat. A CCC के exam. अबे how we can conduct? We don't know. Since last 25 years, we are working as a teacher, and we don't know what is computer, how we can operate. Now government has told us that we have to pass CCC exam. Why you are criticizing? Go and learn. Almighty has given you lots and numbers of amount of intellectual properties. Go for the tuition. Invest 2,000 rupees. Learn from the word that tabariya. वो छोटा बच्चा है, सीख लो इससे and appear for the exam. If a 10th standard 2 student gets appear for this exam, they can. Why to criticize? Instead of criticizing the change, hug it with the open arms. खुले बाहों से आजा दोस्त, तू भी आजा, तेरे साथ भी मेरी यारी दोस्ती बना लेंगे. And show that you are capable of hitting every curve ball that comes in your way. चाहे तू कितना भी स्विंग और बॉलिंग कर ले, मैं हिट करूंगा. I will hit you. And this is nothing but the state of mind. This is nothing but the state of mind. Friends, and last, this is very important. जैसे कि मैंने बताया था ना, छठे नंबर पे ऑर्गेनाइज, ये इंपॉर्टेंट नहीं है बिकॉज यू नो, लेकिन ये उससे उल्टा है. दिस इज वेरी इंपॉर्टेंट. क्रिएट योर ओन रेप्लिका. खुद की प्रतिकृति. मैं ऐसा एक स्पष्ट रूप से मानता हूं, टीचर कभी मृत्यु नहीं दे, कि टीचर का कभी मृत्यु नहीं होता. उसका नाशवान शरीर जा सकता है, लेकिन उसकी सोच उसके स्टूडेंट में आज भी जिंदा रहती है. उसके स्टूडेंट में टीचर का कभी मृत्यु नहीं हो सकता, क्योंकि टीचर नहीं, टीचर का शरीर मरता है, अंदर का टीचर आज भी उसके स्टूडेंट में जिंदा रहता है. और इसीलिए मैं आज बात बताऊंगा दोस्तों, पूरा का पूरा स्लाइड ओपन कर देता हूं. ए गुड टीचर नेवर डाइज. ही इज गेटिंग स्प्रेडेड आउट इन स्टूडेंट्स. ये मेरी लास्ट स्लाइड है दोस्तों. मैं यहाँ पे बात बताऊंगा नॉमिनी की. इस दुनिया में किसी भी इंसान के दो प्रकार के वारसदार होते हैं, नॉमिनी होते हैं. फर्स्ट, दैट इज लीगल नॉमिनी. हमारे पंचमहाभूत के शरीर से पैदा हुआ दूसरा एक शरीर, जिसको हम कहते हैं बायोलॉजिकल नॉमिनी. एंड दिस बायोलॉजिकल नॉमिनी इज गेटिंग द फिजिकल प्रॉपर्टी ऑफ आवर सेल्फ. Physical property of ourself. When we will leave this world, हमारा बायोलॉजिकल नॉमिनी जो भी होगा, उसको हमारी लाखों करोड़ों की जायदाद मिल जाएगी. दूसरा है साइकोलॉजिकल नॉमिनी. साइकोलॉजिकल नॉमिनी मतलब परेश भट्ट आज जिस प्रकार से ट्रेनिंग कर रहा है, वो ट्रेनिंग की स्किल कहां पे होगी, जो आज मेरी बैग उठा के मेरे साथ घूम रहा है. My son is a chemical engineer. He is not in the teaching profession. He is not a trainer. So after getting departure from this world, where Paresh Bhatt will be alive, he'll be alive in his new teachers or professors or trainers who are coming in the same profession. We have to create our psychological nominee. हम किसी के दिल में, किसी के दिमाग में जिंदा रहने चाहिए. एंड फॉर दैट मैटर आई ऑलवेज यूज्ड टू से क्रिएट योर ओन रेप्लिका. आज भी मैं कहता हूं, कोई प्रोफेसर ऐसे है, कोई मेरे गुरु ट्रेनर्स ऐसे है, जिसका एहसास मुझे होता है कि शायद ये विचार, ये वे ऑफ डिलीवरिंग माय लेक्चर दैट आई हैव लर्न और आई हैव अर्न फ्रॉम देम, वो आज भी मेरी काम में कहीं न कहीं दिखाई दे रहा है. कौन कहता है रफी साहब चले गए? आज भी रफी साहब जिंदा है. वॉइस ऑफ रफी को सुन लो. कौन कहते हैं मुकेश जी चले गए? आज भी मुकेश जी जिंदा है. और कौन कहता है मेरे एपीजे अब्दुल कलाम चले गए? आज भी वो इसरो के वो अधिकारी में अंदर आज भी जिंदा रहते हैं, जिसके दिल में वो राष्ट्रपति. क्रिएट योर ओन रेप्लिका. दिस इज द ओनली प्रोफेशन फ्रेंड्स. एज अ टीचर, दिस इज द ओनली प्रोफेशन where you can earn 11 types of respect and satisfaction of our inner soul. This is the only profession. This is the only profession. And for that matter, today, it was my privilege, it is my happiness that I have delivered a lecture, 11 vows to be an effective teacher. એક અસરકારક શિક્ષક બનવા માટેના 11 મહાવ્રતો. ये 11 महाव्रत 11 मैंने इसीलिए लिया है बिकॉज माय गांधी, पूज्य महात्मा गांधी के 11 मनोरथ किए थे. सत्य, अहिंसा, चोरी न करवी, अपरिग्रह, वणजोतु न संकर हूं, ब्रह्मचर्य ने जाते महन. ये जो उसने 11 प्रकार के 11 महाव्रत दिए थे, उसको केंद्र में रखते हुए इस 11 महाव्रत 11 vows today I have delivered in my lecture. I'm sure there is some I would have been tried. I have tried to touch the heart and soul of yourself, and I'm sure it would have been create a good impact in your thought process, also in your act. Thank you very much, friends. So nice of you. Now, last 10 minutes are there, and if you want to go for the open session or if you want to talk, you can. Thank you very much, and God bless.
Thank you so much, sir. I request and invite participants to please join the conversation with Parag, sir.
Paresh.
Sir, good afternoon, sir.
Yes, sorry, Paresh, sir.
Sir, good afternoon, sir.
Good afternoon. Who is there?
My name is R.S. Kiran. I'm calling from Visakhapatnam.
Okay.
Yeah. Do you have any relevant book by which I can improve the knowledge that has been shared by you? आपने आज जो पढ़ा है उसके बारे में मुझे और भी जानकारी दी, उसके लिए कोई किताब है सर?
सर किताब तो नहीं है, लेकिन ये पावर पॉइंट प्रेजेंटेशन में आपको मेल कर सकता हूँ सर.
जी सर, थैंक यू सर. यस
डेफिनेटली. आप कैसे करेंगे, मैं आपको किस प्रकार से दे पाऊंगा वो जरा आप बता देना.
हाँ, मैं ईमेल कर देता हूँ सर आपको.
हाँ, मेरा ईमेल या फिर मेरा मोबाइल नंबर या मेरा ईमेल है, तो आप मुझे मेल कर देना. डेफिनेटली.
परेश भाई,
देखो ऐसा है,
परेश भाई, you can send to
जी,
me.
sir.
I will circulate it in WhatsApp group to all participants.
That's great. तो सभी के लिए वो प्राप्त हो जाएगा. आप मोदी साहब बोल रहे हैं ना सर?
Yes.
Sure, I will definitely send it.
Yes sir. Thank you. Thanks a lot, sir. Thank you.
Yes, any other participant would like to join the conversation, will ask something from sir.
Hello, I was disconnected due to network connectivity. So can you repeat the question if somebody has asked the question?
No, sir, nobody has asked the question, but I was
Okay.
asking them to ask.
Okay, got it.
I think as you have told that you will be sharing the slides, many of the participants must be thinking that they will again refresh what you have spoken in each slide. Truly, sir, it's very hard to express this session in few words. I cannot even express because I'm not so well in expressing. But truly, each and every slide gave a motivation and a feel about being a teacher. Today, I think many of us minds have been ignited. I believe it was a very, very motivational lecture, sir. Thank you so much, sir. On behalf of FDP team, yeah, thank you so much, sir. On behalf of FDP team and Mechanical Engineering Department, Government Engineering College Bharuch, I truly, with my all expressions, I thank you so much, sir.
Dhanyawad. Thank you very much. Can we conclude the session?
Sure, sir.
So thank you very much, all the participants. I am very thankful and God bless you all. Be a very good teacher. आपके अंदर वो गुरु तत्व पैदा हो जाए, ऐसी मैं भगवान से प्रार्थना करता हूँ. And live the life king size. धन्यवाद. Bye bye.
Thank you, sir.